Hello, hello, hello. Good morning, good morning, good morning, everybody. Thank Hello and good morning. Sorry, I'm back. Looks like I lost my internet for a second. Welcome to the Software Architecture Conference. This is our third edition. Everybody, thank you for joining from different places. Rohit is joining us. If you are a part of C# Corner, you probably know we do this conference each year, and this is our third edition. My name is Mahesh Chand. I'm founder of C# Corner. And if you are in the software industry, which you are, we believe that software architecture is one of the most important part of building either a new software or even if you're re-architecting your existing solution, existing software, existing product. And today, with this conference, it's a 3-day conference. It's amazing. We have 30 plus speakers where you're going to learn different trends, technologies, tactics to build how to build better software, and also going to learn from these industry experts. So today we have a keynote. Our keynote is by Bill Wolff. Bill is a veteran architect. He has been building software, I would say probably 30 plus years, if I'm not wrong. Bill is going to come join us soon in a minute. And then today you're also going to learn about different architecture topics, including cloud modernization, with .NET, MongoDB, microservices. If you look at the agenda, we have amazing speakers, and many of these speakers have actually built real products for real companies. So you will learn from that. So hang tight. We're going to start in a minute. And before we bring our keynote speaker, Bill Wolff, I want to also talk about a couple of things. This conference is brought to you by C# Corner. So if you are not familiar with C# Corner, it's one of the largest and oldest communities for software developers. What we do here is our focus is just making software developers better every day. And what does that mean? That means we publish latest news, industry trends, topics, articles, blogs, videos, code samples. We do these conferences on different topics. So if you are not a part of C# Corner, check it out, csharpcorner.com. Also, this streaming is brought to you by csharp.tv. csharp.tv is our live streaming service where think of it like a Netflix for software developers. We not only stream these conferences similar to this one, but we also have almost every day there's a new podcast, live podcast on different topics. So with that said, hang tight, enjoy these 3 days of software architecture topics. Last thing I want to talk about is a little bit about AI. As you probably heard, AI is here big time. If you have not used Copilot, I highly recommend you start looking into Copilot as a part of your VS Code or Visual Studio. It's actually helping boost productivity of every developer. Either you are a young developer or you're a senior developer. You are building a new application or you're re-architecting your existing applications. Check it out, Copilot. And with that said, let me bring our keynote speaker today, Bill Wolff. Hey, Bill, good morning.
How you doing, Mahesh?
All good. Can you hear me?
Yeah.
All right, all right. Your background looks nice. Looks like you're architecting your home. Very, very nice. Um, this is our third software architecture conference, and excited to see your keynote.
Well, I'm happy to talk to the crowd. I did want to correct you, though. You said I was working in the software business for 30 years. It's been 45. So
Wow.
probably
So look at that. So
before you were
yeah,
born.
I should have said 30 times Microsoft MVP. So yeah, Bill, you are probably one of the most expert and experienced architect in the industry. Um, and a lot of people watching this conference are young guys. I'm sure there's a lot of young guys. If you have to give, before I leave you the stage, if you have to give one advice to these young kids who are trying to architect this, what would that be?
Uh, just keep learning. Uh, I'm I'm
Keep
basically
learning. There
over
you go.
45 years.
Yeah.
I'm self-taught, and I my job is to study new Microsoft technologies, figure out how they might apply, and then show others how to use them. I've been doing that for decades, and I still do that every
Awesome.
day. I
All right, guys. So there you go. Keep learning. Continuous learning is the key to growth. I agree with that. I'm a big believer in that. So with that said, Bill, I leave you to the stage with your keynote. Thank you so much.
Okay. All right. So welcome everybody. My name is Bill Wolff, and I've been a Microsoft MVP for 22 years. I actually met Mahesh in Redmond at an MVP summit, and we discovered the two of us don't live too far away, and so we've been doing community stuff together for well over 15 years. Um, I primarily worked as a contractor for my career, starting in the 80s. That was the 1980s. And I worked with lots of different technologies. I was a very early adopter of the .NET framework and SQL Server, things that I still use daily in my job. Um, about 6 months ago, I was actually considering retirement, and set some feelers out, and I got an interesting offer from a company in California named Simpson Strong Tie, and what they wanted to do is take a large suite of applications and move them from on-premise to the cloud. And I'm like, well, I know a lot about the cloud stuff. I can show you how to do that because I've done that at other clients. So what I'm going to show you today is sort of my journey discovering what they have and thinking about how to apply it to the cloud. Uh, just so everybody understands, I am primarily Microsoft focused. So all of this talk will be Azure based, but you could do the same thing in AWS or Google or some other cloud environment. So what we have at Simpson Strong Tie, what does that company do? We make connectors for the building trades. So if you have a deck, your deck is probably held together with little metal connectors with bolts in them. We manufacture all that stuff by the millions. And we also make things for commercial construction, things that would help buildings withstand hurricanes. So we have a lot of engineering and a lot of manufacturing capability. Since we sell so much of that kind of stuff, we develop software applications that the building trades can use to help sell our materials. And I'm working currently with a suite of applications that are written well over 10 years ago. They are C# based. They're written in WPF, and it's all traditional client server where they're actually talking directly to a SQL database installed on the user's machine. They don't even work in an environment where they have a central server. each person has their own SQL server and their own SQL reporting services. And you can imagine this is a bear to support and maintain. They did all of this because 10, 15 years ago, connectivity in a truss manufacturing plant was minimal. So they made it so each person could sort of work independently. We have to get the customers off that mindset and say, well, if everybody's connected, we can put it in the cloud, then everybody shares the same install, the same versions, a lot easier to support. We can optimize performance. So that was my mandate when I accepted the position. And as I mentioned here, the one application I'm working with, just one of them has 5,000 databases, and it uses the Microsoft Sync framework to synchronize within a particular customer facility. And there's just a lot of old technology. The other thing they've done is they've taken advantage of the file system. So they use the file system to store some of the design information and also documents that have to do with buildings, like code enforcement submissions. So how are we going to take all this stuff and move it to the cloud? Interesting question. Well, the easy thing, and if you do, if you attend a Microsoft demo, they'll say, here, you just make a Blazor app and make a API and you publish to the cloud. And it's like, yeah, that works real well for a simple application. But what if you're going to do this for thousands of enterprise users and you want it to be, 4 nines reliability, stuff like that? There's a lot more that goes into that. So we're going to start with the ability to convert the app. And it's sort of a natural conversion for us to go from WPF to Blazor, somewhat related technologies. And everything, of course, is written in C#. Very few things are done in JavaScript at all. For the service layer, we would use minimal APIs. I prefer those. And then we use a mix of Entity Framework and Dapper as the relational database connectivity. The databases, instead of having like 5,000 of them out at the clients, we're going to consolidate that into one multi-tenant database. And believe me, that's a hard sell to convince our business people and our customers that one database can handle this. But I've worked in other industries where that was clearly the case, could easily be done. And I've already built a proof of concept to show that this will work fine. The other thing I looked at is, well, we don't want to use the file system because they're used to just taking like reports or design files and saving them to a local share. Well, your web browser can't do that. The user has to intervene. They have to say, okay, I'll accept this download and put it in this folder. So the way to get around that is to store all the documents in the cloud. And you'd be amazed how inexpensive it is. Right now in my proof of concept, I have 3 million documents stored in Azure storage, and it's costing us about, $20 a month to store that. But something you may not be aware of, when you use Azure storage, it has something called index tags. So think of that as metadata. So each document you can put in like the GUID that associates with the database. You can put in like a category of class, what kind of document it is. And then you don't have to maintain a separate SQL table that matches to each document. You actually use Azure storage as a database, and you can query it, and the response time is just extremely impressive. The other thing, of course, we'll take advantage of is Redis caching. And Redis caching allows us to take frequently used data like lookup tables or pictures that the customer just looked at and store them in a cache because they may want to look at them 3 minutes from now. And put all that together and we can get a pretty fancy performant environment. So that is our plan. Now, as a developer, how do I set that up on my machine? Well, you could just go to Visual Studio or VS Code, say file new project, and create a new project. And that works to a point. When you get into something this large, and I didn't tell you that this is one of like 10 different applications that I'm working with, then you start to think, well, 10 applications, I bet they all need authentication. They all need document management. Then you start thinking about building a platform. So the platform becomes a set of services in Azure that is shared by multiple applications. And those services probably all are going to be API projects in some degree. Well, how are we going to get all that down to a developer's desktop so that they can actually step through the code and understand how everything works? And Microsoft invented this technology over the last year called Aspire. So I'm a big fan of Aspire, and we use that to take all the projects and the front end and have them appear in a large solution. And what happens is there's something in Aspire called a host, and the host use orchestration to load the other projects and make them so they're all discoverable between each other. Excellent technology. You should look at Aspire if you have a chance. Some of the things you would use in Aspire, like Redis, you can simulate using Docker. And the other thing that's real nice about Aspire is it has a monitoring dashboard where all the telemetry information is shown in a very visual way, very easy to use. So now we have to take, now that we built some stuff on our laptop and we're going to publish it to the web, where do we publish it? Well, there's a lot to learn in Azure, and there's books. I just, most of my information I get from Microsoft Learn and reading the documentation. But in Azure, there's a whole hierarchy that you have to understand. And depending on the size of company you're in, it's very likely you have very limited visibility to what's really going on. If you work at my level as a senior architect, they'll say, okay, Bill, you're allowed to see everything we're doing in Azure so you can help us make it better. And then you learn about things called management groups. Management groups are basically where you put individual developers and users so that they can see things in Azure. And that's sort of your top level. And then below that, they have these things called subscriptions. A subscription is tied to what's called an offer. An offer implies the cost that you're going to have. Highly recommend that you learn about dev test subscriptions. They reduce the cost so that when you're doing development and QA testing, you're not paying full charge for your database, your storage, and your event applications. Inside the subscriptions, you're then going to place resource groups. And the resource groups are basically a logical container. Think of it like a folder, or if you're a SQL person, think of it like a database. And inside there, you can have various resources. A resource would be something like a database, a website, a log, things like that. So you have to sort of understand this. Now, a lot of developers don't even need to touch this. You can have your architect, or more likely your DevOps person, set all this up for you. And then when you go to check in your source code and you do your pull request, you might have CICD in place that automatically takes your code and puts it into the correct resources so that the users can see the results. But somebody in your organization has to understand this stuff and has to embrace it. Now, where do we put our web applications? Well, typically when you see a demo, they put them in an app service. An app service is cloud native. It's a way to put a front end or a back end, your Blazor or your API. You can put them in a website, and they're attached to what's called an app service plan. An app service plan basically indicates a geographic location, and then also sort of a costing vehicle. That's one way to do it. Another way to do it is something newer called a container app. A container app actually takes your front end and sort of puts it into a Linux container and then runs from within there. It's sort of like a scaled down Kubernetes. Kubernetes is the cloud way to do containers, where Docker would be more the desktop version. So those are all different ways that you can work with. In our design, we're leaning towards container apps, and then a container app, you can scale that by adding additional containers if you get a large load for some reason. Other things to consider are using serverless coding approaches like functions or logic apps, and excellent thing for developers to learn. If you think you want to write a very complex API, eventually you'll get that done and you'll push it to the web. But if you want somebody to see sort of an example of what you're doing, make a function that sort of reads the same data from the database and returns it back. And then that you can have other developers, or you can show your business people what the data is going to look like before you actually have the full-blown API service created. So I often use functions in conjunction with container apps and when I build services. Where are we going to put the data? Well, that's a fascinating thing to learn. I said there were 5,000 databases, and that's just one of my applications. Some of the other applications have many hundreds or thousands also. So part of my job is to figure out how can we sort of, herd all of the databases into something more manageable. And Microsoft offers multiple ways to host SQL natively in Azure. They have what are called vCore subscriptions, DTU, and Hyperscale. So Hyperscale is the newest and sort of the fanciest. And then vCore has a serverless option. And the reason I bring up serverless, if you set up a development environment and you use vCore as your choice of database, then you can mark it as serverless, and you can tell it to turn off after 30 minutes of inactivity. That saves you some money. And if you're in a shop where you're only developing 8 hours a day, well, that's 40 hours out of 168 for the week. So basically you can program your database to not charge anything to your account while you're not using it. Great thing to do. So there's different ways to do this. The other thing you can do with SQL databases is you can put them in pools. There's a thing called an elastic pool. And what that does, rather than reserve a certain amount of compute and storage for a particular database, you reserve a compute and storage quota and share it across dozens of databases. And then if one is active, it takes the compute, and then it dies down, and then another one becomes active. So you have to look at sort of the trends of how you use your data to see what is going to be the best solution for you. In terms of storage, I mentioned I'm storing millions of documents already. I'm projecting in 2 or 3 years, we'll easily have 250 million documents. Not concerned about that at all. Azure is designed to handle lots more than that, but you have to sort of understand how to work with blobs. And the biggest thing I want you to study is this thing called index tags. It makes quite a difference in how fast you can access and search for a document and then download it as needed. Redis cache is, that's an industry standard used in a lot of open source projects. They do have a native Redis cache built into Azure, so we will take advantage of that. And the other thing in terms of data management I would mention is a key vault. And the key vault is where you put your secrets. And by secrets, I mean things like connection strings, things that you don't want all the developers to know what they are. And then typically DevOps or your security ops person manages the secrets and doesn't let the desk developer actually know what's going on. And that's how we protect environments like staging and production. Now, if you're used to doing desktop apps, you probably haven't done a lot of event-driven programming. And there are two things that I want you to think about in the Azure space. One's called Event Grid and one's called Service Bus. Event Grid is where a device can publish to some endpoint. And then other routines like a worker app, a container worker app, can subscribe to that endpoint and pick things off the queue. And we're looking at that as a way to transfer data from our old legacy software up to the cloud. And then also, it's really good for things that are like workflow related. So for instance, the software I work on is used to design roof truss. So those are those big wooden things that have the little metal plates in them that hold up your roof. And if you have one of those, you can say, gee, I know Bill Wolff, who works at Simpson. They manufacture all those plates. And they make software to help builders design the shape of the truss. And if you don't have the proper size wood and the proper plates, your truss falls down in the snow. We don't want that to happen. Well, when we do a project, we're gonna have a bid, then we're gonna have the bid accepted. To me, those are events. Then I'm going to have the whole truss system designed for a roof. Then I have to send that to code enforcement to have it, what they are called sealed. And then that once it's sealed, I can put it down to the production floor and have it manufactured. Then somebody can load it on a truck. The truck drives it over to a construction site and delivers it. And then the installers actually take it and install it. To me, each of those is events. Well, that's what you would use Event Grid for. Every time one of these things happens, I want to fire an event, and then my software can sort of put in a task table and say, this is when everything was completed. And it's a real nice way to work. And Event Grid supports MQTT, which is like sort of an industry standard way to do messaging. Now, if you have a number of services, I said we're going to have a platform across multiple applications. If you have a number of services on the cloud that need to talk to each other, then the way to do that is called Service Bus. And what that does is allows you to decouple your applications and have something say, okay, the design's done, post an event onto the service bus, and then maybe the reporting engine picks up that event and says, oh, you want me to build all of the formal reports for this design and put them in document storage or email them to somebody showing them that they're ready. So these are things that I would recommend you start looking at. It's sort of a different way to program. You're using the entire cloud and having different components talk to each other in an orchestrated fashion. Now, once you get all the stuff in the cloud, then you have to say, well, we got to secure this. We got to protect it. And one of the ways to do that is you set up gateways. You set up, there's an API center that Microsoft provides as part of Azure. And it can have policies and restrict who can get to your APIs and when. You can have private endpoints. You can have things called peer subnets, where you can have two services like within the cloud talk to each other, but nobody from outside can talk to them. So there's a whole sort of science to how you set up your network and secure it so you can keep out bad actors. One of my favorite parts of the cloud is monitoring. And once you get into cloud native, I mean, some of us grew up like reading text logs from the C drive. This is much, much fancier. And, Microsoft has this thing called App Insights. It's been upgraded, and now it relies on something called Log Analytics Workspace to actually store the logging information. Once you start collecting these logs, you can then query them. And you can query them using a language called Kusto, K-U-S-T-O. And it's shortened to KQL for Kusto Query Language. So you query your logs, and then these can be used to generate alerts, which would be email messages if you get a bunch of errors, or you could put them in a workbook. A workbook would be a set of instructions that allows somebody to run a set of queries and learn what the status is of a particular application. And finally, they can be displayed on a nice dashboard. Now, the dashboards are typically in the Azure portal. And that's okay if you're a developer or you're an architect. What if you want your product management people to see the results of your app? Well, then we have to publish the dashboard a different way. And Microsoft has in Azure something called a managed Grafana service. And Grafana is sort of the industry-leading way of doing telemetry dashboards in the cloud and on websites. So we're using Grafana to publish the Custo queries as tables and as charts so that we can show business people like, this is how many trusses we built today, or this is how many errors we got last week, stuff like that. The other thing I'd ask you to research is something in Microsoft has now called Database Watcher. So Database Watcher is a newer technology. It replaces what is called SQL Insights. And Database Watcher basically sits in the background and does a bunch of queries to your database. It doesn't really impact the performance of your database. It's querying the underlying system tables, those sys.dot things. And it collects a whole bunch of statistics and things. So you can go to the dashboard in Database Watcher and say, show me how many queries I'm getting per second. Show me how many users I had today. Show me my top queries and how long they're taking to run. And then it gives you useful hints and say like, well, you have 62 indexes, but you're only using 44 of them. You want to get rid of the rest. So Database Watch is an excellent tool. Some of you in the database world might be used to using Redgate as a tool. Well, Database Watcher is sort of the cloud equivalent of Redgate. Now, you're not going to have somebody sit at the Azure portal and actually build all of this technology one piece at a time. You're going to automate it. And when you automate it, you're going to do something called infrastructure as code. And the sort of the darling of the industry there, there's I think it's called Terraform is the language that people use to build resources in the cloud. But that is more prevalent in AWS. In Microsoft, they looked at that and they said, we can do better. And they built their own language called Bicep. And Bicep has full support, Visual Studio Code especially, and also Visual Studio. And basically what it is, it's a declarative language where you define, Azure has hundreds of different types of resources. Each one of them is accessible through Bicep. So you can create a new storage account. You can say what size you want it to have. You can tell it whether you want to use cold storage or hot storage as a default. All these things can be scripted. And then when you first build your resources, you use Bicep to do that. But you can also take Bicep and introduce it into your DevOps pipeline so that it automatically checks to make sure the Azure resource has the proper settings when it does a build into various environments. So Bicep is absolutely a language you want to learn a little bit about. When you do your deployments, as I said, you can use GitHub. There's lots of tools you can use. Jenkins, there's lots of build tools out there. We're focusing on Azure DevOps. It just fits into their environment the best. And we're going to build pipelines that do CICD. It can read from any Git repo. We happen to be a Bitbucket shop. So it reads from the Bitbucket repo whenever you do, a pull request, and then it automatically can set up and deploy. It does its build on virtual machines, and then it automatically deploys the code to your app service or your app container, wherever you need it to go. It can also be set up to do database upgrades as well. So, security and threat detection. Well, two Microsoft technologies you want to consider, Defender and Sentinel. Defender Basically, it will go and look at your code and look for threats and known problems and report back to you. You can actually have it stop a build if it finds something. And then Sentinel is the thing that would do things like denial of service attacks. So it sits there and sort of blocks bad actors coming into your network. It's a whole interesting area to learn about security on the cloud. So some of the tools I use Draw.io to do all my architectural drawings. It's open source. It's a free download. The Draw.io drawings can then be pasted into PowerPoint or right into a Jira Confluence page, things like that. So very easy to work with. I use a mix of Visual Studio and VS Code. When I'm in VS Code, I use REST Client, which is a extension that's used for testing APIs. And then I use Microsoft Playwright. I don't know if you're aware of this, but Microsoft has an excellent tool that does both API and screen testing. So you can actually point it at a web front end and have it look at the screen and say, okay, pretend you click this button. Once you did, then look at the grid and tell me how many rows are there. And it will actually allow you to run tests that are working with the front end design as well as the API. And finally, we take a lot of advantage of GitHub Copilot writing code. And I highly recommend that. You basically, when you're coding, you can ask questions and you can type something and say, like, is there a better way to do this method? And it'll come back and say, well, why don't you try it this way? So then you don't actually have to talk to any other developers. You just talk to your AI friend. Great way to live. So other things, obviously for SQL Server, you want a SQL Management Studio. If you're not aware and you're using Azure Blobs, you want to download what's called Storage Explorer. Again, free tool. Microsoft also has Data Explorer and Custo Explorer if you want to look at your Custo queries and your dashboards. So, in conclusion, there's a lot to learn when you move to the cloud. Your developers that are writing all your C# code don't necessarily have to know all the stuff I just mentioned. They just have to know how to write code, possibly inside a .NET Aspire framework. And then you need a DevOps person that can then take and publish that code once it's checked in to the proper resources in Azure. But you absolutely need an architect or a DevOps person that understands the Azure world and important things like performance and cost. The best way to learn all this stuff is to go to Microsoft Learn. That's what I do for most of what I do. So hopefully you've enjoyed this and enjoy the conference, and hope you get a lot out of it. Have a good day.
Thank you so much, Phil. That was absolutely great. I really loved watching your session from behind the scenes, and the way you started with one of your recent gigs, right? All the problems you're trying to solve, then you went through all the resources and how you can get started with Azure. I also liked what you talked about the hierarchy, and I could really relate that the developers, when you work in a very big project, you really don't know what's happening, where are some of the Azure resources. You're only stuck into what you're doing. So an idea on how the Azure is broken down into resource group, subscription, and management. That was really lovely. And
yeah, part of my job, Simon, is I don't see companies doing enough training. And they want to do something like move to the cloud, but then they say, oh, go watch a Pluralsight video. It's like, yeah. The only way you're going to learn this stuff is if you do it hands-on. You have to make resources in Azure, see what they do, see how fast they go. That's the only way you're going to learn. Just watching videos doesn't work. And but C# Corner and C# TV are good resources because you have lots of videos on things and exercises on this.
That reminds me, I mean, you'll find a lot of content on C# Corner and C# TV. And this also reminds me that from your last slides on Microsoft Learn, right? If you go to on that platform and you start working any of the, let's say, Azure fundamentals, they will give you these sandboxes where you can actually create VMs, you can create
Yes.
SQL servers and all that. And I really love that. You don't even have to ask your company, or even if you're a college student or maybe getting started with cloud, or maybe with Azure, you already know AWS. So I love that part.
Yep.
Yeah.
All right.
Uh,
Well, you guys have a good day. I'm gonna go. I'm gonna go play with Azure.
all right. Thank you so much. Well, thanks for accepting the invitation. We'll see you very soon. Bye bye. Take
All right.
care.
Take care now.
All right, boys and girls, that was Bill Wolff, your keynote for today, with over 30 years of Microsoft MVP and 45 years experience. He's the best guy who could do the keynote and start the software architecture conference. Before we move to the next session, we have about 4 minutes, and I've been looking at the chats. Actually, there are a few questions. Perhaps we can stick around, maybe look at the questions that are in the chats. But welcome everyone. Welcome everyone to the software architecture conference. This is season 3, or the third edition, as we're calling it on the social media. We have a lot of giveaways, right? So if you're asking questions, please use the hashtag software architecture conf in the comments along with that question. Then in some time, we're going to do the raffle and we'll do the giveaways. The tool that I use is still not perfect, and it still picks up C# Corner accounts as the winner, but never mind. And I see very familiar faces. I see Anderson. Thanks, Anderson, for joining in. Ganesh is here. Ganesh often joins it very frequently. Deepak. Then we have Vichya and Ledger. So thanks everyone for joining in. We now move to our next session, and our next session is by Rishit. Rishit is going to talk about new era of .NET development with MongoDB. It's conference by C# Corner, so why not? Some .NET C# is must. Rashid is a senior product manager for MongoDB. And without any further ado, let's bring Rashid to the conference. Hi, Rishit.
Yes,
Welcome
Simon.
to this conference.
Thanks, Simon. Good to be
I
here.
really, yeah, I really love your background already. It is so branded. It looks so nice. I love it.
Thanks to the MongoDB design team for that.
All right, Rishit, and we're going to do a lot of chit chat towards the end of your session. We'll also have a few questions. I'll let you get started with your session. I've added your screen to the stream. Everybody else can see it, and next 35 minutes is all yours.
Awesome. Thank you so much. So, hey everyone, and welcome to a new era of .NET development with MongoDB at the third edition of the Software Architecture Conference by C# TV. My name is Rishit Bhatia, and I'm a senior product manager at MongoDB, focusing on the developer experience for .NET and C#. I'm based in Toronto, Canada, which is home for me since the last 2 years, before which I spent the last 7 years in the US, but I'm originally from Mumbai, India, which is where I was born and raised. I actually started my career as an engineer working on C#. So I was working in sports technologies, games, etc., helping build AR, VR apps, mobile apps before moving to product management in 2019. So yeah, that's a quick summary about me. Okay, enough about me. Let's talk about what is MongoDB and what is MongoDB Atlas for those of you who may not be aware with it. So firstly, MongoDB is a document database. So it's similar to a key value store. However, it supports a wide variety of data types, including strings, arrays, objects, making it more versatile. Unlike traditional relational databases, which store data in tables, rows, and columns, MongoDB uses BSON, which is binary JSON. The document-oriented approach allows for a more natural and expressive way to store data and can easily accommodate hierarchical relationships and array-based data as well. MongoDB is designed to meet the needs of different audiences. So if you're looking for a personal project, you can use it. Or if you're looking to build enterprise-grade applications in different industries like healthcare, retail, finance, etc., you can do so using MongoDB. One of the key features MongoDB has is its flexible schema. So unlike relational databases that require you to define a schema before storing or inserting the data, MongoDB allows you to store documents without prior definition or a structure. Lastly, MongoDB supports horizontal scaling. So it does so through what is known as sharding. So it allows you to distribute your data throughout a cluster of machines. This approach can improve performance and allows the database to grow exponentially as the user's needs are growing, and makes it suitable for applications which require large data sets or high throughput requirements. Okay, so we know what MongoDB is. What is MongoDB Atlas? MongoDB Atlas is a fully managed cloud database that handles the complexity of deploying, managing, and healing your cloud deployments on any cloud service provider of your choice. It also offers SDKs or drivers, which facilitate the development of applications across a range of devices. So these help you developers integrate MongoDB Atlas into your application, allowing for seamless data synchronization and manipulation. And it works across different devices or different platforms, such as mobile and IoT. We also have charts. So charts is a feature which allows you to create visual representations of your data stored in MongoDB. So you don't have to go to any third-party tool. It's fully integrated into the platform, and you can generate charts, graphs for data analysis and reporting without any need for third-party tools. We also have analytics. So analytics allows you to perform complex queries and aggregate operations for your data, and it's optimized for performance and scale. So it makes it easier for your organization to gain insights on large volumes of data in real time. And lastly, we also have search. So Atlas Search is a fully built-in text search capability engine, which is built on Apache Lucene. It helps you perform rich text search queries without the need for a separate plugin or an engine. So this integrated solution helps you build search into your application by using MongoDB Atlas. Okay, so we've heard what MongoDB is, what MongoDB Atlas is. Now I want to touch on what is Entity Framework Core, or EF Core. So EF Core is the most popular object relational mapper, or ORM, in the .NET ecosystem. Since it was introduced in 2019, it has really become the ORM of choice for C# developers and has widely gained popularity across these years. EF Core is compatible with different databases, and it can do so through plugin libraries called database providers. So you can switch between different database providers by switching the plugin or the provider in your application. This should not be considered a drop-in replacement, though, because each provider might work slightly differently. EF Core also uses the language integrated query, or LINQ syntax, which allows you to use C# to write strongly typed queries. And the main reason why EF Core is so popular is because of its ease of use and the wide range of capabilities, which include entity splitting, lazy loading, custom conventions, etc., among many others. Okay, so why is all of this important? I want to quickly touch on some of the numbers here, which are taken from recent surveys, public surveys. One thing that we noticed is 39% of C# developers said that they have used EF Core in some capacity. So they're familiar with it. It's one of the most popular technologies in the .NET ecosystem. MongoDB was also the #1 NoSQL database for C# developers. And a lot of developers who have not used MongoDB or are not familiar with it did say that they want to try it out. So when you put all of this together, we started to collaborate with the team at Microsoft, and one of the most requested features for EF Core was a MongoDB EF Core provider. But for us as well, we got a lot of requests about having a provider that works with EF Core. So considering all the numbers and the requests that we had, the MongoDB EF Core provider comes into existence, and it really helps bridge this gap that we've just looked at. So in the past, C# developers could use MongoDB C# driver, but it didn't have first-party support for EF Core. So this meant a lack of official support or backing for EF Core if you were working with MongoDB. With the official MongoDB provider now generally available since May this year, you can confidently use C# and EF Core when you're building for production-grade workloads with MongoDB and EF Core. And like I said, we've been collaborating with the Microsoft team to bring this provider to life. and we're happy that we launched it, and we are going to evolve it with newer capabilities as we progress. Now, what are the benefits of the MongoDB EF Core provider? The first one is it allows you to leverage familiar APIs, query paradigms like link, and design patterns. The second most important thing is there is no cloud vendor lock-in. Now, what this means is if you're using MongoDB Atlas, you can use the cloud provider of your choice, be it Azure, AWS, or GCP. And since the EF Core provider is built on top of the C# driver, which is an architectural choice that we made, it allows you to use capabilities that the C# driver exposes, which might not be available in EF Core, like Atlas Search, Atlas Vector Search for AI applications, which I'll touch on a little bit later, and index management and other admin type capabilities. Okay. All right, so now let's take a look at a quick demo about how we can set up EF Core to use with MongoDB Atlas and how we can perform basic CRUD operations, and then also show a glimpse of the index management capability that I just spoke about. So hope everyone's excited to look at this. Okay, I'm going to be looking at my other monitor, but what you see on the right-hand side here is MongoDB Compass. And it's essentially the GUI for working with MongoDB. It's a desktop app. And on the left is just a terminal. So we'll be working with a basic .NET console application in this example. So if you want to add the EF Core provider to a basic project, all you need to do is use the .NET add package command, and it will add the EF Core provider to your project along with any dependencies needed. Now we switch over to our basic console application, and this is what you would do in your program.cs file for connecting to any database. So you just create a client, you have the database itself, and then the important thing here for EF Core is the DB context. So you see here we have our own DB context called movies DB context, because in this example we're using sample data set which is available with Atlas. So we're using the sample movies collection. If you get started with Atlas on the free tier, you have access to all the sample data that you need. Now we'll go into the create function itself. So we were looking at the program.cs file. Now we're looking at the movies DB context file. So you'll see that it inherits from DB context, which is available with the EF Core package. And we have our own create function here, which takes in the database. Now, all you need to do to connect to Atlas is use the function called use MongoDB on your DB context options builder. And it takes in the database object with the database client and the database name. Once you do that, that's pretty much it for connecting to Atlas. The only other thing worth mentioning here is we also have the constructor, which is the default one, and we just inherit from the base. Now, the other thing that we'll be doing here is defining the DB set. So we have our own entity called movies, and we need to define that we're using a DB set called movies. And we look at the model class quickly, but you just have to define it here in your DB context. Let's look at the movies model class. So you'll see here we have different fields defined in our model class called ID, title, year, plot, rated, etc. We also have up top an attribute, which is a collections attribute. So the thing highlighted on top, what it does is it tells the EF Core provider that we are going to be mapping our movies, DB set of movies entities into a collection, similar to a table in a SQL database. And all the names here are not shown, but they are defined in a constants file here. So be it the collection name, the name of the database, the connection string. You can do so directly as well, but just for the sake of this demo, we've put it in a constants file. The other important thing to note here is if you see the movies model class, everything here is in Pascal case. And all the fields in the database initially when we were looking at Compass, you'll notice here are in camel case. So now what we can do is configure our conventions. So what that does, we're going to uncomment this part. What this does is it tells the EF Core provider that we're going to be using the camel case convention, which allows to map the fields in the database to the model class. So for each and every field, we don't need to do anything explicitly again and again. We just need to do this once, and this mapping will be taken care of by the EF provider. So we just make sure we have the conventions added, we define the convention, and that's pretty much it. So going back to our program.cs file, now we're going to do a basic read. So we have a lot of movies in our database, I think around 20,000. What we're going to do is we're going to write a query. We're using link here. So we're just doing db.movies.where, and we're going to find movies from the comedy genre. We will find movies that start with an A, and we order by descending with the year field. And once we have our results, we're going to take the first 5 results and then try to print them. And in the movies class itself, we had a toString function, I think, which allows you to just print the movies. There we go. Okay. Didn't want to go into too much detail there, but just in case anyone wonders how is this being logged. So now we're going to just run this project. Let's see if we get our movies back. Okay, perfect. So you can see here in the log, we got our 5 movies. Movie can have multiple genres. So we asked for comedy movies. So we have all the movies that have the genre as comedy. They start with an A. They are ordered in descending order by the year. And we also have some awards or nominations listed here. So this is helpful, but what if you want to see more logs? What if you want to see what's happening behind the scenes with the provider, and how is it communicating with MongoDB? So if you want to do that, we go back to our DB context class. We can enable logging here, which is a pretty cool feature. And you can use any logger, but we're using just console.writeLine. And you have to enable sensitive data logging just in case there's any PII, because this will be logged into the console. Once we do that, let's just save and then rerun our program. And what we'll see here is we do see the results for what we wanted, but we see much more details than we saw before. And I'll show one more interesting thing. So we see a lot of logs. We're just browsing through it, and you can see all the communication and all the logs being seen in the console. And you see this sample.mflix movies.aggregate, the highlighted line here. What is it doing? So this is actually the query that is being sent to the server. So based on the link query that we wrote in our program.cs file, you'll see we have a match stage, which matches the genre, the title, starting with an A. We have a sort with the year field. In descending order, we have a limit to take the first 5 results. And it's essentially converting it to an aggregate pipeline. So you have a clear view of the executed MQL with the server. So that's pretty neat. You can see what query is being sent to the server. Okay, so now we've seen how a basic query works. Let's take a look at how we can use the index management feature I just spoke about. So what we're doing here is we are leveraging the capabilities of the driver. I mentioned that the EF core provider is built on top of the driver. So we are reusing the database or the Mongo client here that we defined initially. And we're just defining the convention here again, which I'll explain why. And we're creating a new index here on the title and genres field. So we are working with the title and genres field in our query. I want my query to be optimized, so I need to create an index for it. So this is just the driver code to create the index, and you'll see here create one async, and this takes in the movies index definition that you want to create. It's a compound index, and we're doing it in ascending order for the title and genres field. Coming back to the convention, why are we defining the convention again when we defined it already in the DB context? So the important thing to note here is that this is for the driver. So the EF core provider has its own data mapping for the model, and that's why we need to do it for the EF core provider separately in the DB context. But if we're using any of the capabilities of the C# driver, then we need to do it for the driver as well. But you only need to do it once. So now we've done that. Just to make sure that we're going to call that task here. And then just to make sure that the indexes are actually created, we'll go in and check, does this index exist already or what indexes exist? So going back to Compass, I see that there's an ID index, which is created by default. And then there's a separate index I would have created before on the plot field, but not what we want for the title and genres. So let's run this program. We have not given any by looking at Compass again. Okay, we're going to do a refresh. Perfect. We see title underscore one underscore genres underscore one. So it did create an index for us. And you can also see the title and genres field here with an up arrow because we wanted it in ascending order. And like we intended, it is a compound index. So awesome. We have like optimized queries now with the field that we needed. Cool. Okay. So what we're going to look at next is a full CRUD and change tracking example. So one of the things I mentioned initially was MongoDB supports a flexible schema. So with the database, there may be fields that you have not defined before. So in this case, we are defining a new field on the fly in our model class called the book was better. And this field does not exist for any document in the database. So we're going to create a new movie entity. We're going to set this field, and then we're going to update few properties and then delete it. And we'll see the whole life cycle with breakpoints. So firstly, let's create a new movie called MongoDB the movie for 2023. We have a plot, lucky little database, revolutionizes software development. It is a documentary. And we're going to set the book was better field to true. But just to make sure that this actually works, we're going to go back to Compass and we're going to search for this field, the book was better, and see if there's any document that has this field present. And once we do a find, you'll see that there is no document with this field. So we can confirm that this does not exist in the database. And like I said, you have to call save changes or save changes async. So we're going to create a new entity, add it to the DB set, save changes. We're adding breakpoints so we can pause and see every step along the way, how things are working. After we create the new movie entity, we're going to update the year to 2024 from 2023. We're also going to add a genre. So we know we only had documentary. We're going to add true story as well. And let's give our movie some awards because why not? It deserves some awards and nominations. We do the save changes async again, and then we finally remove the movie. So let's see how this lifecycle works. We have our code ready for change tracking for a basic CRUD operations. We run the program and then we'll wait for the breakpoint to hit. Okay, awesome. All right, so we're at the first breakpoint, as you can see. Let's step over it, step over the save changes. One thing to note here is if you don't call save changes or save changes async, the changes are local, this is standard EF core behavior. So you see the changes reflected in your database only if you actually call save changes. Now, at this point, we've paused at, new movie.here is 2024. So a new movie should have been added with this field. Let's go back to Compass and check that. We do a find again with this field, we just added to our movie entity. Awesome. Okay. So we did find our movie that was added. So yeah, congratulations. We can see that it's a documentary. We can see that the year is 2023. And we can also see that just go back a little bit. Yeah, we can see the year. We can see that there's no awards. The book was better field is true, which is what we were searching for. So now we're going to go to the updates and step over the updates and see if they actually get reflected in the database. So we update the year, add a genre, add awards and nominations, save changes, and then go back to Compass to see if it got updated. So we just do a find again, and yes. We'll expand on the genre. So now there's two genres instead of one. So you can have arrays, nested objects inside it, where genres is an array and awards is the nested object. So we have awards and nominations, yes, for our movie now. And the year is also 2024 instead of 2023. And lastly, let's remove the movie, sadly, and then save changes, and then go find it again in the database, and you can't find it anymore. So all of the operations succeeded. We're able to see how easy it is to set up the EF core provider, how to perform change tracking and basic CRUD operations with it, and also how to use capabilities from the driver, like index management, by creating a new index. And you can do much more with that. So the main thing to notice here is the only thing that's different if you're already familiar with EF core is the use MongoDB function. So we use the already defined database client and the database name. And that's all that you need to remember if you've already been familiar with EF core. I also want to showcase like some of the key features that are available already since we've been GA in May this year, and then also what's coming up. So we are compatible with EF Core 8 and .NET 8. We already saw capabilities in action with CRUD operations, change tracking, embedded documents, link query support, etc. In terms of the upcoming features, what I'm excited about is transactions and optimistic concurrency, which is coming soon, this week actually, as we're speaking. So what this allows is it makes save changes and save changes async transactional by default. If you want to turn it off, you can intentionally. And we support two modes of optimistic concurrency. So you can define a concurrency token, like a last updated time field, and the onus is on the developer to update that. But you can also use a row version, which is an automatic update field where EF core provider will take care of it on its own. There's other features also listed here, but we have our whole list available on GitHub. I can share a link later. And that's pretty much in terms of what's going to be available. What I do want to mention next is what else are we working on? So we spoke about the EF core provider, we spoke about the driver, and how these tie together and how you can use MongoDB Atlas along with it. But four things I want to highlight that our team has been working on and is very excited to share updates on. Firstly, on the top left, you'll see the MongoDB.NET Analyzer. So for folks who are not familiar with this, it is an extension already available as a NuGet package. And it's a Roslyn analyzer, which allows you to see your queries at compile time in your IDE. So if you are working with builders or link, you can use the analyzer to hover over your code with the mouse, and you'll see 3 dots, and then you can expand on that to see your queries even before they are sent to the server. So it's pretty cool in terms of seeing what queries would be executed as you're working and developing your application. Another important thing here is, as of yesterday, we shipped an update to the .NET Analyzer, and it supports EF Core as well. So if you're using the driver or EF Core, you can use the analyzer along with it. The next one below that is better OData support. So OData is an extension that has been available in the .NET ecosystem for a while. So if you are working with OData, we do have an extension for MongoDB available. You can simply use the Mongo enable query tag on your code, on your controller's queries, and then it will just make your queries powered by OData. We've been working on improving the OData extension by adding support for better filters and compute operations. And in the next iteration or the next release of the extension, all of this will be available. The next one that I think a lot of folks will be intrigued about is our semantic kernel integration. So if you are interested in building GenAI applications, then you have the MongoDB memory connector, which allows you to store your vector embeddings alongside your data. So you can use Atlas to store all the data you already have with the vector embeddings. And the semantic kernel integration will allow you to query your data and create GenAI applications with that. So I'll just share a couple of links in the chat. And in case anyone's interested, I was able to get up and running with adding basic documents and create a chatbot in less than an hour. So it's very, very nice. The last thing I want to mention is the C# driver 3.0. So our C# driver has not seen a major upgrade in the last 8 years. So this is really the next-gen version of our driver, which allows you to reduce a lot of tech debt, deprecate things, add new capabilities that we've been wanting to add for years. So we're really excited to introduce that. The estimated time for that is late September to early October. So we should be able to share more details as we make progress on that. Okay. I think that's all from me. I'm open to questions, but before we go to any questions, I also want to leave this up, which is codes or links available to view the documentation for EF Core. If you want to see the GitHub repository for the features that I just mentioned in terms of what's available, what are the limitations, what is not supported, but we're considering. And then if you want to engage with the community, we have our community forums. And lastly, our Jira board is public for any project. So for the EF Core provider specifically, if you've already used it and want to share any feedback, feel free to do that. Thank you, and back to you, Simon.
Wow, Rashid, that was absolutely great. I really loved watching your session. I'm gonna leave this slide up over here, and we can do some chit chat because audience can scan this QR code. I see already a comment by Salam. He's asking, "Is this demo and code work only?" Okay, no. Okay, actually, there's another guy who's asking for. Uh, Let me find it. Salam was actually asking, "Is the code Rashid showing is available to play with?" So I think the GitHub repository QR code that you have, it will take you there. Oh,
Sorry,
I
I'm
think you're
muted.
mute. Yeah.
Yeah, I was mentioning that that is for the EF Core's official repository. So if
Hmm.
you want to see what's going on in the project, but great question. The code is available. So I'm going to share a link to you, Simon.
Yeah.
So it's publicly available. It's called a basic Mongo Flix project, which allows you to work with the sample data set I mentioned and has all the capabilities I just showed in the demo. So if you want to download it and try it out, um,
Perfect. So what I've actually done, Salam, is I have dropped the links in the chat of the GitHub. It's everywhere: Facebook, YouTube, Twitter, Twitch, wherever you're tuning in from. You can click on this, or actually go to this repository and have a play with this demo. So let's take a few questions, Rashid,
yeah,
while this keyword is up there. Let's see. Okay, so we have. Okay, let's go one by one. Okay, so we have. Where did it go? Oh, I'm messing up. All right. Yeah, so we have one by. How? Why am I missing? Where are all the comments gone? Okay, there's one by Bhaskar. Okay, he's saying, "Do you
okay.
see great achievement of MongoDB over RDBMS and why?" I see it. I would say personally yes. I'll let you answer it.
I think it's a good question.
Yeah.
It really depends on your use cases and how you've structured your data. But I mean, the short answer would be yes, but it's much more elaborate than that, I would say. So, y- we have a long way to go if you're really looking to modernize your applications. There's a lot of tools that we've been building at MongoDB. Where you can see how you can transform your schema, see how you can optimize your queries, etc., etc. But again, like if you want to build something which is a personal project like I mentioned initially, or something at scale, we have hundreds of examples, more than 40,000 customers at MongoDB.
Mhm.
So I don't think it's a question anymore whether it will work or has any improvements. So there are real life examples which work. So I would encourage everyone to try it out and give it a shot in the .NET ecosystem, and we're
Yeah.
always open to feedback, so I'm happy to hear that.
Yeah, and I never really love the MongoDB's free tier that they have it, right? Either
Yeah.
you can also run it on your local system, or if you use Atlas, they have free tier. And you
Yes.
mentioned in your presentation that you can choose your cloud provider if you want to deploy it on Azure or GCP or AWS.
Yeah.
Uh, and when I say that, Rishit, I have a question, right? So
Yeah.
I didn't say it anywhere, but tell me, if I have an existing cloud subscription, let's say on AWS or GCP, can I tie that subscription when I create a resource through MongoDB? At this instance, I cannot recall actually.
I don't think I have the answer to that. I can follow
Mhm,
up with that though.
mhm.
I'm sure there are ways to do so. But
Yeah,
like you said, there's a free tier to get started. I don't know if you already have something existing. How do you go about doing that? To be
yeah.
completely honest. But yeah, I can follow up with more information on that.
Yeah. Okay. Yeah, that's good. That's good. I love it. I have used it for a while. And let's take another question from
Yeah.
Sophia. I think it's more developer oriented. She's asking, what are the key differences in managing transactions and ensuring data consistency when using MongoDB with EF core versus traditional SQL database?
Yeah, good question. So,
Yeah.
I think I touched on this. We are just getting started with supporting transactions in the EF core provider. So, we are
Hmm.
trying to establish a baseline. So, we are not supporting all types of transactions, like complete transactions, what EF core would, just because of how it would work in a traditional SQL database versus what how it would work in a NoSQL database. So
Yeah.
what we're offering now is just basic support for transactions. So I was able to test it out this week, where if I have a set of operations, I insert a document with an ID, a new entity, and then I try to create a new DB context and then insert a couple more documents,
Hmm.
and if the ID is same, you would get an exception usually, which is accepted. This happens with the driver or the EF core provider. But what the EF core provider would do is, for the second set of operations, when you call your save changes, it will roll back. So that is, the basic expected behavior. So instead of having three documents in your database because the latter two failed because of a
Yeah.
duplicate key, only one goes into the database, which is, what is expected of basic transaction support. I was using a row version for my
Hmm.
application, but you can use concurrency tokens as you prefer. So I think there's much more to transactions that we want to support, but this is like the first iteration that is out and going to be available soon.
Mm. That's nice. That's nice.
Yeah,
Okay,
good
Sophia, I
question.
hope I hope you've got your answer now. And Rashid, I really liked your demo. I've seen many people using this movie database, right? It's
Okay.
very popular, right? And I've also actually used it,
Oh,
but
nice.
I did not use it for the .NET drivers. I used
Okay,
it for the Node.js, and
nice.
that was for the vector databases. So
Cool.
so what MongoDB is doing with vector databases, I really love that too. So yeah.
Nice. I
So
just want
let's.
to expand,
Mhm.
sorry, that the two links that I shared for the
Yeah,
semantic kernel integration, one of
yeah.
them is a full tutorial on
I'll do it
creating a
again.
movie recommendation system. So
Hmm.
if you're interested, like Simon, and you want to try out that sample data set,
Yeah.
it would tell you to create like a basic chatbot where you can define, hey, I want to watch this type of movie with sharks in it. So it will give you the movie recommendation accordingly.
Yeah, and the best part, what I like is, we have been sharing GitHub links. Rishit has been giving
Yeah.
GitHub links. If you find that, hey, you know what, there's a mistake or there's an update that you want to do in the repository, go ahead and do a pull request. And you never know, it can get merged, because that's happened with me. I was going to the vector database repository. There was an update that MongoDB had it. The repository wasn't updated for some reason, so I went through it. It wasn't working. I created a pull request, and it got merged into MongoDB repository, and it felt so good.
Nice. Thanks for contributing, Simon.
All right, so let's take a few more questions. Let's take, there was one by Rohit. He's asking, what are the best practices for implementing MongoDB in .NET microservice architecture, particularly concerning data modeling and API design? I mean, I know people from the .NET and C# background, they used other NoSQL database like Cosmos DB and all that,
Yeah.
right? So
Yeah.
perhaps this can also cover that ecosystem.
Yeah, that's a
Yeah.
good question. I think there's different ways in the .NET ecosystem now,
Mm.
whether you're using, the MVC model, or you're using just controllers for your APIs. You can do that. The good thing is the driver itself or the EF core provider is agnostic to that implementation. It's more about how the communication works with the server, and how you're working with your queries. Are you optimizing it? Are you using the correct aggregations? Is your schema appropriate? So I think it falls more on that. Um, I mean, you can even use minimal APIs if you want, for that
Oh
matter,
yeah.
and the driver would not care about it. So I like it. I think it's very simplistic. So in terms of creating microservices, it will be more about the application architecture itself and making sure that your schema is appropriate. You're not doing, too many joins with your queries,
Yeah.
and so on and so forth.
Yeah, that's good. I like manual queries too, APIs too. I
Yeah,
love that. It was launched only some time back, right? It's
yeah,
still relatively new, but
yeah,
I think everyone in .NET community and C# here really love
yeah.
it. So we'll take a couple of more questions, then we'll
Sure.
kind of wrap it up. And I'm giving, you need to have a glass a photo next to you.
I'm good, thank you.
So Vinash is actually asking, with RDBMS, we had a lot of dependency on proper schema design for performance. And that's always a problem. You cannot change it later on. So stressful. How
Yeah.
does MongoDB manage performance for schema-less database?
Yeah, I think it's related to the previous question somewhat. So
Mm-hmm.
I think one of the ideologies when you're designing, an application with MongoDB is data that is accessed together should be stored together. So because it's a flexible schema and it allows for nested documents, you can essentially manage your schema such that whatever you're going to access in one go can reside in the same document itself. And what you want decoupled, you can still keep it decoupled. You can do basic sort of mappings. I don't want to use that word, but in some ways where you have an ID and you can do a lookup. Um, but I think it's very different from how you would design it in RDBMS way. And we're seeing a lot more examples of this happening in recent times. And that's what I wanted to touch on before is we have free tools like the Relational Migrator available. It's a desktop app. It's in beta, I think, now, which allows you to see and evaluate your schema and how you can transition that to a NoSQL database like MongoDB. So it has different components. It has a schema converter. It has a query converter. If you have a SQL query, how would that look, in MongoDB, and then how you can convert that into your application code. So we're working on these tools as we progress, but I don't know if this directly answers the question, but I think that's what we have, which will help guide you in the right direction, hopefully.
Yeah, it does. It does. It makes sense, everything what you have said. I like it. There's another quick question coming from Salam. I mean, we quickly answer this one. Okay, not this one. Where did that go? Yeah, this is
Can
Salam
go
is
ahead.
asking, is this demo and code works only with Atlas or local MongoDB too?
Oh, good question. No, it will work with local MongoDB too. So we have our community edition, we have our enterprise advanced, and we have Atlas. So it works with anything. Again, like the architecture in an application, the driver is agnostic to what MongoDB you're using. So it will work with all of them.
Perfect. I see your slides already right. All the resources that you have. One resource that that's not mentioned here, but I think you should have is the
Yeah.
MongoDB University. How can you forget that?
Oh, yes. And
Yeah.
as we speak, I mean, now that you've mentioned it,
Yeah.
we've been working on a learning bite. So it's a
Mhm.
10-minute course which will help you get up and running with the F core in no time. So we're working on it and it should be published in the coming weeks. But yeah, you can go to MongoDB University, which is learn.mongodb.com, and you'll have a C Sharp learning path if you want to learn more about how you can get started with MongoDB and C Sharp. You have detailed tutorials and videos for each and every course. You have an interactive lab so you can work within the browser and see how your queries work, how your code would work, etc.
Yeah, I love those labs, and the best part is you actually cannot skip those labs if you're working on it.
That's
You
good.
cannot fool because you
Yeah,
have to write, you have to create those tables, the database, everything. You have to do that activity and then you
yeah,
will check it, and only then you can move to the next one. You can
yes,
try it, but you're not gonna get certificate if you do it that way.
yeah,
So it may say 10 hours, you may end up taking like 12 or 13 hours of doing a particular course, but I think it's actually worth it. I love MongoDB, all resources, the community, and thank you so much, Rishit, for doing this
my
this
pleasure.
this community session with us. We would love to have you in the other events that we do. Before we move to the next session, any final thing you want to say?
No, I would encourage everyone to try it out, give us feedback. We're open, engage with the community, and yeah, thanks everyone for listening in.
Yeah. Thank you so much, Rishit, once again. I know it's a work day, so I'll let you go. We'll see you in some other events, and until then, take good care of yourself. Thank
Thanks
you.
everyone. Thanks, Simon.
Yeah. Bye bye. All right, ladies and gentlemen, that was all about MongoDB. If you want to get started with MongoDB, this is the session you should watch, especially if you come from a .NET or a C Sharp ecosystem. Definitely, I believe most of this audience joining in this conference, they have C Sharp and .NET background. But we have next session, but before we move to the next session, I want to remind everyone that whenever you drop any comments, please use the hashtag software architecture conf, and then we can actually track it and announce the winners. Thanks for all the questions you're asking. And I think Okay. So we move to the next session, but I think we're gonna have some. We need to check some speakers mic. Never mind. We'll bring him in, and we'll see what can be done with his headphones. Our next speaker is Alexander. Oh, he says it works. Ooh, last minute. Our next speaker is Alexander. He's gonna talk about why does the big ball of mud keep happening and how to stop it. This is such a creative session title. So without any further ado, let's bring Alexander to the Software Architecture Conference. Hi, Alexander, and welcome to the Software Architecture Conference. You are frozen. Or I think your system is not working. So, all right, your slides are working, but Alexander, you are muted and your video is frozen. So perhaps you would like, there you go. It works now.
Okay, can you hear me?
Yeah, Alexander, we can hear you loud and clear.
Okay, that's wonderful.
All right, so what I'm going to do, I'm going to add your slide to the stream. Everybody else can see it, and you have full 60 minutes for your session.
Okay, thank you very much, Simon. And thank you for everybody for joining. Unfortunately, I cannot see any of you. So, and I cannot hear you either. So it's very hard to get feedback or anything like this. But I'm trying my best to be as entertaining as possible towards my computer right now. So we're going to talk about the big ball of mud. And I'm pretty sure that most of the people who had worked in the software industry for some time understand the concept of a big ball of mud, because that's what most people are actually working with. I also know that most people are not too happy to work on a big ball of mud. It's not always fun. It's actually sometimes very dangerous and very dangerous to make changes, because it's hard to basically understand the consequences of those changes, because big balls of mud are suffering from high coupling and other issues. We're going to go into details. First, we're going to talk about what is a big ball of mud. And we're going to look at a very nice example, open source project called Apache Cassandra. Then we're going to discuss the characteristics of big balls of mud. And then we're going to find out how can we detect it if our project turns into a big ball of mud, and how can we stop it at the end from happening in the first place. And what are we going to do if we already have a big ball of mud? So this is a screenshot of a dependency diagram. I think we can agree that it looks a little bit like a ball. We see something like 1,553 Java files that form one big cycle. It means from each of those 1,500 Java files, you can reach any other one and come back another way. So basically, they form one gigantic big Java file, one logical big Java file that comprises basically most of Apache Cassandra, which means that the original architecture has been lost or simplified to the maximum, because in that case, you could say it's a simple architecture diagram with one box labeled Apache Cassandra, no further subdivision. So I'm pretty sure the original developers still understand their code base a little bit, but we also could agree that somebody who comes from the outside and needs to do meaningful changes to this code base might have a hard time doing that. So what happened here? So I'm trying to prove that once a project becomes a big ball of mud, it will be very difficult to come back from it. And what I did an analysis of different open source projects, and one of them was Apache Cassandra. And here what I did, I compared 5 different versions of Apache Cassandra, started with version 1.0 up to version 4.1. And I think now we have even a newer version that has even worse characteristics than the previous ones. So what we can see in a trend, which I'm able to prove also with many other projects, once you get those big cycle groups in a system, they tend to grow. That's why I call them code cancer. They're like little tumors, and as soon as they grow over a certain size, they will develop some dynamic growth that at the end will eat up your whole system. And as I said, by just looking at the data, we can confirm that things got worse with every new version. They are caused by growing groups of elements involved in cyclic dependencies. And once you have one of those bigger cycles, let's assume you have 20, 30, 40 classes in a cycle, it's very easy to add new classes to that cycle without even knowing it. Because they're already, the bigger those cycles become, the more they develop their own kind of gravity and attracting more and more dependencies from the outside, which at the end only means that the cycles are growing. So this is how it started, how it's going. So version 1.0, we had 296 classes in a big cycle, already pretty big. And now in version 4.1, we have 1,553. So the two graphs, of course, because most of the files are not visible on the right side, the right one doesn't look so much worse than the first one. So the first one was already pretty bad. But now we are in a stage where it becomes very, very difficult to put any structure in this, any architectural structure on top of Apache Cassandra, because everything is literally connected to everything. By the way, the different colors in the graph are forming different parent packages. So each of those little rectangles is one Java file, and all Java files with the same color are in the same package. So here we have different charts where we compare those numbers over time. So we can see in the first chart on the top left that the lines of code from version 1 to version 4.1 grew from about 50,000 lines of code to over 300,000 lines of code. The number of Java files went from 500 to 2,200 or something like this. And then the number of packages went from 40 to over 120. Now we have two metrics here called propagation cost and maintainability level. Blue is propagation cost. Propagation cost means if you have a propagation cost value of 70%, it means if you change a random file, if you're in your system, 70% of the system will be affected by that change. And that's quite a big number. Then maintainability level is a metric that we developed together with some of our customers, where we look at how maintainable is a module in your software. So it's computed on the module level, and it takes into consideration the dependency structure, the amount or size of cycle groups, and similar things. The best value is 100%, the worst value is 0, and you can see it's pretty close to 0. So it started in version 1 a little bit over 20%, and then after that it fell to the 10% range and never really recovered from that. Propagation cost at the end is brutally high, almost 80%. So every time I change a file in Apache Cassandra, 80% of the Apache Cassandra code base might be affected by that change. So that, of course, dramatically increases the chances of regression bugs coming in. It also makes it much harder to test the code because you cannot test anything in isolation. Never even talking about how would you be able to understand that code base if there's so much coupling and everything is kind of related to everything else. We can also see that the number of elements in the biggest cycle group is continuously increasing. From version 1, it was 296 to 1553. So that's a pretty steep increase. Also, the biggest package cycle groups went from about 30 to 110 packages. And relative cyclicity is another metric, which I will explain down the road in this presentation, also went up to the 90% range on the package level and to the 70 to 80% range in the Java file level. So that is what I'm trying to prove here. Once you have this kind of code cancer, it usually only gets worse. That's why it makes sense to think about why is it happening in the first place and what can we do to stop it. After all, Cassandra is quite a successful project. It's used in many production environments and a very popular open source project. But it has no discernible architecture. It is hard to understand, especially if you're new to the project, because then you have to basically read the whole code base to have an understanding how everything works. It is basically impossible to test anything in isolation. It has no modularity whatsoever. And it's just one big jar of highly coupled code, which means you also have a higher risk of vulnerabilities. Just imagine you want to harden that code base against cyber threats. The more complicated the code base is, the more highly coupled it is, the more difficult it will become to harden the code base against threats from the outside. Yeah, and of course, we already talked about the chance of regression bugs. The probability increases dramatically because every time we change a file, about 1,500 files are directly or indirectly affected by the change due to the extremely high coupling values in that project. So, another argument is that big ball of muds, BBOMs, are expensive. Very expensive indeed. Just in the United States, there was a report from CISQ about the total cost of poor software quality, and it is estimated for 2020 that this cost was in the range of $2 trillion, which is roughly 10% of GDP, quite a bit of money. And there's a new report out in the meantime from 22 that has even worse numbers in there. So we can assume that poor software quality costs a lot of money over time. We have a relatively large bubble of unsuccessful IT projects, 260 billion alone. That is a little shocking, right? Because we're developing software for more than 50 years now. You would hope that we figured out how to do it right in the meantime, but obviously not. We're still having issues finishing projects successfully, obviously. We have legacy systems with 520 billion, operational failures with 1.56 trillion, which is quite a big number. And there are many famous examples of bad software quality. Let's talk about Boeing 737 MAX, for example. It's a nice example where sloppy software development and sloppy quality control actually led to the death of 400 people. And totally destroyed the reputation of Boeing, and they're still trying to recover from it. And obviously, if you read the news, those problems are not totally solved at Boeing yet. If the doors can fly out mid-flight, that's a serious quality issue too. But it's all related. So the quality of the airplane, the software, all is related together. And there are many other examples where poor software quality at the end cost real money. Now, why? There are some more interesting findings in this report. For example, failed projects are up 46% from 2018. And I was wondering why that happened, but I think there's a relationship between the hype going to microservices, which started in about 2015. There are many organizations switched to a microservice architecture without really knowing what they were doing. So many of those microservice projects actually failed, and I've seen a couple of them because we also do software assessment services. And I can tell you there are lots of issues. Microservices are not a bad thing in itself, but it requires a more skilled team to write a microservice compared to a monolith. And it also puts a lot of burden on your end users because now they have to manage many services that have to kind of be orchestrated, running in a Kubernetes cluster or something like this, and all that increases complexity. It also increases programming complexity because as soon as one microservice has to talk to another one, you need some inter-process communication mechanisms like message queues and similar things, which increase complexity and do not decrease complexity. What are the key recommendations from the report? One of them says, ensure early and regular analysis of source code to detect violations, weaknesses, and vulnerabilities. That is where you actually need tools. And very few people use tools for that. We're going to talk about some tools a little bit down the road here. Then measure structural quality characteristics. I couldn't agree more. That's why we have a tool called Sonargraph that can do all those things. And there's even a free version of it called Sonargraph Explorer, which you can basically download for free from our website, hellotomorrow.com, and use for free even in commercial context. And it will compute most of those metrics for you and give you some basic information about cycles and similar things. There's also a commercial version of the product that can do nice visualization and other stuff. if you wanted to have a little bit more than just the basic features. Yeah, and then recognize the inherent difficulties of developing software and use effective tools to help with those, to deal with those difficulties. Again, a totally correct answer, but very few companies actually do something about that. And I can kind of relate very well with that, because when I go to conferences, I often ask, I talk about this topic very often, so I often ask, how many of you having a formally defined architectural model for the project they're working on right now? And less than half of the hands go up. Most people don't have a formal architecture. It's something that is maybe communicated verbally or hidden in some documents, but it's not a lot. So there are basically some basic rules, what you should do and what you shouldn't do, but it's not enforced in any way, shape, or form. Of course, now it's easy, much easier for the big ball of mud to grow, because if there are no boundaries, no rules that are enforced when it comes to the dependency structure, those issues can happen very easily. So you need tool basically to figure out what's going on with your code base, and you need rules, enforceable rules, ideally something that breaks your build when something is happening that is not supporting your current architecture. Now let's talk about how can we, what are the characteristics of a big ball of mud and how can we measure that? So a big ball of mud have few but large groups of cyclic elements. So that's the sign of end-stage code cancer. If you have those big cycle groups, few big cycle groups. In Apache Cassandra, there was one big cycle group, and now it metastasized to a second one with only about 100 elements. But if you have few large cycle groups, then you have a big ball of mud. Once they grow over a certain size, they basically are like black holes in the universe. They develop a lot of gravitational pull and pulling more and more components into their orbit. And of course, we have some metrics, which I'm going to explain in the next section, that allow you to detect this problem early on. And the first good strategy to fight the big ball of mud is monitor cyclic dependencies and not allowing to let those large cycle groups grow. That would be a first strategy, at least to stop the bleeding. And of course, if you can do that, an enforceable architectural model is even better. Why is an architectural model better? Because in an architectural model, you actually talk about the structure of your code base. And I'm a big fan of domain-driven design. Basically, you cut your system by functionality first, and then you have those different domains. They should have a cycle-free dependency structure between them. And then inside the domains, you can have layering, like a UI layer, a controller layer, a service layer, persistence layer, and so on. And then once you have this enforceable structure, you will know which dependencies in your code base have to go anyway because they violate the structure. And many times, removing those unwanted dependencies leads to less cycles and better structure. But of course, without using proper tools, fighting this problem becomes very, very difficult. So why does it happen so often? Because I'm pretty sure if I could see you now and I would ask you, do you like working on a big ball of mud? Very few hands would rise up. And if I ask you, do you intentionally create a big ball of mud? Nobody would agree to that because we're not doing that intentionally. We're not trying to create the worst possible software structure that we can. I think most developers I know are striving to create good code. It is much more fun to work on a good code base. Anyway, as soon as we have enough people working on the same code base, that is the usual outcome. So you need to put active countermeasures in place. Otherwise, a big ball of mud is the default outcome for any non-trivial project. And I've proven that a million times. I've done so many software assessments. I can tell you that 80% of non-trivial systems are ending up as a big ball of mud. It's our default architecture design pattern. So another reason, because we have no formal definition of our architectural model. And even if we have it, we lack an enforcement mechanism, because it's nice to have your architecture on paper, but the paper won't tell you if your code base is conforming to the architecture. So without proper tools and dependency visualization, those structural issues are introduced without the developers being aware of the problem. They're not doing that intentionally. Developers are not stupid, but it's really hard if you're working on a big code base with thousands of files to understand all the dependency implications of the changes you are doing without some tools that help you visualize that. And as I said, as the cycle groups are growing like little tumors, so they create a snowballing effect until your whole code base is affected. And also, it's not easy to communicating architectural rules. That's why a formal description that is enforced by a tool can be so helpful, because then there's no interpretation of the rules possible, because the tool decides what is right and what is wrong. And of course, we're always working under time pressure, and time pressure encourages shortcuts, definitely. So many times we're just pragmatic and skip over a couple hoops just to make sure that we are faster and that we meet our deadline. And in the end, we create increased technical debt by that. But usually we don't have the time after the deadline to fix the technical debt that we already accumulated. And if you never fix or address your technical debt, it just only grows and makes things harder and harder, until you reach a point where every change becomes increasingly very, very difficult. So some people said, oh, microservices to the rescue, right? So just make smaller code bases and then everything becomes easy. Of course, a major cause for the big ball of mud is that it's hard to define and enforce architectural boundaries. But that problem does not go away by simply splitting it up into a monolith into many smaller services, because you still have the dependencies between those services. So basically what many people do when they jump blindly into microservices architectures, they basically split up their big ball of mud into a distributed big ball of mud, which is even worse than what we had before. Of course, there are many good cases for microservices, but they're not the silver bullet. And the author of this famous book about microservices, Sam Newman, wrote it very nicely. You have to convince me that I need microservices, and you have to have good arguments for it, because the default architectural pattern should still be the monolith. The monolith is a valid architectural pattern. The fact that so many people have problems with monoliths is due to the fact that very few people are able to basically create a nicely structured monolith, because they have no tools to enforce architectural rules. If you have a well-structured monolith, we also call those moduliths for modular monolith, then you don't have the usual problems that you normally have with monoliths. And the argument that you need microservices for scaling or scalability is not always true. Sometimes it is true. Sometimes you can just split your big monoliths into two services and already create something like a great improvement in scalability. Sometimes scalability is not improved by just splitting a service up into a smaller one. It depends on the architecture characteristics of the different services you're creating. But using microservices just by itself creates more problems than you used to have before. There can be a good solution, but not everybody is Netflix. Not everybody needs Netflix scalability. And not everybody has a rockstar developer team that the people at Netflix have, that obviously understand all these complex things and complex relationships and can make it work. So microservices can be a good solution, but they increase overall complexity. They do not decrease it, they increase it. And we know by now that many of those microservice migration projects actually fail. Because as soon as you get into the details and the nitty-gritty, things can get very nasty very quickly. So we talked a lot about why it's happening and what the big ball of mud is. Now it would be useful if we could actually get some metrics that help us finding out what is wrong with our software, and maybe detect harmful trends early by using a metric-based feedback loop. So 2 metrics I'm going to explain pretty quickly is average component dependency and propagation cost. Those 2 are related. Then we're going to talk about what are cycle groups. We're going to introduce some cycle analysis metrics. And we're going to talk about that metric maintainability level, which we developed together with some of our customers. Let's start with average component dependency. That's a simple metric. On the left side, so we have a couple dependency graphs here. The boxes are source files. The arrows are dependencies between those source files. And the numbers are the so-called depends upon values. On the bottom, the depends upon value is 1 because this file only depends on itself. This one depends on this one, and on itself. That's why we have a 3 in there. And this one depends on all the other ones directly and indirectly plus itself. So that's why we have a 6 in there. If we add up those numbers, we get cumulated component dependency. 6 plus 3 plus 3 plus 3 times 1 gives you 15. And if we divide it through the number of boxes, we get average component dependency of 2.5. Means in that dependency graph, every file on average depends on 2.5 files, including itself. Now in the middle, we see what happens if we apply the dependency inversion principle. That means it allows us to turn around to the direction of dependencies. So in that case, the 2 files in the middle become the bottom of our system. And we get a better value of 2 instead of 2.5. Minimum value would be 1, which means we have 6 islands with no connection between each other. Maximum value would be 6, means everybody's literally connected to everybody. And here we see what happens if we just add 1 dependency that would create 2 cycles, 1 to the left, 1 to the right. And then we get a much worse value from 4.33, which is pretty close to the maximum of 6. So cyclic dependencies are always making average component dependency worse. Now, the input metric for average component dependencies depends upon value. Yeah. So we just explained depends upon. This is a graph here, same thing. This only depends on itself. This one only depends on this and on itself, and so on. That's how you get the numbers. There's a mirror metric used from, which just turns the question around, said how many people are using me directly or indirectly, and then the one on the bottom gets the biggest number, and the smallest numbers are on the top here because it's only used by themselves. The funny thing is, and necessary by mathematics and graph theoretical reasons, if you add up the depends upon values and the used from values from the same graph, you always get to the same number. In our case, it would be 3 plus 3 is 6, 12, 14. And here we also have 14, if you add it up quickly. So same number. And then we can normalize those numbers, divide by the number of boxes, which gives us a metric fan out or fan in here. Propagation cost is basically the percentage rate to indicate coupling. We learned that Apache Cassandra had about 70% propagation cost. And we can calculate that very easily by either taking the average value of fan in or the average value of fan out. Or we can divide average component dependency by the number of components once more, gives us the same value. All result in the same number, which is a percentage value, which tells us how strong the coupling in our system is. Yeah, as soon as you get values above 20%, you have bad values except for small systems. So propagation cost calculations make sense for larger systems. If you have very small systems with 20 or 30 files, it's not really relevant because then you will get naturally high coupling values anyway because the number of files is so small. And since it's a dependency, basically a dependency percentage metric, by just adding new files to a system, this value will grow, will shrink. The value will shrink because you have more and more files, so the density of relationships between files compared to the total number of files will sink. It's owed to the fact that basically you have a quadratic number of dependencies. So if you have 10 files, you can have 100 different dependencies, 10 times 10. if you have 100 files, you already have 10,000 potential dependencies and so on. So the number of potential dependencies increases with the square number of nodes in your system. And so that usually, if you're not catastrophically bad at what you're doing, just adding files will let the value shrink a little bit. But still, higher values of propagation costs are always bad news. Never let it grow to the values that you see in Apache Cassandra. Now, we talked about cycle groups a little bit. Here's a visualization, what that exactly means. So in this graph, we have two cycle groups, the gray one and the red one. And the white nodes are not involved in any cycles. And with Apache Cassandra before, we saw that giant cycle with 1553 elements. You can imagine that this looks a lot more complicated. No. So more about cycle groups. So dependencies can be analyzed between compilation units, packages or namespaces, or arbitrary elements defined in your code. So I can just make a source file based cycle analysis. I take all the C# files or Java files from my system and find out if there are cycles between each other. Or I can do that analysis by just making a namespace or package dependency graph and do an analysis on this level. Or I could basically do an analysis based on directories or something like this. The different levels of cycles I can calculate, but the most popular levels I can calculate cycle dependencies between are either the compilation units themselves or packages or namespaces. So in our case, we're mostly interested in compilation unit cycles and package level cycles. And smaller cycle groups with 5 elements or less within a package or namespace are usually not too problematic. So you can have smaller cycles. Some design patterns basically imply cyclic dependencies between different classes, but keep those cycle groups small. Less than 5 elements is a good idea. Less than 3 elements is even better. Try to avoid package and namespace cycles at all. So if you have cycles, try to isolate the cycles within a namespace or package. But as soon as you get to the package and namespace level, it's always a good idea to keep that structure completely cycle-free. Because then you can also use your package and namespace structure to basically connect it to your architecture in some way. For example, it's a very good idea. For example, if you think about domain-driven design, you can have your namespace naming strategy. You say start with your company name, hello tomorrow, then the project name, project X, and then the name of the domain, and then the name of the layer. So by just looking at a package or namespace name, you would know where you are in your architecture. The good news, all cycles can be broken. The bad news is most people don't learn how to do that. So that's something that you probably need to teach your developers in some kind of boot camp situation, or send them through some good architecture training so that they learn how to do that. I give you an example. So dependency inversion principle is a very famous way to break cycles. So that's a simple cycle between two classes. Class A and class B are using each other. And by just introducing an interface, I can break that cycle. So instead of class A pointing to B directly, it points to interface for B. That interface is implemented by B. And now we have a cycle-free dependency graph. That's why it's called dependency inversion principles. Interfaces are really good for inversing directions of dependencies. Another cycle breakup technique could be reorganization of your code. For example, we have, that's a classic example here. We have a customer class and an order class. The order knows its customer, and the customer is a convenience function. Find the order with number ID that belongs to me. Of course, the correct ordering would be that this find order function should belong to the order class and not to the customer class, and then you again get a cycle-free structure. There are other techniques too, like promoting and demoting dependencies up and down. So for example, if you have two classes that use each other, you can basically have a class above them that knows those two classes and basically internalize the cycle into its inner structure. Or you can do this with a class that is known by both of the classes in the cycle and basically demote it to the lower class. Well, let's look at some cycle analysis metrics. let's start with cyclicity and relative cyclicity. Biggest cycle group is also a good indicator. It's just a very simple metric, tells you how many elements are in the biggest cycle group. Structural depth index is a metric that tells us how difficult would it be to break all these cycles up. And let's start with cyclicity here. Cyclicity is a very simple metric. If you have a cycle group of 3 elements, its cyclicity is 9. If you have a cycle group of 10 elements, its cyclicity is 100. So it's a square number of its size. Very simple. Now we can add up the cyclicity for all cycles inside a module or inside of the whole system, and then you get a sum of cyclicity. And then you can basically calculate relative cyclicity for that container, which can be the module or the whole system, or it could even be a package, as sum of cyclicity, the square root of the sum of cyclicity divided by the number of elements multiplied by 100. So why is this metric useful, you might think? I can give you an example. Now let's make a little thought experiment here. Please follow me in your head. Let's assume we have a system with 100 source files. And the first one is using the second one is using the third one, and so on until we get to number 100, which is again using the first one. So in our head, we should have a big cycle having 100 nodes. In that case, relative cyclicity could be calculated as the sum of cyclicity. In this case, we only have one cycle of 100 elements. The cyclicity would be 10,000. The square root of 10,000 would be 100, divided by 100 would be 1. And then we get 100% relative cyclicity. So that's a worst case scenario. One big cycle comprising all elements, and we get the worst value of relative cyclicity. Now let's assume we have the same system, but instead of having one big cycle, we have 50 small cycles of 2 elements. Now if we do that exercise again, the small cycles have a cyclicity of 4, 2 times 2, times 50 is 200. The square root of 200 would be 14. So in that case, our relative cyclicity would only be 14%. Although in both cases, 100% of all source files are involved in some kind of cycle, but in the first case, it was a much bigger cycle. Basically, this metric tells us how bad is it. So if you have lots of smaller cycles, that's always better than having one big cycle. And that can be measured very nicely with relative cyclicity. That's why this metric is useful. Structural depth index is kind of the other side of the coin. There we try to answer the question, how difficult would it be to break up a cycle? And so we run a graph algorithm over the cycle groups. And for each cycle group, we compute 2 values. First of all, we find out how many links to have to cut to break the cycle group. And then for each link, we look at the weight of the link. So if you have a dependency between class A and class B, and class A is using class B in 3 different ways, then the weight of that link would be 3. If that's the only link we had to cut, our structural depth index value would be 13, because we calculate structural depth index as 10 times the links to break plus total weight of links. So in our example, if we had this one link with 3 dependencies, and that's the one that has to go, the structural depth index value would be 13. And of course, we then add this up for the whole module or the whole system. For each cycle group, we get a value. And then we're adding up these values for different scopes. Of course, that's a value you might want to track and then make sure that it's not growing. Because if this value is growing all the time, it means your cycles are getting denser and denser and harder to break up. Now, maintainability level is a way more complicated metric. We implemented that together with the customer. The idea was basically that's a metric we calculate per module. And for each module, we wanted to get a value between 0 and 100%. 100% would be perfect. 0% would be very bad. That basically correlates to the stomach feeling of developers about the quality of modules. And we let different inputs go into this metric. It should be stable when there are no major changes to the architecture or dependency structure. And it measures decoupling and successful verticalization. What is verticalization? Verticalization is domain-driven design. Basically, you first divide your system vertically by organizing it into different domains. And the dependencies between the domains should be minimized. So you have a successful verticalization if you can clearly see those domains in your code structure and they don't have too many dependencies between each other. And of course, reducing cycles and reducing coupling will improve the metric, and it's one of several indicators of design quality. Recommended value 75% or more. Definitely you want to keep it above 50%. 75% is already pretty safe. If you can keep it at 75 or higher, that's reasonable. Now let's see how we calculate that metric. So this is a simple dependency graph again up there with 12 compilation units. And we calculate first all the fan-in value maintainability level, fan-in MLL. That's a percentage of higher level components influenced by a given component. Now, if you create this graph, you see we levelize this graph. Level 1 has no outgoing dependencies. Level 2 has only incoming dependencies from higher level and outgoing dependencies to lower level and so on. But before we can levelize the graph, we need to basically condense cycle groups into their own logical nodes. So we have a little cycle group between FG and H here. So we form one logical node called FGH out of this cycle group so that we get a cycle-free graph structure. So let's calculate that fed in, for example, for node A. Yeah, A is used by E directly and by I and J indirectly. So I mean 3 nodes are using us. 3 nodes of 8 nodes in higher levels means 3 8s means a 37.5% value of fan-in ML for node A. For node E, the value is 50% because E is used by I and J, and that is 2 nodes out of 4 nodes which are in higher levels. So 50% for E. For all the nodes on level 3, we have a value of 0 because we have no incoming dependencies. Nobody's using us. So I, J, K, and L are the files that we can change without affecting the rest of the system. So that is where we should put our complicated logic. Put the complicated logic in files that have as little as possible incoming dependencies, ideally no incoming dependencies. Now you could argue if it doesn't have any incoming dependencies, it's not used by anybody, so that's useless. Not true. If your class is implemented by an interface, implements an interface, you can call that interface without calling the class directly, and the class itself might have no incoming dependency, but it's still used over the interface. The interface allows you a large degree of decoupling, and as long as you don't change the interface, you can change the code in I or J as much as you want without affecting anything in the rest of your system. Now we have different calculations here. For example, fan-in of this node FGA would be 75% because it's used by J, K, and L, which is 75% of those higher level nodes. Now, there are a lot more details to this metrics because there are also alternative ways to calculate it. There's a blog article which contains all the details here. Just go to blog.hellotomorrow.com and look for the keyword promising. You'll find the article about the metric that contains all the formulas and everything in detail. Because in reality, what we found out when we developed the metric, that first step wasn't enough. So we had an example from our customer Porsche Informatik in Salzburg, Austria, where they said, we have 2 modules here and both of them scored in the high 90s with becoming maintainability. One module was clearly well structured. The other one was hated by most of the developers. So we tried to figure out what happened there. And it turned out that in the second module, just the structure between the compilation units was pretty nice and almost cycle-free. But the package structure was completely random and chaotic. So basically the assignment of files to packages was more or less random. There was no system in there, which means it was very hard to find the code. And that created also a lot of package cycles that were just caused by the fact that classes were in the wrong package, and that makes it hard to understand and maintain a code base. So we also added an alternative calculation, which is based on relative cyclicity on the package level. And then ML ended up to be the minimum of those 2 values. Once we did that, we got the desired result. The good module still scored in the 90s, while the bad module suddenly scored in the 40s and not in the 90s anymore. So developing metrics can sometimes be tricky, but once you get to a good point, I would say in the meantime, maintainability level is a pretty good metric for assessing maintainability of code modules. Now, how do you get those metrics in the first place? You need tools for that. And there's a free tool I already mentioned, Sonargraph Explorer, completely free to use, also in a commercial setting. The only thing you need to do is to basically register on hellotomorrow.com and then get your free license, and you can use it, download it directly from the website and run it on your things. And maybe I'll have a little time. If I have a little time, I'm going to show you how to use it. I'm not sure. Let's see how far do we go. Short usage demo. Yeah, let's do that quickly. Yeah, unfortunately, my computer is a little slow with the software here, but I hope it will recover. Okay, now let's. So this is Sonargraph here. Let's open a system here. And I'm going to go to an open source system called Gradle. Many of you are probably familiar with Gradle. Takes a little longer because that streaming software is using some part of my CPU here. Now we have the data. Still some analyzers are running. And I should soon get to my dashboard here, which gives me some overall information. So this is basically the thing that you get also with Sonargraph Explorer. You get a structure dashboard here, which tells you what structural issues you have. That looks at entangled code and cycles. And obviously we have almost 78% of the code base is entangled in some way, shape, or form. But the relative entanglement, which is based on relative cyclicity, is not as bad. So the second red bar is much smaller than the first one, which means there's still hope regarding the overall structure. You can also see that if I click down here, I can see the metric propagation cost. It's at 4.5%, so that's a good value. Average component dependency is 396. That is basically 4.5% of those 8,800 Java files that are in this system here. So I can see propagation cost here. I can see maintainability level is at near the border where I feel uncomfortable. So what I would do next is here to basically go down into the metrics view and find out which are my problematic modules. So I go here, click on module, click on maintainability level. If I can find it. No, not propagation cost, maintainability level. That's the one. I'm going to sort inversely. So we have one module called dependency management, which has a very low level of maintainability. Let's see how big that module is. I can add lines of code as a second metric. So in this case, we have 77,000 lines of code. Unfortunately, it's also our biggest module. And maybe we can also add propagation cost just for fun. Propagation cost is not too bad here in dependency management, but maintainability level is low. Let's see where it comes from. So the next step, what we usually do is look at the cycle groups. And if I look at basic compilation unit cycle groups, I see, oh man, I didn't clean up from my last demo. I'm sorry. Give me a second. It's now recalculating everything. And here we have the component cycles again. And now we see dependency management has a pretty big Java file cycle group. So this you can still get with Sonargraph Explorer with a free tool. And if I open that, I can see which files are part of that cycle. Now, if you want to see the cycle itself visualized, you would need the commercial product for that. So if I can throw that in a cycle view, that it would visualize that whole thing for me in a way that you can see where's the cycle coming from. So different colors, again, represent different packages. Now, let's go back to our slides. Let's hope I can go back to presentation mode without waiting 5 minutes. Okay. Now, book recommendation. If you want to learn more about those metrics, shameless plug. I'm a co-author of this book together with 9 other people. So the book has 10 chapters. Everybody wrote his own chapter, and all the metrics I described here, plus some extra, are described in this O'Reilly book here. Now, how do we detect if a project turns into a big ball of mud? Collect metrics in your 90 build and track them. That would be the first step. And check for the size of the biggest cycle group. It should be 5 or below. It becomes dangerous when it's over 30 and becomes really bad when it's over 100. Check your relative cyclicity values. Should be below 10% ideally. And as soon as it goes over 20%, it becomes dangerous. And structural depth index. How difficult would it be to break up all the cycles you have? If that metric grows over time, all the time, then it points to a problem, which again tells me that you need a metric-based feedback loop. You need some mechanism to integrate those metric calculations into your 90 build. That can be done completely free. So Sonargraph Explorer also comes with a build integration. You can integrate that in your build to calculate metric reports. And then you can basically use, for example, Jenkins to display those metrics over time. Or you can use our commercial product here, Sonargraph Enterprise, which is basically a metrics database where you can upload metrics on a daily basis and then see how metrics are changing over time. How do we stop the big ball of mud? By just following some golden rules. First one is define architectural boundaries. Ideally, you use a domain-specific language. It's like something that comes with Sonargraph. Sonargraph comes with a domain-specific language to define architectural boundaries. But you can also use tools like ArcUnit or similar. Enforce them into your CI build. Make sure that your build breaks if something is not kosher. Do not allow package or namespace cycles and keep other cycles under 6 elements. Avoid God classes. So those big classes, more than 1,000 lines of code, are usually problematic because they also have their own gravitational pull. The bigger the class, the more dependency it will attract. And also limit local complexity. Don't write those God methods that go over hundreds of lines and are very complex to understand and read. The effect of the golden rules is that your modularity will always be preserved. Coupling is minimized. That increases code readability and testability. And also you end up with fewer potential vulnerabilities. And if you do that, your system will be better off than 90% of systems with comparable size and complexity. The most important thing to remember is the developers spend most of the time reading code. We know that in most development organizations, developers spend between 80 and 90% of the time reading code and very little time actually writing code. If you want to make your developers more productive, make your code more readable, more understandable, less coupled, and then they have more time writing code. This is a little example for an ArcUnit test. So ArcUnit is an open source system where you can basically define certain rules. For example, the rule no classes that reside in a package presentation should access classes that reside in a package persistence, and so on. And that will basically break your build if that rule is broken in some way. If you use Sonargraph's DSL, that looks like this. On the left side, you see the domain-specific language that comes with Sonargraph. Basically, an artifact is a box in an architecture diagram. The include statement tells us what is in the box, and the connect statement tells me what it can talk to. And then here you also get a very nice description of your architecture in form of a model. That is basically UML component diagram in text form, what you see there. The main difference is that Sonargraph uses a model-based approach. Basically, you create a model for your whole application. And models have a big advantage that as soon as you cover all your code with a model, everything that is not explicitly allowed is forbidden and will be found. So you can basically check for completeness of your model by making sure that your architecture covers all your code. With Arc Unit, that's a lot harder because it's just a set of independent rules that can be checked. So, and checking for completeness is difficult. But on the other hand, by all means, using Arc Unit is much better than not using Arc Unit because that allows you to define architectural boundaries. It's just not as comfortable and luxurious at what you can do with a DSL. Okay, how do we improve an existing big ball of mud? First of all, it's a good idea to find out which parts of your code base are actively worked on. There's no need of resolving cyclic dependencies in a code base that hasn't been touched for the last 2 years, because then it's stable and then doesn't need to be done anything. But if you have code that is actively changed and very complex, then this is where you should focus your improvements. And the first thing would be to basically find out if you can reduce package cycles. Package cycles are worse than component cycles. And then if you have those big compilation unit cycles, also try to make them smaller. Breaking them up into smaller cycles is already a good gain. And we have some tutorial videos on our website that explains this process. I see I'm running out of time. We're almost at the end. I have to go a little faster here. Having an architectural model is always good. And once you have an architectural model, you can track your progress and see, by just looking at the metric, you can see if things are moving into the right direction or not. There's some source code management metrics that are really interesting. Basically, metrics derived from a version control system, change frequency, how many file changes did we have, how many commits, how many lines have been changed. What is the code churn rate, the lines that have been changed in relation to the total number of lines in your code base, and how many different authors have worked on a piece of code. And that can, at the end, lead to this hotspot map here. That's a 3-dimensional visualization of a code base. Each of those little blocks is a building, a source file. The ground area of the block of the building is proportional to the lines of code, and the color and height of the building are assigned some arbitrary metrics. In that case, we have assigned complexity to the color, and height is the change frequency. So what we're looking for would be red skyscrapers. That's basically is based on Apache Cassandra. We don't have a red skyscraper, but we have a pretty big dark red building. That's basically the core class of Apache Cassandra that is changed frequently and medium complex and pretty big. So that is something where you may be focusing refactorings on. Okay, so much so good. 2 minutes left for questions.
All right, Alexander, thank you so much. That was a very clear session, right? I bet no one was actually expecting to have a session like that. Thank you so much for doing that. We have quite a few questions in the comments. I'm going to
think I can also stop the screen sharing here.
Yeah, what I'm gonna do is I'm gonna start picking some of the questions. The first one is by Avinash. He's asking, I know you have covered it already, but he's asking, what are the ways and tools that can help in understanding code that is part of big ball of mud? I know you have covered it, but I still wanted to read this question.
Yeah, you need a tool that basically allows you to visualize your code base. And there's certain tools out there. Sonargraph is one of them. There's some others out there, but I think Sonargraph is the leading one in that particular area when it comes to code visualization and making sure that and metric calculation in a combination, basically.
Perfect. Okay, there's another question coming from Pavel. I cannot read his last name. It's regarding your slide number 8 about CISQ. Do you have any insight about numbers from the HW development? Is it a common issue or only software architecture industry is affected by this in such dramatic way?
In that case, those numbers were specific for the software industry, not for hardware development. But of course, it includes probably embedded software development, so which is close to the hardware. But all of those, slide 8 was only talking about software projects, so software industry in general.
Okay, that's exactly for software industry. All right. We also have another question from Sophia, and it goes like, how can we effectively refactor an existing big ball of mud into a more modular and maintainable architecture without causing significant disruption to ongoing development?
Well, the last part of the question is an interesting one, because of course, if you break up cycles, you might have to change the structure. Sometimes you might have to even move files around, move file from one package to another. And that is always something that basically messes up your repositories and might create merge conflicts and all these kind of things. So what I recommend is something like to have a code hygiene Friday. I think that's a very good idea. One day per week, or maybe every 2 weeks if that's too much for you. They spend 1 day to do nothing but improving the structure and hygiene of your code base. And then you do it together as a mob programming action. So basically somebody shares the screen and everybody works together, and you're committing those changes together. And then in the end, everybody updates, and you shouldn't have a lot of merge conflicts. That is something I would recommend. It's still, of course, it's tricky because people might have feature branches that are not integrated with those changes. The other thing I always recommend is to integrate develop as often as possible if you're working on a feature branch, to make sure that you're not deviating too much from the main development line. And by the way, there's a nice video on our website also. If you go to the hellotomorrow.com, I can basically try to copy the link inside the chat if I can, if I find it.
You can give me in the private chat. I can put it in the comments and everyone can go there.
Okay, let's go here to take a tour. Where is it? Take a tour. Breaking up cyclic dependencies like a pro. This copy link address, and I will put this in the private chat.
Yeah, I got it. And I put it in the comments. Yeah, everybody has it. So I hope that helps. There's also another question coming from Deepak. He's asking, what role does automated testing and continuous integration, CICD, play in maintaining clean and well-architected code base?
Okay, automated testing is a completely different topic, but of course it's also very important. You need to have automated tests as much as possible, so that's always a good thing. But for the clean and well-architected code base, the only way to do is basically have a tool integrated in your CI loop, like Sonargraph or Arc Unit, that tests for certain structural issues, compute certain metrics for you, and keep those values under check. If a value goes bad, if somebody adds new cycles, adds new architecture violations, in my company, for example, that would break the build. So we have a very clean code base, almost cycle-free, because we always break the build if something happens that we don't like. You can automate it, and actually I highly recommend the automation, because otherwise you always need that poor guy who's working with the tool and checks the code base every weekend to find out if new catastrophes have been added. And that guy won't like that job very much for a long time.
That's right. I think this is a case scenario that happens everywhere and in every project. We'll take one final question. I know we are almost on time for the next session. There's another question coming from Pavel. I think I like the way he's asking with slides. He's saying, regarding slide number 12, what about the creativity and individuality of the developers? Do you think it has also a certain effect?
Yeah, that is a classic topic, of course. Because first of all, in every team, we have developers of different creativity, different skill levels, different experiences. So it's always having a group of developers is almost like herding cats, right? So because they also have egos, that come into the thing. And most developers have a strong opinion how code should be written. And those strong opinions don't always overlap. Sometimes people have very different opinions. And I think important in a group environment is first of all to basically try to bring everybody on board. Means you do those mob sessions from time to time where you look at the structure of your code together, like we did right now in this little demo, where we look at the structure together and then discuss how we get out of it. Because at the end, all those different inputs and perspectives are good and important because everybody looks at the problem from a different angle. But the decisive point is at the end that you discuss the problem and then come to a solution that everybody can accept. And then everybody follows that solution. And that's a step that is very often skipped because it's a hard step. It's a hard step because it requires a discussion. Sometimes there are fights about how to do this. Sometimes people even fight about where the curly braces have to be placed. Yeah? So there's all kinds of fights about this. But if you want to have a coherent, good project, by all means, have the discussion. Let all different perspectives flow in how we solve the problem. But in the end, agree on one solution, because what often happens that those conflicts are not solved, then everybody works according to their own taste.
That's right.
Which means at the end, you don't have a congruent code base, because you can basically, by just looking at the code, you know who's written it. And that's not a good thing.
That's right. With that, Alexander, I think it's time we wrap up and move to the next session. Any final thing you want to say to the audience and everyone who's tuned in?
Yeah, just if you keep one thing from that presentation, look at cycle groups, keep them small. Just that little change can dramatically improve the outcome of future projects.
All right. All right. Thank you so much, Alexander. Thank you so much for doing with us. We'd love to have you again when you're available, and have a nice day. We'll see you on the evening.
Thank you very much. That was fun.
Bye-bye.
Talk to you soon. Bye-bye.
Bye. All right, everyone. That was Alexander for you. The only session in this entire conference that was for about an hour. We don't have any sessions for about an hour. So that was almost like 2-hour session. 2 sessions right there. Can I say top class? I know. It was top class. No one was expecting a session like that. So thank you so much, Alexander, once again. We now move to our next session, and that is by Koushik Sundar. And Koushik Sundar is a vice president at Citibank. Wow, what's happening? It's so cool. So, and Koushik is going to actually talk about enhancing microservices with Kafka, a distributed messaging solution. I think this is quite popular among these days. So without any further ado, let's bring our next speaker, Koushik, to this conference.
Hey Simon, how are you doing?
Hi, Koushik. Welcome to the Software Architecture Conference.
Hey, Simon. Thank you very much. It's a pleasure to be here.
Yeah, thank you. Thanks for accepting the invitation, Koushik. I really appreciate it. Quick question: where are you joining us today from?
I'm right now in Seattle.
Okay. Wow. So it must be quite early morning for you, isn't it?
Yes.
So I know it's a work day, so I won't take much of your time, Koushik. Please feel free to go ahead and share your screen, and then we'll do chit chat towards the end.
Sure, Simon. For some reason, I'm trying to share my screen, and it's taking a little bit of time.
Yeah, it's okay. You can click on present. When you click on present, you say share screen, and then you click on entire screen. And yeah, I think I have it coming my way. All right, I see your slides up there. If you go to the presentation mode, I can start it. Yes, and maybe you would like to click on that hide button that says, so that removes the pop-up on the screen. There's a button that says Streamer is sharing. Please click on that hide.
Yeah. Sure.
Yeah, there it's gone. I have added your screen to the stream. Everybody else can see it, Koushik, and next 35 minutes is all yours.
Hey, Simon. Looks like I lost you.
No, Koushik, I'm saying next 35 minutes is all yours. You can go ahead and start to present.
Oh, sure. Thank you very much. So, hi, everyone. Good morning, good afternoon, good evening. Just a bit about me. Simon already spoke about this, so without wasting time, let me quickly jump start. I'm going to cover the basics first, considering the audience from the various background, before we deep dive into the session. So what is microservices? Before we talk about microservices, we have to understand what is the current challenge and what are the monolithic applications. So for more than a couple of decades, the standard way of developing application is using monolithic architecture. That is, all the components of application are in a single code base, and the scaling and deployment of the application done as one unit. This means the application must be written in a single language with completely one tech stack, and entire global team working on different parts of the application still then have to coordinate better. Okay, this way of standard development of applications and is complex, and especially it's even becomes massive when the application has to be handled across global teams. The first of all this, the main challenge is the coordination among team members is difficult, as the code base are more tangled. Okay, and if we need to scale one particular functionality of the application, we cannot do, because we need to develop the entire stack of the application together, and we have to scale it up all together. So this means we will have higher infrastructure cost, more challenges, and the entire unit has to be compatible, and everyone have to be on their toes to support the application. And the other challenges, if we are using a third-party jar, and say if one functionality needs, let's say, version 3.6, and another functionality says needs version 1.8, then we cannot have two versions. We need to either use one way or scale up our application and fix the bugs or make it scalable to support the other version. A couple of years back, we had a Log4j vulnerability, and if you remember, there was version 2.14, which was the version which found vulnerable, and they were supposed to upgrade to 2.17, if I remember it right. So the entire application has to be scaled up if we are using a Log4j. And if there are any dependent jars which is making use of this particular version, then we need to work around it, either to handle those jar files separately, or make it as an exclusion, or come up with an innovative way and do a patch on the hack just to keep those components aside. And these all increase our turnaround time and the complexity of the application stack. And this is where all this leads to the microservices architecture. So here in microservices architecture, so we are going to break down the application into multiple smaller applications. So this is like several micro applications making up the big one application. The breakdown of the application into microservices is purely dependent upon the business functionality and not by technical component. So microservice of an e-commerce or a shopping website, just for an example, let's say a product, shopping cart, or a user information, checkout and payment will all be a separate microservice components. So in terms of size, each microservices can have an isolated functionality. So one service will do one specific job. And another important criteria while we are working on microservices is that it's loosely coupled and independent. So we can independently deploy and scale each functionality or the services, and it gives a greater flexibility, and they can have their own versions without depending upon the other component. This makes it opening up a wider platform to support different programming languages. So if I'm going to integrate a machine learning component into my functional application, I can have it in a Python, where rest of my application can still run in Java. So this makes it completely agnostic to the underlying programming languages. If one microservices goes down for whatever reason, the application is still functionable and the rest of the components can support it. Say, if the payment services have some glitch, still people can view their products, add to the shopping cart, and they can check out at a later point of time. In addition, when we design microservices, these are some of the basic characteristics and the designs of microservices, which we have to consider it, like the isolation part and statelessness. So to talk about statelessness, The microservices, it's good to have it as an idempotent. That is, if a message comes multiple times, the functional and behavior of the microservices will be good to mimic the same output. So every time a same message replayed into a service, it will yield the same output. And event-driven makes the microservices more robust and functionable. And a lot of organizations, including from my past experience, we are heavily on event-driven. And performance-wise, this is highly scalable because we can scale up the pods, or in respect of whether you are running on a Kubernetes or any other platforms, you can independently scale up them, and you can deploy and decentralize the components. So it gives a greater flexibility. So how do microservices communicate? That normal traditional way where a lot of applications goes through the API calls. That is, if they expose a HTTPS port open, so one services can send a request and probably will wait for an acknowledgement from the other service through an endpoint. This is very common, and this is an synchronous way. That is, each component has to wait for a request and a response, and it needs to be processed. Next is the messaging broker, which we will be going to deep dive after this one. But just to give a high level, service one, let's say a shopping cart publishes the list of products in the cart to a messaging broker, and the consumers, like a dispatcher or something, will consume them in the sequence or in whatever order, how we are defining it, will process that order and will dispatch it. So here the service one is not dependent on service two, how it is being processing the messages. So the role of the service one is just to publish the messages. It's done, and it will move on to its next functionality. And service two, if it is just about consuming it, it keeps on consuming and processing whatever it's intended to do. This way, it is asynchronous and event-driven. And the third one is the service mesh, where there will be a sidecar container acting like a proxy service within a container along with the application service. And it will be connecting to a control panel, which is network managed, and they will be handling this communication part. And this is quite widely popular and is also used. But which one to make use of is also dependent upon the application architecture and the functionality. So what is Kafka? How it is connected to the microservices? Kafka is a messaging broker. Eventually, it was originated in a LinkedIn platform and handed over to Apache Software Foundation as an open source. It is a distributed message streaming platform, and it can handle real-time data feeds with high throughput and low latencies. And it is more preferred message broker in microservices architecture due to its robust features and ability to manage large volumes of data efficiently. And based on my experience personally, we have done handling millions of transactions every single day, and we haven't seen any single latency issues or throughputs purely from a Kafka broker perspectives. Kafka supports both publish subscriber and queuing model, which makes it more versatile for various use case scenarios. Let's take an example, right? Again, I'm sticking to the same e-commerce or shopping website. So I'm picking up two users' names in random. Let's say Adam is a confused consumer who likes to add many items to his shopping cart and then removes it and adds back a different product. So there is a sequence associated with the items he is ordering to it. In parallel, let's say John is very aware of what item he needs. He just goes and adds the item, whatever he wants, to his cart and checks out. So we have two users placing their order, and they can be processed in parallel. However, the orders items placed by Adam has to be processed in sequence because he added an item, removed it, and then added something else back. If this sequence is messed up, his product, whatever is going to get delivered, will be impacted. So in case of Adam's order, the sequence has to be maintained. And however, Adam and John orders can be processed in parallel. So this is where Kafka is, even more versatile and supports this scenario. In Kafka, we have something like partition key. So this is what we are going to go a little bit deeper here. So partition key is the one which is associated with every single message and defines in which partition they will land up with. So Kafka have two major things. One is the topic and second is a partition. Topic is the one, it's more like a channel. And within a channel, we can have multiple partitions. If we say checkout to delivery, then that can be a topic. And within those topics, we can have multiple partitions. In this case, it can be one topic for checkout to delivery, and Adam's order and John's order can go into multiple partitions. And within the partition, we can define the partition key. This is what will guarantee the sequence. So Adam's order will go in the right sequence and will get fulfilled on the consumer side, define as long as the partition key is properly defined. So this way the sequence is guaranteed. Just to talk about this architecture flow, right? So here on the left-hand side, you will find the producer, where I listed few services. And on the right-hand side, there are consumers. We can see a list of consumers taking the messages. Here the producer is, this is an asynchronous architecture. So the role of the producer is just to publish the message, and consumers will consume and will process the message as per the functionality. Here the producer is not waiting for an acknowledgement or anything from a consumer. The only latency is producer will get an acknowledgement from the Kafka brokers that the message has been published. And consumer will consume in whatever capacity they can. And let's say the functionality of the consumer is very massive, and then we can scale up the more consumers without impacting the producer. So here I just listed 3 Kafka brokers. Normally the Kafka brokers are selected in odd numbers, and the number of replications, or eventually you can have all replications, or at least like n plus 1 by 2, so that you will have better replications in terms of one broker goes down. So I'm going to cover about the replications in a bit later, but let's stick to this one. So here, each broker will have all the topics. So if we have, let's say 5 topics, all the brokers will have all the 5 topics will be created on all the brokers. And each topics, let's say we have 3 partitions, then the leader for a partition will be, won't be across one particular broker. It will be divided across the brokers. This way, there is more fragmentation and it is eventually distributed. So in this example, if you can see the partition 0, broker 1 is the leader, and in broker 2, it is for the partition 2, and broker 3 is for partition 1, whereas the other brokers are replicated. This way, the one broker is not overloaded. The functionality of the broker and things are equally shared, load balanced pretty much, and they can replicate. And how many replications we need for each messages, this is again to ensure fault tolerance, we can define it. And if say one broker goes down, then the rest of the 2 brokers, as long as they are replicated, will elect a primary leader and will start supporting the functionality. And Zookeeper, as it says, it's just to ensure the Kafka brokers are connected and scaled up. Now, one producer can publish to one message, or there can be multiple producers publishing to one topic. So that's why I just captured a few services here. So the service 2, which is like considered as like 2 instances of a microservices, which can produce a message and can publish it. So this is where the scalability comes into the part. If you're going to increase the number of pods to scale up, then this will support that functionality. And same way, on the consumer side, I can have one consumer, and if I need to scale up to increase the throughput, I can scale up the consumers. And when the consumer group is unique, then the microservices and Kafka eventually goes hand in hand here. So we can divide the partitions to the different consumer threads. So the service 2A, let's say it's like the order fulfillment, can consume from partition 0 and 1, and second one can consume, the second instance can consume from partition 2. So Kafka resilience and high availability is this what we have wanted to deep dive. So it is highly fault tolerant, and there are a lot of disaster recovery strategies which we can make use of. So this is where the partition things will come into the picture. In addition, we are replicating the brokers, right? In also the clusters can also be replicated across different data centers. So how it is, before we talk about the disaster recovery, how it is fault tolerant. In general, Kafka passes the message to the disk, which ensures the data durability and also ability to reprocess them. Internally, within the cluster, we can choose a number of replications. And to make it even more replicated, we can have mirror maker or Kafka replicator. So if we have two clusters, say one sits in NAM data center and another cluster sits in EMEA or APAC data center. Now, one cluster generates a message which acts like a primary, and your disaster recovery systems is somewhere sits in a different data center. Then the mirror maker can connect these two clusters. They will be replicating the messages from one cluster to the other. And if we have some network alias, wide IPs or something, then it makes it easier. So if this cluster goes down, seamlessly it will connect to the data center cluster. This way, the microservice is completely loosely coupled from the underlying infrastructure components. And scalability wise, so there are two major things we can handle with. So first, to talk about is the vertical scaling. So vertical scaling is like adding more CPU, RAM, that is the memory, and the disk space, so that if the cluster runs slow on the underlying infrastructure components, then we can scale up them. Whereas in the horizontal scaling, we are actually adding more brokers to the cluster. So earlier we saw like a 3-broker cluster. We can make it like a 5-broker cluster or something. But the downside of this is either of this approach will, need some downtime, which will impact the functional components. And especially it depends on whether we are running on a bare metal for a vertical scaling, then it needs a reboot, or it depends on the virtual machine. And something that's becoming popular in the recent time is elastic scaling. So just like how the microservices application architecture runs in a microservices environment in the cloud, the infrastructure components can also run in cloud, which will enable it to scale seamlessly, adding more brokers to the cluster or having multiple clusters interconnected. This way, it reduces the downtime, or literally to say theoretically 0%. So the applications will always be connected to Kafka brokers, and they are all load balanced. So either of the cluster or brokers will be available to serve the components. And to talk about the utilities, I'll try to keep this short because we'll have some time for the questions. So Kafka offers KSQL. That is, we can go and query the messages using a KSQL DB, through which we can extract some valuable insight. And normally, this is not widely used unless there is a specific use cases. And a lot of enterprise architectures normally serialize the messages over Kafka, like Google using Google Protoprof or something. In that case, this won't come handy. As long as if we are using a string or JSON serializer, this will work, where we'll be able to query using the raw language. But if it is serialized, then this won't be very efficient, and it will increase the load on the brokers. Kafka Connect is like a utility tools where we can source from a different components like a database or Elasticsearch and publish the messages to Kafka, more like an utility out of the box without developing a component altogether. Control center is something very critical, because this is where we can monitor the health of the cluster. We will know how many consumers or producers, how their throughput, what is that range, and if there are any lags, we can dynamically scale up the consumer pods. So this gives, and we can even generate alerts. And if we integrated this with the microservice component, we can sense, okay, the throughputs are increasing or it's low, and that means we need to scale up more consumers to increase the throughput so the lags can be drained faster. Replicator Mirror Maker is the one we just covered a bit. So this is mainly for the replication across different clusters or data which might be residing in different data centers. So benefits of using Kafka in the microservices part. This is the high throughput which we were talking about. It can handle millions of transactions seamlessly. We are talking about in seconds. And in general, Kafka can have one broker in a cluster can handle 4,000 partitions. And if we are talking about a 3-node cluster, we are talking about like a 12,000 partitions. That 12,000 partitions can be across multiple topics, which makes it more robust to scale based on the application needs. And their fault tolerance and the message and durability wise, they are persisted in the hard drive. So it's easily recoverable, and it decoupled the microservice components and mainly for the real-time processing. So using the partition key, we are ordering the messaging orders, and there are all replay capabilities where we can republish the messages. On the consumer side, there is something called like a consumer offset number. So when a consumer consumes a message, it updates the offset. This way the broker knows, okay, this message has been consumed. And if we need to replay messages, obviously we can go and reset the offset to whatever number or to the beginning, and we can replay the entire messages. And in case if a consumer goes down, the broker will hold the messages as long as the consumer group name is same. And when the consumer comes up, it can start consuming the messages. So the messages are not lost, and the offsets are maintained properly. And with Kafka, we can also have the streaming processing, which is the Kafka streams, and where we can go by that window-based to aggregate the messages, or based on the rule where we need to drop certain events. This comes in handy when we want to ignore certain messages or aggregate certain events by time window. But one thing with a window-based approach is like the window should be a little smaller, because that's going to put a lot of stress on the broker, because it's constantly holding the window for the messages to handle. And if there is a high throughput messages, high volume applications, then we are increasing the complexity. Now, that being said, if there is a necessity to do that, there is a other component that's where it comes, Flink. So Apache Flink is something where it offers a big data kind of streaming. So if you are heavily dependent on streaming for a batch processing, then this is not the component where we need to build it. We can switch out to the Flink. So some tips to handle. Avoid delaying messages. Like I said, do not build the messages or have a large window for the messages to hold it across. So this will increase the stress on the broker. And Kafka is mainly for the real-time event-driven application. So stick to that part. So it was good in that case. It's not a caching solution. So there have been scenarios where I have seen people using it for caching, using a key value kind of pair. No, go for a distributed caching solutions. That could be Redis or MongoDBs or a bunch of things available based on your application needs, but it's not for Kafka. And when we talk about microservices, right, a lot of people have a dependency on database for static data or to persist the messages. It will be good to decouple them, have its own separate microservice layer, and use the Kafka to publish the messages. This way, if there are any underlying bottlenecks with your database layer, where it can process only certain number of messages for insert or a trigger based on the complexities. It is decoupled, and the application can still run on the caching solution. So KSQL, Kafka Streams, and Flink. So this is the part I was covering, mentioning a little bit earlier. Flink is from Apache Kafka, which is for big data streaming and analysis, which is efficient if you want to have a batch or real-time streaming, and it has its own pros and cons. So, but definitely Kafka Streams and Flink have their own use cases. Do not use Kafka Streams for analytics or holding the messages for batch processing. Instead, go for Flink. And KSQL is for querying the messages. Unless there isn't any dependency, it's not widely used. Then be mindful while defining the number of partitions and topics. So what does it mean? As I said, each broker have a limit of 4,000 partitions. And if we are creating one topic with 100 partitions, then eventually by the simple math, then we are limiting the number of topics we could create. So create a partitions, and you can increase the number of partitions as there is a need for the application to scale up. I'll go for Q&A and will stop sharing my screen.
Thank you so much, Koushik. I would encourage you to go ahead and grab a glass of water. You have been speaking very continuously, and I also know it's early morning, right? So it's so, yeah,
So
that was great.
I just recording from a bad cold, so my throat was sore.
Yeah, I
I was
get
trying to
that. I'm so
manage.
sorry for it.
No
Okay,
worries.
so we have quite a few questions, right? Let's start from the beginning. There's one question by Ganesh is asking, which is best between Kafka and Service Bus? I know it's very tough to debate, but which one would you recommend?
So I would prefer Kafka if it
Mhm.
is an event-driven application, because it's real-time and seamless. And Service Bus is good, but if it is more like a web-based applications where you have proxy layers, a lot of cross dependencies. And another thing with the Service Bus is like it acts as a proxy layer, and each it's like a sidecar container that sits with the microservices. So there
Mhm.
is also an overhead of maintaining it. But again, there are a lot of vendors support a proxy layers on this service mesh. So if we are going for a vendor solution, then that overhead is taken. But if you're going for, again, a real-time event-driven, Kafka is out of the box, and
Yeah.
that is exactly what it is intended for. So let's keep the architecture simple.
Oh, that's right. I like your last statement. Let's keep the architecture simple. That's good. We, so we have another question coming from Rohit. I think it's very technical. He's asking, how do you ensure messaging ordering consistency when using Kafka in a microservices architecture with multiple pods and JVM?
So messaging order, this is where the
Mhm.
partition key comes into the picture. So right partition key is a critical, and if we mess up with the partition key, then the order will not be maintained. Um, so um, we have multiple applications and a lot of pods that scale up dynamically. And if the partition key is not properly defined, what will happen is in a multi-threaded environment, the same messages will be replicated across multiple partitions and the sequence will be messed up. So when the consumer is should be an idempotent consumer, it should be stateless. So it
Mhm.
may not know whether it's processing the same messages again and again, or it is one-time event, and which is a good in a way, because it keeps it simple. But now that's where the dependency on Kafka is increasing in maintaining the partition key. So if we define the partition key properly, when the producer publishes a message, it goes into one topic and one particular partition. It doesn't matter how many subsequent messages, like an amendment or a cancellation or anything that deals with the messages based on your application business nature, will go into the same partition. And on the consumer side, we have the consumer group, which is tied to a bunch of consumers. And when they register to Kafka, the Kafka cluster ensure the brokers that these messages are in single partition and they are sent in the right sequence based on the partition. So when a consumer consumes a message, whether irrespective of how many times it goes down and comes up, or even if we scale up the number of pods or the instances, then one partition will be assigned to only one consumer thread. So the messages are guaranteed in the sequence. Say, if one message is consumed, like an initial order placement, and the consumer goes down, and we scale up a different instance or a pod in a different VM cluster or somewhere, broker knows that the message offset is moved, and the subsequent amendment and cancellation was still in the same partition in the queue. And when the consumer comes up, it goes and consumes the message, which will be the cancellation, and then probably followed by an amendment. So that's how the sequence is guaranteed. And that's where the partition key plays a critical role. And if we mess up with the partition key, and then the sequence is not guaranteed.
Wow, very well answered. That is a very detailed answer. I'm sure Rohit wasn't expecting that. So it went over my head, to be honest, but I hope Rohit got his answer. Okay, so let's take another question coming from Sri Verma. I think he's one of our speakers, if I'm not wrong. He's speaking the other day. Tomorrow he's speaking. He's like, how can I prevent data loss when using message brokers like Kafka?
So Kafka using persistent message disk, normally they go for solid states or something. That's where the messages are persisted in a solid layer. And in clouds, there have been elastic Kafkas that is being offered by a lot of vendors now, more like a Kafka as a service. So that's overhead is taken away from the application development team. But I will keep that as a separate topic because that's have its own pros and cons. But if you are maintaining your own cluster, it goes in a solid persistent messages, and that's why it's saved. And producer, there is a, in terms of producer, when a producer publishes a message, there are certain configurations like a producer configuration where we can ensure whether a producer needs to wait for an acknowledgement from a broker. So there are configurations where to say at least one ACK. So that is when a producer publishes a message, it can wait for a broker to say it received the message. That is one acknowledgement. Or it can wait for the broker to say that it received the message and replicate it to all the replications across the cluster within the brokers based on the broker settings. So this way, the data loss is prevented. The producer will know now this message has been published. And that when we say producer, the producer jar, which is again comes from the Kafka libraries, will ensure this based on this configuration, whether ACK all or ACK 1, the message has been published. Else, it's going to retry publishing the message. So that complexity again is not on the application team. So they have been well defined by the producer jars. We just need to make sure how we are tweaking the configuration, whether we want one acknowledgement or wait for the all acknowledgements. It comes up with the performance impact. So if we have one, then it's going to be quicker. If we are going to all, and imagine if you have a seven broker Kafka cluster, then you are waiting for the message to be replicated across 7 brokers and to receive the acknowledgement all. So how you tweak, it also depends on the number of brokers you have and the performance of your application.
Wow. That was nice. So there's Ganesh, the question you just answered. Ganesh said, great answer. He has not used Kafka, but both have their case-based importance. So thank you. So I think you're answering all your questions. Great. I won't take much of time. There's another question coming from Deepak and a few more. Perhaps you can come to YouTube or maybe reply, or maybe it's okay, we can do it some other time. Koushik, before we move to the next session, I'm asking this question. I'm trying to ask this question to everyone, right? That is, other than all this, all this tech stuff and all that, what are some of your hobbies? What do you do when you're not coding or you're going to office?
I'm just starting with my fitness thing. So I haven't spent a lot of times on fitness, but as you grow older, so that's where health comes into the part. So I want to stay healthy and fit. And I have a son, 8 years old. And that's where I realized when I have to chase him and play with him, that I need to be fit enough to accompany him. And that's why I spend my other time. And I love reading books. So
wow.
I sit with him, read books with him, and also that's like our daily routine to read on some books and
Yeah,
to maintain the sanity part, just to stay
that's
away from the devices.
that's lovely, Koushik. So, how often do you visit India? When was the last time you were here?
Hey Simon, sorry, my network is choppy. I missed your last question.
Yeah, I was just asking, how often do you visit India? I mean, when was the last time you were here?
I have been there last year, visiting my
Yeah,
family.
yeah,
So India trip, I always look for a longer time,
yeah,
because 2 weeks or 3 weeks is way short.
yeah.
Just going on jet lag something, and we have a lot of things to do, right?
That's right,
And
and
especially when you are in your home country, catching up with
yeah,
family, time
that's
flies.
right. Yeah, and Diwali is coming soon, so perhaps if not this year, you should plan next year, right? So everyone excited. So Diwali is in October, so maybe that's a good time to come once again.
Yep,
Yeah.
definitely.
So Kaushik, thank you so much for doing it once again. I really enjoyed it. I loved the pace of your session. Very calm and composed. Thank you so much for doing with us. Let's stay in touch, and I'll see you in some other live and virtual events. Have a nice day ahead.
Sure.
I think, yeah. All right. So I think he has some internet problem. Never mind. So, all right, everyone. There was Kaushik for you to talk about Kafka. We now move to our next session. I know I'm already into the next session. Our next session is by Edward. He's a Microsoft MVP and a data architect, and he's going to talk about quality AI requires quality data. It is an interesting session title. So, without any further ado, let's bring Edward to the conference. Hi, Edward.
That was
Welcome to
nice
the
intro.
software.
Thanks.
Tell me, you weren't expecting that, right?
Not at all. That was way fancier than I would have expected from myself. So good job.
Yeah, thanks to the other teammates who have done it. So thank you so much, Edward. I already love your background. Is that your home library?
Yeah, this is real. I experiment with all kinds of like made up backgrounds, and people just enjoy looking at the individual things back there and pointing them
Yeah.
out and talking about them. It's a great distraction from anything important they may otherwise talk about. But it's kind of fun to have a little, personal stuff in there. But no security breaches back there. I promise. You can look. No passwords.
All right, Edward, I think I'm going to enjoy your session. I know I'm only 2 minutes in your session, so I'm not going to take much of our time. Please feel free to go ahead and add your screen, share your screen, and then I'm going to add it to the stream. And everyone's watching in, please feel free to go ahead and drop your question in the comments. We're going to take it towards the end of the session. And yeah, I see your screen, Edward. I'm going to add it to the stream now. Perhaps you want to click on that hide. Your streamer is sharing your screen. Would like to click on that hide button, link,
What
whatever it
button?
is. On the screen, there's a label that says StreamYard is sharing.
Oh, I see.
There's
I see.
a
Hi, I
floating.
see.
Yeah.
Okay. There we
All
go.
right.
No
All
problem.
right. All right, Edward. Next 35 minutes is all yours.
All right. Well, thank you very much for having me. This is exciting. This is a topic that is both old and new. Data quality is nothing new. We've been dealing with it for years and years and years. Even before databases existed, people had filing cabinets full of paper, and there were sure to be mistakes inside of them. And so data quality is an eternal issue we've been dealing with forever. It doesn't stop being an issue, but the more downstream things we do, the more complex our usage of that data gets, the more ways we have to muck it up and make our lives very difficult. So our goal here is to talk about data quality through the lens of AI. That is, we're going to throw complicated algorithms at our data. What does that mean for data quality? I'm going to move kind of quickly. My goal is to save some time at the end for questions. Those questions are great. But if there aren't any, we can also just chat and have fun as well. So I'm just going to dive right on in very quickly. I've already gotten the intro. This is just more stuff. I will skip it because we already got a cool intro. The agenda is straightforward. Really, we're going to talk about data quality, the classic problem, how to solve it, why it matters, and then what are all the things we do in AI that make our lives more difficult because of this. We'll bring it all together at the end and save a little bit of time for questions. So this is an example of a software development lifecycle. There are many out there. Different organizations, different sizes have different variations of this. If you're a small organization, you have a little less. If you're big, you may have more. But the basic idea is there's design, there's architecture, you build some software, you test a whole bunch, iterate, and eventually deploy, maintain, so on and so forth. And there's a lot of arrows, a lot of boxes, and these are all here primarily so that we make good decisions. We add quality new features, make good decisions, make few mistakes, and then release something that users love, right? That's the whole point of software development. But where that is kind of where a mature product would behave in terms of how we go from an idea to code in a production environment, what very often happens in AI is a little bit like this. Not exactly, I'm exaggerating, but it's funny, right? Somebody comes and says, we want the bright, shiny new thing now. And you say, okay, when do you want it by? And they say next week, and you work really fast and a new feature goes out and it's cool because the new shiny thing's worth a lot, right? And so very often we skip steps. We hurry, we skip, we do everything we can to get things out, and that's dangerous, right? We're skipping a software design lifecycle. So part of this entire conversation is that we should treat anything we develop in AI to be very much like any other software development, right? It's just features. In the same way that database development is just development. Software development is development. AI development, machine learning algorithms, analytics, dashboarding, all those things that we do with our data later, it's just development. So treat it like development. If you do what I show on the screen right now, things may not work the way you want them to. You'll get some surprises that, surprise cake for your birthday, good. Surprise bugs, not so good, right? There's more challenges though. What are the challenges we face with data and AI? And these are common challenges, some of them. For example, data grows, right? Data gets bigger. It always gets bigger. We have more databases, more data, we have more data sources, and it can be from anywhere, right? Data begins somewhere. It begins in a transactional database, in edge devices, in some data source element place somewhere where it's being created, and then it exists, it's used, right? It's used by applications, used in UIs, used by users, used by people. But then more things happen to that data. We begin getting bigger and asking more questions about our data. And so we begin copying it. We make replicas of it. Maybe we'll do some transformations of that data to make it easier to report on. We want to provide dashboards and reports to users or to internal to an organization or to executives or to who knows who else, shareholders. There's a million places that data can be used. And so after transforming it and playing with it a bit, we may eventually put it into other places, into Redshift or Snowflake, a data lake, a warehouse, a lakehouse, whatever. Data goes somewhere else, and we work with it downstream. And so because data is growing and evolving over time and moving a lot, we have a way of making mistakes along the way, and those mistakes get copied. As soon as a mistake is made with data, and you have a data quality issue, it just passes through this process, whatever it looks like, and continues its way to the end, which isn't very good. And downside to AI processes, which is an additional problem, is they like returning answers. They don't give results, they give answers. We want our AI to tell people what they want to know. Like, I want to know what a plane ticket costs. Give me the price. I want to know what car you'd recommend for my lifestyle. Go and give me the right answer. So they're very authoritative in nature. So if you have bad data, then you're going to authoritatively give bad answers, which is a challenge. So we want to build authoritatively give good answers. And data quality is the linchpin to all of this. So many of this is going to be a classic answer. How do we prevent bad data? This is going to begin in the land of classic data problems and end in the land of AI. So we're going to start with things you may have heard before, or maybe things you do already, maybe things you don't do already. The simplest way to prevent bad data is to prevent it at the source. So you're at the beginning of the data lifecycle. You're in an application, you're pulling in data from edge devices, people are processing orders or buying things or bank transactions or whatever. You could be anywhere. Data is being created for the first time, it's being stored somewhere, and we want to make sure it's correct. This is where data begins. So how do we do that? And there's different ways to do it. You can be strict about it and have things like check constraints, data constraints, foreign keys, database constructs that ensure that if you try to put bad data in there, it will fail. And those are good things to have if they're available to you, because they ensure you can't have bad data. If your database says you can't do this, then you can't do this. Problem solved, right? We can't do that in every system, but when we can, it's nice. Some systems put data in out of order and do other things where you just can't do it. Or you're in a platform where those sorts of constraints don't make sense. You can still validate data, though. The application can validate data. The database could have a process to validate data. Or you can simply run reports after the fact, or validation processes after the fact, that check data and say, is it good and is it bad? And then deal with it in whatever the appropriate way is. It's important to note that any bad data created here lasts forever. Anything else you do with it from this point on will have mistakes in it, and it's going to stay there. So if we could fix it at the source, that's a very good thing. And note that I mentioned validating data at multiple levels. There's value in that. Sometimes we like to think to ourselves, if the app is checking our data for us, we're good, right? We don't have to worry about anything else. The database can be kept simple, straightforward, small, and compact. But we're assuming the app is perfect. And if you've built an app where there's no bugs, and that's the way it's been for its life cycle, that's awesome. But most apps don't behave that way. Things go wrong, we have bugs, we fix bugs, bad data is created. So consider when you're validating data in its creation state, having it checked in multiple places. It's a great way, and say when you layer security, layer data validation and data integrity checking, because this is the beginning of data. If it's bad here, it's bad forever. From here, where does data go? Well, you start with transactional data, we start with application data, and it begins moving along. It may get copied, may end up in analytic environment because we want to run reports, whether they're inward-facing, outward-facing. If there's any sort of analytics going on at all, decisions are being made based on it. And so we want those decisions to be made correctly. So how do we do that? Validating data is not hard, honestly. You don't have to check every single value. You have to make sure everything is correct. Very often, simply checking the general data size and data shape after data gets moved or copied somewhere or transformed is good enough. If the amount of data that I have changed by more than X% day over day, or like over like, we want to know. If the data returned is 0 for a day, if the number of data sources goes up or down by a lot, if the byte count goes up or down by a lot, things like that. Very, very easy to check and very easy to tell when something's wrong. If we get 1,000 rows from somewhere every single day and suddenly it's 1,000,000, that's unusual, and there's a reason, right? Similarly, we can look at values as well. Uniqueness of values. There's certain values that should always be unique. Are nulls and blanks allowed or not? Are there values that are invalid? Very often we'll say, take an integer, store a value, but we know it can't be negative, but we're storing it as an int anyway. You can check and see, are there negatives? And you may say, that can't possibly happen, but we know how these things work. If you allow a negative, somebody will put a negative in if you allow it to happen. It's just what QA does, right? That's how we do things. Negative 1,000,000, just as valid as positive 1,000,000 if you allow it, right? Missing data is important, as is duplicate data. These are key validations that are not hard to check for. If you have some key value that should be unique, make sure it only appears once per value. Because again, in the analytic world, we very often will have less constraints. We'll have less validation that's built into data structures, but we can check it, right? You can load data, check it. You can copy data, check it. You can transform it, check it. It's very fast, it's very easy. And once you've checked any data you've loaded, you can put that then onto your giant mountain of existing data and not worry about it again. Also consider edge cases. Edge cases happen a lot in data. Are they valid or not valid edge cases? Do they mean something and we should have them? Or are they crazy? If I see in my order processing system that somebody placed an order for $10 trillion, I would assume that edge case is probably invalid. Nobody is making an order that large, right? On the other hand, if I saw an order for $1 million, I would say, all right, that number is really big. Probably somebody should look at it, but it could be valid, right? Somebody could spend $1 million on something, as improbable as it may be. That's at least feasible. Negative $1 million, not possible. Negative numbers, you can't spend a negative number of dollars, right? So we can check for things like that and understand, is it correct or not? And importantly here, this validation should all occur before the data is moved again, before it's used for anything else. This is your second chance. So you check it at its source, and you check it after it's been moved and copied. And each time it gets moved and copied, there needs to be validation. And it amazes me how many systems I've worked with over my lifetime and seen and heard about where there's no validation. Data simply moves all over the place, and people just use it. And that's it. Just keep in mind that if you do that, you're riding on hopes and dreams, but hopes and dreams aren't very scientific, nor do they really help you get good data. I've hoped and dreamed a lot, and my data quality has never gone up as a result. So I highly recommend validation as opposed to hopes. They don't really help as much. And of course, one big piece that doesn't always get considered is what happens when things change. Software releases happen all the time. In applications, in the analytic world, in the AI world, things change, right? We decide to go from ChatGPT to a new version of ChatGPT. We're going to upgrade and try a new version. We're going to move everything to that. But that changes things, right? Or maybe a software release goes into a transactional application. Well, check and make sure that any data impacted by the release is checked, validated, looks good. Also ensure that new data being created is also checked, validated, good. And this is really what QA is for, right? Quality assurance is there to ensure that changes happen well. That's important. But if we don't do that, though, there's always a chance that things will go wrong going forward. And now you're in a world where some of your data is good and some of your data is bad. We have to come back and deal with that later, which I suppose is better than all bad data. But just keep in mind that changes to any tier of your application, whether it's a transactional app, whether it's a production database, whether it's ETL, ELT, data movement, data copying, analytics, AI, machine learning, whatever, those are all changes. They should be QA'd, tested, data validated. It's important. Something else, too, that's kind of a fundamental in database design that gets often thrown away when we start talking about things so far downstream are, what do our names of things look like? What do our data types look like? These are classic problems we've dealt with that are very often seen as beginning of the lifeline for our data, but they matter more now than ever, because we're going to take data and throw it into an AI algorithm and say, hey, look at my data, process it, understand it, and then answer my questions about it. If you have metadata problems, not just data problems, but you have metadata problems, then there is a chance the AI will make a mistake based on, this is really common. We've all probably run into metadata problems like this, and if you haven't, you will, but you're lucky so far, I suppose. For example, I have a couple fun examples here, just for heck, just to throw some ideas out here. What if you saw a data element that was an integer named invoice? What would that be? If you're an AI algorithm consuming this, what do you think it would be? Does it mean there is an invoice, yes or no? Is it the invoice amount? Is it an invoice number? I don't really know what it is. I can guess. I can look at the data and guess, but there's no guarantee I'll be right. I'll be right sometimes, and I might be wrong sometimes. So look at any data you have, and look at the names, the data types, the sizes, and validate, is this correct or not? For example, if I had a date time named entry time, is it entry time, or is it really a date time? Sometimes we store dates or times as date time, or even as a string. Strings are dangerous because they could have bad values, right? February 31st is not possible in a date time that's typed correctly. But if it was a string, February 31st can happen. Or you just mix up European and American times, for example. Some of us will write 2/29 for February 29th, but what about 29/2 for 29th of February? Or year, month, day, year, day, month, so on and so forth. Those things matter here. AI is going to consume this, look at it, make decisions based on it. It needs to be clear. Similarly, if I had a call, and this is kind of a fun one, very often we soft delete data because we want to keep it around for posterity, for reference purposes, for compliance purposes. And so we'll soft delete data, and we'll have some column or element named like is deleted or something, and then, or is archived, whatever. And we'll have that out there. And then at some point, AI comes and consumes this, and the algorithm will then maybe say, well, hey, it's deleted. Okay. Does that mean I should use this data as I crunch and return responses, or should I skip the ones that are deleted because they're deleted? Realistically, it doesn't really know what the right answer is. You and I may, but it won't. So consider that as well, that if there's any kind of ambiguous metadata or metadata that may influence decisions, you may have to train it or give it additional information to understand what it means, or just remove it altogether. If a column is something that you can simply resolve and say, you know what, I just don't want deleted data in there at all, then remove all the rows is deleted one, call it a day, never train with it, don't bring it in as RAG data, just leave it out. Don't even give it to the algorithm. Don't let it think about it. It's just noise at that point. And providing noise to an AI algorithm is only going to create bad responses or just things people don't expect. The last thing you want to do is get information on an order you placed last year that you deleted and never actually placed, right? I filled my card up, I went to place the order, I said, oh, I don't want that stuff, I'm gonna just start over. And then it's giving me answers back about it later. That's not so good. One note is we have different kinds of data. These are 2 examples. You may have other data that goes into your algorithms, goes into your machine learning. Keep in mind that each of these are different data sets. So you have training data. The purpose of training data is to ultimately tell your AI how to behave. What is its purpose? What is it going to do? How is it going to respond? What is it trying to? And if it's bad, what happens? Well, if you have bad training data, your model will simply not behave the way it should. It may return the right answers potentially, but it may not do it in the right way, or it may give irrelevant answers that are still correct. You ask me what the color of the sky is, and I say 42. That's not a very helpful response. Maybe I was thinking of a wavelength instead or something else, but that isn't relevant or correct. So I can give the right answer to the wrong question. That's often what happens here. On the other hand, you have retrieval augmented generation. That is RAG data. That's the data you bring. So you train a model, it's behaving the way you want. Now you swap in your data, the actual data you care about. You've trained it to be a bot that will answer questions about an airline, for example. Now you're going to bring your airline data in so it can use current information to do what it has to do. If your RAG data is incorrect, what do you get? You have invalid responses, bad answers. So it's important to know you have different sets of data, and bad data in any of these areas will result in different results at the end of the line. So you can have bad training data, which will provide one set of problems and headaches, and bad your data, RAG data, which will result in other headaches, different headaches. And if you have bad data in both, you may have a hard time diagnosing where the problem is. All right, so now we're going to talk about AI specific. How do we cheat? How do we do things we're not supposed to do to try to fix the problem? Because we have an app, we're close to releasing some new stuff, it's not behaving correctly, we've got to fix it. What are the things we do and then don't look back on that probably we shouldn't do? All right, this sounds fun, right? This is the most common one I see. It's very often that we're close. We have a interface that works nicely. It's almost correct all the time. Sometimes you get bad responses. Sometimes you get answers that aren't correct. So what do? We take our prompt and try to engineer it further. And we say, hey, you know what? We're really close. We'll just adjust it a little bit so that it doesn't give the wrong responses anymore. And this goes down a rabbit hole of kind of cause and effect, cause and effect. The purpose of prompt engineering is to provide purpose to an algorithm so that it knows what is it, what is its role, what is it supposed to be doing, how does it answer, things like that. That's what we're trying to do. It keeps things relevant. It makes sure that it's doing what you want it to do. If you have bad data coming in from anywhere in your process and it consumes that bad data, you really can't prompt your way out of it. You can try. You can include details in your prompt to try to get around it. But the problem is you're changing its purpose now. And so you're trying to prompt your way out of bad data. But as you do so, you're going to make it behave differently in an effort to avoid bad data. And if you think of it more from a human perspective, like if you were going to ask somebody to answer questions for you on the phone, and you went to them and said, listen, this is really important. When you're answering questions about the airline, don't respond with that flight going to Bangkok tomorrow. Just don't mention it at all. And if they ask about it, don't say anything. It's not $1,000. Like you begin giving these weird pointers, and a human being would say, what? What are you talking about? That doesn't make any sense. But the algorithm's happy to consume whatever you give it. And so you prompt engineer, you put details in, and you might start getting correct answers to the problem you found, but I guarantee you will introduce complexities and wrong answers elsewhere. So you can't prompt your way out of bad data, and if you try, you will prompt yourself into other bad responses. Not a good way to go. Similarly, we have the world of the data we bring. Retrieval augmented generation, RAG data is data we bring. So you train your model on one data set, and then when you're happy with what you have, you bring your data and continue working with it. You can't fix bad training with this, though. The purpose of RAG data is to be your data. For the flight, for the airline example, I will have flight numbers and prices and layovers and durations and first class, economy, whatever. I'll have all that data coming in for upcoming flights. People will ask questions, they'll get answers. The nice thing about this, though, is if you do have bad data in the RAG world, that's going to mean bad responses, just inaccurate answers. That's all. It's also easy to fix, though. This is the data set you're bringing. You simply identify where's the bad data, you fix it, and then after you fix it, you can go back and find the source of the bad data and fix the source as well, and then we're good, and you move on with life. Don't make it more complicated than it has to be. Don't try to work around it. Don't try to train around it. Don't try to fine-tune around it. Don't try to unlearn stuff. Anything else you do to try to fix your bad RAG data is just going to make things more complicated. And there really is a beauty in simplicity in this world. The more complicated your code gets for your algorithms, the harder it is to troubleshoot and to get back what you really want. Semantic search is fun because there's a lot of math involved here. Personally, I love math. Math is fun to me. Not everyone believes that, but I enjoy it. Purpose of semantic search is to take and create associations in data. This helps us create more qualitative analysis. And so you have quantitative mathematical analysis that results in our ability to make things associate to each other so we can answer questions. So if I ask a question of an algorithm and it doesn't recognize all the words or sentences, it can figure out what I'm talking about based on meaning and sort it out, synonyms, things like that. And so under the covers, it's going to vectorize data. It's going to break it into chunks. It's going to create associations, assign numbers of similarity or dissimilarity, and then go from there. And this is really cool. But if you have bad data in here, you'll get bad associations. The good news is, this is kind of like a very basic example I like to use to show what vectorization looks like. So you're basically taking this many-dimensional model of relationships, and obviously this is smaller than any data you have, right? You have more than 8 things and 7 things you associate them with. You'll probably have hundreds, thousands, millions, whatever. But to simplify it, you look at this here and you see positive and negative numbers that indicate similarity or dissimilarity. If I were to be talking to an algorithm, a chatbot, whatever, and getting back wrong answers because of this, I can trace it back. So tracing back bad data from semantic search is actually not that bad, because if I see that cat is associated to canine, and there's a high relevance factor for it, I'm going to say, all right, there's something wrong in my data. There's no way that would happen otherwise. Let me go dig into it and figure out where that came from and solve it. So the good news here is that if you see bad data here, you can reverse engineer it, solve it, and be done. But you can't work around it, though. If there's bad data here, it will continue to associate badly in the future. And canine doesn't just mean dog, it can mean wolf, it can mean something else. And so there's the potential for more bad associations that I simply haven't hit on yet. Just because I found one does not mean that more aren't there somewhere. A few more fun ones here before I leave some time here for questions, because questions are fun. Fine-tuning is something that we often misuse. Fine-tuning lets you take an algorithm and make it specific to a certain use case. Like, for example, let's say that I have my airline model and I like it, but I want to make a couple of specific use cases out of that, one for cargo and one for first class, because those just tend to be very different from everything else. I want them to kind of be tailored specifically to the crowds that will be interested in paying money for those services. To really do this correctly, though, you have to spend a little bit of time understanding the use cases, the business model, and what you're trying to do. An important key is that you can't you can't RAG your way out of bad data. You can't unlearn it, untrain it. You can't prompt engineer your way. You can't fine-tune your way out of bad data. If you have a data problem, fine-tuning is not going to fix it. The purpose of fine-tuning is to make a model more specific. That's all. It's supposed to allow it to handle a subset of use cases that are important to you under certain circumstances. And fine-tuning for that purpose is easy, but it takes time and effort to do it correctly. It's not going to solve bad data. And if you try to solve bad data here, again, you're saying, hey, model, I'm giving you a purpose, but by the way, as part of that purpose, avoid this and don't do this, and this should really be this. That's not a purpose. That isn't providing a use case. That's confusing. Whenever you're not really sure if something you're doing is correct, think about talking to a human being to ask them to do these things. Would it make sense or not? And if it's total nonsense, then it's probably nonsense to the algorithm as well. So fine-tuning is to create specific use cases. It's not meant to solve bad data. Here's a new one that's been coming up more and more, and this has been proven through recent studies that are really interesting. Many models have many apps have ways to unlearn data. Basically say, all right, you know what? I have an algorithm that's doing great, but I want it to forget certain things. There's bad data, there's PII, there's copyrighted material, there's something I just don't want it to ever talk about. So remove it. And the reality of this right now is that all the unlearning methods that are out there right now are pretty rudimentary. They might kind of work, but there's more of a chance they're going to harm your model than help it. It's very much like me saying one day, like, you know what? Last week was horrible. I had a terrible week. Everything went wrong. I want to go in my brain and pull out all the neurons from last week and make all those memories go away. Can you try to do that? I'm sure there's some way to try to do that in science right now. I'm sure it'll have negative repercussions that I really, really wouldn't like. So this is just a technology that's getting there. It's not there yet. If you try to do unlearning, be very cautious. Check, save, back up everything you're doing before you make anything permanent change to it, and be cautious. Unlearning, especially unlearn more data, will very often result in bad things happening. If you need to get rid of data, remove it from the data source. If your RAG data has stuff in it you don't want to bring anymore, remove the data, present a new set of data, and go from there. That's far better than trying to tell it after the fact, exclude data, unlearn data, make it go away. For training data, this is even more important. You've built this model, you built a way it behaves, you've worked with it, you like it, you've adjusted it. Now to go in and begin ripping stuff out after the fact, it may have unintended consequences. So I highly recommend caution around unlearning data because you don't really know what the results are going to be like. And in current methods, current models, a lot of harm can be done. And so I really just caution here before doing it. These will get better with time. I'm sure they will. But there's always a danger in telling a model to forget stuff because it may forget more than you want it to, or it may forget less, or it may forget who knows what. You may try to get rid of all the PII and accidentally get rid of additional information you need. Or you may not get rid of all of it, and then you'll still give it to people inadvertently, but confidently after the fact. So I want to wrap up and have a few minutes for questions at the end. This presentation really had a lot of information in it that was pre-existing, that existed long before AI was talked about to the public. It's been around for years, and a lot of newer things as well. And it's all the same. It all relates. We've been using data for analysis for a long time. It's not going to change. All the new algorithms out there are really just an extension of things we've already had. And this will keep happening and keep going on and keep going on. And so just keep in mind the best place to solve bad data is to do it at the source. Solve it early, cut it off before it can go downstream. AI, messing with your AI models can do great things for them, but it won't be a substitute for good data. It can't solve bad data. It can't make your data better. You can try, but you're far better off solving it earlier in your processes. Once you're into a model, once you're testing it, once you're working with it, once you're QAing it, once you're letting people use it for real, keep testing carefully and check for responses. Whenever bad responses happen, find the source of it. Was it bad training? Was it bad RAG data? Was it some changes you made that backfired? Figure out what the source is and resolve the source. This is the best way of solving problems in your models that really, really will make things better. So I want to stop here. I'm going to provide a little bit of information about me. This will be in the slides later that get shared. I'll share them afterwards so you have them. Are there any questions? I moved nice and fast to kind of keep us on time, given it started a little late. Are there any questions so far?
Well, Edward, I do remember that in your session description, you did write that it's going to be a fast-paced session. I didn't realize it's going to be a really fast-paced session. So we're going to take a few questions. I have it in the comments. I'm going to keep this slide up here so that people can, go to your maybe Sessionize and pick up some of your links from there. The first question coming is from Ganesh. Is asking, what will be the outcome of large data set sample size versus small variety of data set?
Great question. Great question. This is kind of almost a stats question here. So what happens to the quality and accuracy of your database and the size of your data? And in general, the smaller your data set is, the smaller variety you have in it, the more chance there is for slant, for skew, for improbable things to become probable because there's less data points. When you're creating your data sets, especially when you pass it on to analytics, machine learning, AI, make sure the data you have, whether it's big or small, is representative of the questions you're trying to answer. For example, if you're answering the airline questions, do you have all of your flights? Do you have all of your users? If you're answering questions about people, is there enough variety of people where they live, who they are, what do they look like, sound like, behave like, to answer your questions accurately? Or do you have a sample size of 1,000 people from a single place in the world? So I definitely think that more data is better, but also quality data is good as well. I'd rather remove 10% of the data if it's bad than keep it for more data. A good question, though.
Yeah, we have a few other questions coming in from the comments, but I also have one from the C# community. Right, I'm gonna, you know what, I'm gonna copy it actually and put it here so that you can also see it. This is coming from the community that we have, and that is, I like this one actually. It's by Rohit. He's asking, can you discuss the importance of having single source of truth for each data source and how this can be maintained in a complex data ecosystem involving the multiple AI and analytics application? This is pretty cool.
That's a great question. You're after my heart here, by the way. That's a wonderful question. And I love the idea behind that. And that's, especially as organizations get bigger, they merge, that things combine, it becomes harder and harder. And I found that the key is to have a single data source of truth. Data gets used in many places. It'll invariably get copied. It'll get moved around. There's huge value in having an original source somewhere, whether it's a database, whether it's a document store, whether it's something somewhere. It doesn't matter where it exists. You want a single source of truth somewhere. You're allowed to copy the data and use it and make it go to downstream applications, but maintain that original place for data. And it may not be transactional in nature. It could be analytic, but have a place that you consider the source of truth for any app, whether it's transactional, analytic, for AI, whatever. Just have a data source. I focus on data source that is the place you go. That way, if something downstream breaks, if data gets transformed improperly, if you see bad responses, you can trace it back and say, all right, here's our original authoritative data source. We can work our way backwards and figure out where the problem happened, knowing that that original source is valid, or at least it's the most valid thing we have, right? Nothing's perfect, but if you have something you consider a source of truth, it'll be the most valid source you have. And even in a complicated environment, everything can have that data source of truth. Even if you have many apps and many sources of truth for different things, you can still have them and maintain them. And have owners, by the way. Make sure you have an owner. Every source of truth should have an actual owner who's responsible for it, like a person or a team. Although honestly, a person tends to be good on top of the team because individuals don't like being tagged with problems. But have an owner for your source of truth. That way, if things go wrong, a person owns fixing it, and it's not just the general consensus.
That's right. Someone in the comments actually said, more than expected. Best session. Thank you, sir. Thank you so much, Edward. Before we wrap up your session, any final thing you want to say? And then we'll wrap it up.
This is a lot of fun here. And I heard you ask at the end of the last session about hobbies and other fun things. And I'm going to go pre-answer that question for you because I love answering that. And so I have a family. I have 2 kids. I have a wife who live out in upstate New York. And I spend a lot of time with them. And so a lot of it is spent. And we try to get out and do a lot together actively, go hiking, do things like swimming or taekwondo or vacationing together, or even just baking. I love baking, by the way. Anybody who knows me personally knows I love baking. And so if you visit, if you ever see me in person, I have cookies with me, along with whatever I'm presenting. Just something I do that's fun. Baking is fun to me as well. I'm spending a lot of time with the family, getting in trouble, and having them keep me in shape because it's what kids do, right? They run you around a lot. So it's a lot of fun.
Yeah, I bet you did a lot of baking during the pandemic, right? Staying home.
There was a lot of insanity there, but we got around. We managed to keep going despite being in a smaller location.
Yeah. All right, Edward, thank you so much for joining in today. Right, lovely session. I know we couldn't take all of the questions, but yeah, we will have you some other time. Have a great day ahead, and let's stay in touch. Thank you so much.
Thanks for having me. Talk soon.
Thanks. Bye-bye. All right, ladies and gentlemen, that was Edward for you. Now we move to our next session, and that was an interesting one actually. It was about renovate to innovate. I mean, lovely session title, right? You're going to learn about fundamentals of transforming legacy architecture by none other than Rashmi. Rashmi is a senior software engineer at Netflix. Everyone gets excited. We have hosted quite a few folks from Netflix, and everyone in the community comes to know there's someone from Netflix. They get excited as if like we are giving free subscription. Never mind, ladies and gentlemen. Let's please welcome Rashmi to talk about renovate to innovate. Hi, Rashmi, and welcome to the Software Architecture Conference.
Wow, Simon, thank you for the lovely intro. I'm pleasantly surprised. This was very warm. Thank you.
Yeah, thanks, Rashmi, for your time. I know it's a work day and you're taking out your time to do this. This is 9, 10 a.m. This is the time when everyone gets on the meetings and all. So I won't take much of your time. I already know that I'm 5 minutes in your session. So please feel free to go ahead and take all the time you need. I'm going to add your screen to the stream. Everybody else can see it. And next 35 minutes, Rashmi, is all yours.
Perfect. Thank you, Simon. Hello, everyone. Welcome to my talk, Renovate to Innovate, the Fundamentals of Transforming Legacy Architecture. I'm excited to be speaking at the Software Architecture Conference today, so thank you for having me. Just a little bit about myself first. I am Rashmi Venugopal, and I'm currently a senior software engineer at Netflix. I'm part of growth engineering, where my team focuses on enabling seamless payment experiences for consumers signing up for Netflix. I've worked with Microsoft and Uber in the past, and as a software engineer, I spent the last decade building and operating reliable distributed systems at scale. Okay, so with my intro out of the way, let's dive right in. Our agenda for today. We'll begin with what legacy means and how I define legacy systems. Next, we'll talk about why systems become legacy in the first place. We'll review what technical renovation means and when it is most appropriate to do one. We'll spend the majority of time on the guiding principles and best practices for technical renovation. That'll be the crux of the talk before we wrap up. So, what's the first thing that comes to mind when you think of the word legacy? If you're open to sharing, feel free to drop some words on the chat. I basically have a word cloud from OpenAI for the word legacy. As you can tell, there's a few different ways of thinking about legacy. So the term legacy is quite overloaded. So it's useful to spend a couple of minutes to get on the same page about what legacy systems mean in the context of this talk. I define legacy system or a software system as legacy or on its way to becoming legacy if it hinders the organization's ability to meet or keep up with business requirements. Let's make this more concrete and talk through some telltale signs of systems that are unable to keep up with business requirements. When there's a decrease in innovation velocity. So as your software systems get more and more complex, even a simple change can take a disproportionate amount of time. Product and project managers expect productivity to scale linearly with complexity. Engineers know better. We're close to the ground, and our past experience has primed us to be more pragmatic. It is a sign of a legacy system when the reality of how long it takes to roll out a change is far from the expectation. And this is driven by an increase in complexity. There are numerous sources of complexity in software engineering. Working across multiple teams involves coordination tasks. A lack of established boundary between teams makes it difficult to release isolated changes. A lack of investment in observability, automation, and testing leads to high operational costs just for keeping the lights on. To recap, there are various sources of complexity, and as it goes up, the developer product productivity and innovation velocity comes down. Another sign of legacy system is when the quality of experience starts to degrade. QoE measures the overall satisfaction of end users when they interact with the system. I'm sure we've all experienced the very real frustration of waiting many seconds for a screen to load. In fact, Amazon has an infamous study that quantifies the impact of latency to their business. They find that every 100 millisecond increase in latency impacts their sales by 1%. To recap, a dip in quality of experience, despite a best effort to tune them, is a sign of a legacy system. Another signal is when it becomes consistently difficult to scale the system for increased user load and user demand. As your business evolves, you will find that the software infrastructure that was set up to serve, a couple million users well is not going to be suitable to serve a billion users well. A system that is not able to keep up with an increase in data load or user volume is on its way to becoming legacy. In summary, it is a sign of a legacy system when it consistently becomes difficult to add new features or even make changes. And both of these are required to keep up with the business needs. Now that we've covered what I mean by legacy, let's talk about why software systems become legacy in the first place. The most obvious reason is the rapid pace at which technology advances today. Just like devices get outdated, systems that were once considered cutting edge struggle to keep up with modern industry standards just a few years down the line as their technology choices become outdated. In addition to this obvious reason, there are two schools of thought that explain software degradation. The first is bit rot theory. This states that software gradually degrades over time due to incremental changes to itself or its surroundings. Some examples of bit rot are code duplication, lack of documentation, or a loss of knowledge. The primary driving factor here are project deadlines and the real trade-offs that engineers make to be able to meet them. Bit rot can be kept in check by following, all the software engineering best practices. But despite our best efforts, they will accumulate over time. The law of architectural entropy states that software systems eventually lose their integrity when features are added without much consideration of the original architecture. As companies evolve their business model, it is surprisingly common for teams to extend their existing services to find the product market fit for the new business areas. Imagine the growth journey of an e-commerce platform. At the early stages, having the perfect architecture is not a priority. They're focused on establishing a successful business. So the architecture evolves very quickly and is driven by business needs like, can we render order history for users? How can we add the ability to recommend products based on their past purchases, etc. And in this example, every new feature is added to the existing monolith, steadily increasing the architectural entropy. So architectural entropy, to recap, is attributed to updates and extensions that introduce more capability to a system than it was originally built to handle. In the real world, software systems are affected by all of these phenomena. This explains why outdated and legacy systems are more commonplace than we'd like them to be. Now that we've established that legacy systems are commonplace, let's ask ourselves, do we proactively improve the state of our software systems? I wish. The inevitability of software degradation, on one hand, driven by entropy, bit rot, and technical advancements, combined with the lack of I'm not saying this always happens, but often the lack of proactiveness in addressing them, on the other hand, leaves us with systems that are difficult to understand, maintain, and extend. And that brings us to technical renovation. So, what does technical renovation actually mean? I define technical renovation as the act of upgrading or replacing outdated systems and technology to improve the state of your software systems. Often I get asked, hey, but how about refactoring? How does that fit into technical renovation? I view refactoring similar to organizing your closet. Much like refactoring, organizing involves moving things around. This makes it easy to access all pieces of your clothing. Hey, you might even get rid of some stuff to create space. And it also has the side effect of reminding you what you already have, and that could influence your future wardrobe investments. Sticking with the closet analogy, renovation is when you break down the walls to replace your regular closet with a walk-in one. Renovation goes beyond just moving things around or getting rid of things. Renovation is when you make a drastic change that shakes things up, and the end result gives you capabilities that you didn't have before. That said, refactoring is very important, and it can occur a lot more frequently than a renovation. Refactoring is a valid strategy to maintain a healthy code base. And there are a lot of benefits to maintaining a healthy code base. Besides making technical renovation easier than it would otherwise be, the sheer joy of working in a refactored and readable and extendable code base is unmatched. Okay, so now that we've established what technical renovation is and how it's different from refactoring, let's review some scenarios that make technical renovation a compelling approach. When there is a new or diverging business need, attempting to reuse the existing systems to solve for it introduces complexity. And we've already talked about how complexity slows down innovation velocity. Let's look at an example of a business-driven renovation. And Netflix is a good use case for that. The company has evolved from a DVD distribution service to a streaming service. The capabilities that were required to deliver DVDs is very different from the capabilities required to stream video on demand. So the systems that served Netflix well in the DVD era aren't going to be sufficient to run a successful streaming service. This drastic change in the business need eventually calls for a technical renovation. The takeaway here is that architecting software involves making some broad and fundamental assumptions, and they're hard to adapt when the business context changes drastically. Another example is modernizing your technology stack. And this specifically is an example of an ecosystem-driven renovation. If you're going from having a Python service, that hosts REST APIs, to then a Java service that's behind a GraphQL gateway, just refactoring isn't going to cut it. You need a technical renovation to modernize your software. Sometimes software systems turn out to be more successful than anyone imagined they would. While this specifically is a good problem to have, it also means that the architecture and the systems stick around for longer. And this unexpected longevity results in a significant accumulation of tech debt. And that becomes extremely costly to address just with refactoring, making a technical renovation a necessity to improve the state of the software systems and the architectural health. Now that we've identified a few scenarios that warrant a technical renovation, let's talk about how to approach one. And today, I'd like to share 5 guiding principles to maximize the success of your technical renovation. Make it work, make it right, make it fast. This quote from Kent Beck encapsulates my approach to any new work, not just renovations. And it is my first guiding principle for a good reason. Technical renovation is a huge undertaking, and prioritizing can be a very daunting affair. Identifying what we should be doing first and what can be left for later is a question that has kept me up at night. Kent suggests that our first priority should be to focus on making it work. Beat the analysis paralysis by doing the simplest thing that just works. Because guess what? You're out of business if you don't have a system that doesn't get the job done. Then make it right. This stage is a good time to prioritize extensibility, readability, and adaptability. This is also when you have to be mindful to resist the temptation to over-engineer. As a general rule of thumb, if you don't regret any of your early decisions, chances are you over-engineered. Finally, make it fast. Now is a good time to prioritize performance. Make the necessary tweaks to the quality of experience metrics that are table stakes to serve your business well. So this structured approach to tackling the various aspects of a technical renovation helps break up a daunting endeavor into manageable milestones, giving you the clarity you need to focus on the right things at the right time. My second guiding principle is evolutionary architecture. Internalize the fact that complex systems cannot be fully designed upfront. Building software in a rapidly changing environment comes with many unknowns and surprises. So evolving your architecture as you go is more pragmatic. So first, start by defining a set of fitness functions that represent the desired qualities of your end state, such as performance, security, and scalability. Once you've picked the system qualities that matter the most to you, use that to then guide your decision making. This ensures that your architecture is evolving in the direction that is right for you and your organization's priorities. Adopt a continuous delivery practice. This helps reliably release changes frequently. Automate all the steps between developing a feature to releasing a feature. This provides the fast feedback loop that helps your team A/B test and experiment your changes out in the wild in the real world. And experimentation in general is key to maintaining high innovation velocity. That brings us to incremental changes. And this is the crux of evolutionary architecture. Create an environment that is conducive to making small changes and validate your technical decisions along the way. First, pilot your renovation architecture in a low stakes environment in an area that is not as business critical. And once the pilot proves successful, expand your renovation to more business critical areas. In summary, you should expect your requirements to grow and evolve. It's a given that that's not going to stay constant. So make incremental changes, validate your architecture against your fitness functions, A/B test and experiment your changes with real users, and iterate from there to make more incremental changes. So this process is critical for the long-term success of your renovation initiative because it ensures that your architecture is adapting in line with the business needs. On to the third guiding principle. No organization or company will stop doing new work. It is wishful thinking to hope for a dedicated renovation window that is uninterrupted by new feature requests. So, the ability to maintain feature development velocity in parallel with the renovation initiative becomes a prerequisite for success. It is equally important to strike the right balance between the extent of overlap between feature innovation and feature renovation. Imagine a scenario where you combine innovation and renovation oriented steps in your project for a large number of components. So now you're A/B testing and experimenting your changes to ensure they're not inadvertently harming your business metrics. And there's two possible outcomes here. Outcome A, the test is green, indicates no harm. That's great news because all is well. But if it is the outcome B, where your test is negative, then we need to be able to identify what is causing the regression. Are the renovation related changes the contributing factor here? Or is it the innovation components that's causing the dip in your metric? Maybe it's both. But debugging to pinpoint the problematic changes can become a painful endeavor because of how entangled they both are. So the takeaway here is that the two birds in one stone approach is not always appropriate. On the other end of the spectrum is enforcing that each new change has to either be an innovation step or a renovation step, but never both. This is also not practical because it becomes expensive and time consuming to create an environment where only one thing changes at a time. A more pragmatic approach would be to apply good judgment on the right extent of overlap. So, in summary, it is worth the trouble to sequence the renovation and innovation steps for business critical areas, but then lean into risk to combine both for less sensitive features in the spirit of increasing the overall execution velocity for your project. On to our fourth guiding principle. Deprecation-driven development focuses on what we're gaining by deprecating, as opposed to what we lose. This approach makes the case that systematically removing obsolete technology is a prerequisite for healthy software engineering lifecycle. So having this common understanding of the critical role of deprecation is essential for everyone involved in building software. It is our collective responsibility as developers, PMs, and managers to recognize that not all features stand to benefit from a renovation. Be honest about components like features that are in the maintenance mode or features that don't significantly contribute to your business, that are better off left in the legacy system, because the return on investment just doesn't justify the cost and the effort required to renovate them. This intentional cost benefit analysis has the ability to reveal what is beneficial for you and your organization. That said, deprecation is a delicate process and it requires thoughtful execution. So come up with a strategy that minimizes disruption and fosters a positive transition experience, and maintain backwards compatibility whenever possible. Netflix winding down DVD.com is an example of a well-executed deprecation. As the streaming business continued to grow and the DVD business started shrinking, it became increasingly difficult to justify the cost of providing the best service experience for Netflix DVD members. So this was a strategic decision to go out on a high note. My final guiding principle is intentional organization design. Innovation is equal parts discovering new products and iterating to improve existing ones. An inspiration for discovery or iteration can occur in any part of the company, making it easy for ideas and inspiration to flow through your organization is important for innovation velocity. So, intentional organization design involves identifying the optimal collaboration model for your business to thrive. As an example, let's look at two different ways of organizing teams. Design A involves grouping engineers based on their function, like front end, middle tier, back end. Design B groups engineers based on common deliverables and as full stack teams. Each design has its pros and cons. Design A optimizes for engineers to ramp up quickly, and it provides space for them to become experts at their specific craft. This also makes collaboration within their respective teams easy. But if every new functionality requires making changes in all three parts of the stack, then they'll need someone outside of the teams to manage dependencies and line up the tasks. In this scenario, the full stack teams in Design B might fare better. They have the autonomy to control their roadmap, and this increased autonomy might mean that renovation initiatives have a higher probability of getting prioritized. In addition to dependencies and flow of ideas, organization design also has an impact on the software architecture. Conway's law suggests that there is synergy between the two. It says that the way that teams are structured and organized influences the architecture and the design of the systems they create. So, for an organization undertaking a technical renovation initiative, it is a good idea to first take a step back and assess the org structure. Identify any changes that might be beneficial for streamlining communication and minimizing the cross-team coordination. Skipping the step could result in systems that mimic how organizations communicate internally, and it might not be in the best interest of serving its end users well. In summary, you have to choose to strengthen the communication paths that are most important for the nature of your organization and its software architecture, because every communication path cannot be the strongest. While that brings us to the end of the guiding principles I have for us today, I'd like to talk about a critical piece of the puzzle that is important for all the work required for a technical renovation to actually come together. And that is embracing the growth mindset. It starts with having the right perspective. The perspective that legacy systems, more often than not, are a byproduct of a company's success. So it should not be of surprise that as your organization grows and evolves, legacy systems emerge. Building the muscle to work through renovation initiatives is imperative for innovation and the continued success for your organization. That said, a technical renovation initiative is a significant undertaking. So rest assured that the path to successfully transforming your legacy architecture will be a bumpy and thorny one. So champion the growth mindset by, learning from mistakes, valuing feedback, and focusing on getting better throughout your renovation journey. And this is also how I approached the guiding principles for technical renovation. Some of the principles I shared here today may seem ambitious. That is because they're intentionally aspirational in the spirit of shooting for the stars and landing on the moon. That's my talk. Thank you all. I'm going to open it up for questions. And I see some on the chat.
That was a great.
Hi, Simon.
Yeah, that was great. I loved it. A very different session for a software architecture conference, right? Very organization one. All the stories that you shared from DVDs to whatnot. Yeah, it was a really cool one. Yeah, I loved it from behind the scenes. So I'm sure everyone tuning in. Actually, at this instance, we have 538 people watching.
Oh,
That's
wow.
lovely. Yeah.
Simon,
So
you
from
say the kindest things. Thank you for that.
All right, so let's take a first question from Bhaskar. He's asking, let me fix my screen. Okay, how do you balance the need for immediate performance improvement with the long-term goals of architectural renovation? It's a good question.
Yeah. And I feel like, I want to throw it back to my first guiding principle, which is, make it work, make it right, and make it fast.
Mhm.
So if you have something that is working already and, it's serving the function, then you can focus on making it
Mhm.
fast. And any renovation initiative shouldn't come at the cost of not supporting your existing customers, right? So it should be something that's kind of done in parallel to maintaining what you already have. And that's where the strategic foresight comes into picture, where you're envisioning that, hey, in 2 years what I have today is not going to be good enough, so let me work
Yeah,
on this renovation initiative. It's not something that you start renovation is not something that you start doing when you have a fire going on already, because at that time
that's
if you
right.
have a fire you focus on fixing that and
That's right. That's well
extinguishing.
said. Yeah, that's very, very good answer. I liked how you ended your answer. It makes a lot of more sense. So there's another question coming from Sophia, and that is, what role do microservices play in transforming legacy architectures? What are the best practices for transitioning from monolithic to microservice-based architecture? I think it's a very long question, but perhaps you can answer the first one that can help.
Totally. So I feel like microservices is a solution, right?
Mm-hmm.
And just comparing solutions might not make you pick the right answer. So start from the first principles of like, hey, what is best for my business? Am I serving 100 customers that pay me a lot of money? Monolithic architecture works fine just for
Yeah.
100 users. But hey, am I serving 1 billion users? And at that point, a monolithic architecture is not going to serve you well. So it is very context dependent. And I would like to quickly address the second part is that if
Yeah.
you are looking to transition a monolithic architecture to a microservice based architecture, then please look up the strangler fig pattern that Martin Fowler popularized, which
Mm-hmm.
is a great way to kind of detangle the monolithic architecture and then build microservices without interrupting your users.
How do you remember these names? I mean, as an IT guy, right? I've not really heard anyone with all these quotations and these principal names. It feels like I'm talking to a physicist, right?
It's like I will be the first one to say that theory is the easy part. So
Uh,
I am now talking about the easy part, and
yeah,
translating this to reality and practice is
yeah,
the hard part. So I don't want to take
yeah,
credit for just remembering, theory. But yes,
yeah,
theory is
yeah.
useful. It's useful for
Yeah.
inspiration.
It is. I mean, I'll tell you, I was very bad with theorems. So I'll skip that part. So we'll move to the next question. That's where Ganesh is asking, is there any relation between conservativeness and legacy system? Hmm.
Conservativeness. I'm trying to think how I should interpret the
Yeah,
meaning.
there's a lack of reference with this question. I give that. Perhaps if Ganesh could add a little more reference to it, right? Then we can definitely come back to this. This question coming from Deepak, right? That is, how do you ensure data integrity and continuity of service during a large scale architecture overhaul, especially in a high stake environment like payment processing? Oh, that's good.
So I think that's where the evolutionary architecture principle comes into practice, where one, we're making small changes in our innovation journey. And
Mm-hmm.
each time we make a small change, we're putting it out there and testing it with a small percentage of users
Mm-hmm.
to minimize the blast radius and the impact radius. So, one, make small change, two, test it on a small set of users to
Yeah.
increase your confidence in what you've
Mm-hmm.
built. Once you do all of that to increase your confidence, then you can ramp up the traffic. You can ramp up the number of people who see this new feature, or maybe the same feature but in your new architecture, right? It could be an
Yeah.
innovation or a renovation that you did in your new architecture. So this slow way of um, ramping up traffic and ramping up
Mm-hmm.
the usage of your renovated architecture is the only way to go, is the pragmatic way to go.
I have a follow-up question to that, Rashmi. Do you follow this practice even in your current organization?
We
Yeah,
do. We do.
yeah.
We're actually currently piloting um,
Mm-hmm.
a new architecture for users that sign up for Netflix.
Ah,
So now, if you sign up on web, you're going to go through our legacy architecture, right?
okay.
But if you sign up under a specific platform in a specific country at a specific time, then you're going to see a new architecture. And we're
Oh,
A/B testing that to make sure that there is no harm being done to our business metrics. Like, are the number of users signing up still the same
yeah.
on the new architecture versus the old one? So we're doing the do no harm test there. And the plan is to, over the course of the year, to slowly ramp up, more countries, more platforms, because, you can sign up on your mobile, you can sign up on your
Mm-hmm.
TV, you can sign up on web. So all these platforms plus countries, and different countries have different payment methods. So today we only
Yeah.
support limited payment methods in the new architecture because
Mm-hmm.
we don't want to invest too much before we're convinced that this architecture is the right way to go.
Makes sense. Wow, I would like to. There's a lot of analytics there, right? There's so much of data that you're getting, right? I would like to see how does the analytics team actually gets up and makes a BI board and see, all the stats coming in. Oh
Yeah,
my goodness, there's so much.
our AB experimentation team is excellent.
Yeah, well, I can tell you that. So I know I'm going to ask you one final question, right? I am asking this to everyone. What are your hobbies? I'm going to ask you that, right? And other than that, I just want to know, how does Friday looks like at Netflix? Do you all just go and enjoy, like, oh, it's already noon, let's enjoy and have fun, watch some movie with popcorns?
Depends on the week.
Yeah,
There are
yeah,
some weeks that I feel like, hey, like this week was too much. I need
yeah.
to start my weekend early. But there are some
Mm-hmm.
weeks that I feel motivated and I'm like, no, no, I want to get to the end of my goals. And then, I push through that. So it
Yeah.
depends on the week for me personally. And with respect to hobbies outside of work, my husband and I, we like spending time outdoors.
Yeah,
We go hiking in the backcountry. I feel like just gives me the perspective to appreciate everything that we already have. So
that's
I like
good.
spending time. outdoors.
Lovely, Rashmi. Thank you so much for your time. Loved your session, right? As I said, I'm repeating myself. Didn't expect a session like that to be coming at the Software Architecture Conference. Very unique from your experience, a very different perspective of the session that we have until now. So thank you so much for your time. We would love to host you whenever available next time. And yeah,
Thank you
have a
for
great day
having
ahead.
me. Bye, all.
Bye bye. All right, everyone. So that was Rashmi for you. A great session, and we'd love to have her back once again. All the speakers that we get from Netflix, they're so good. And yeah, so without any further ado, let's move to our next session. And our next session is by Sandeep. He's going to talk about domain-first GraphQL API platform for your .NET stack. I know, like, we have almost like 600 people watching in, and we're streaming it on C# Corner. So I bet this session is going to love by everyone. Sandeep is a field CTO. So without any further ado, let's bring Sandeep to the conference. Sandeep, I have no idea how my colleague got those pictures. If they're bad, I apologize.
No, I don't think it's the picture's fault. It's my fault. One of them was of a friend of mine, a very good friend of mine from college. But that's totally okay. He's a better looking one. It's totally fine. Use his picture everywhere for me. I wish more people would do that. Thank you so much, Simon. I appreciate the opportunity to be here. I'll get to it as part of my introduction, but C#.NET holds a special place in my heart. I started my career with that. This was, I don't know if you can see the white hair here, but this was back in 2005 and 6, just when the .NET framework was transitioning from version 2 to 3, and a lot of, I think, WCF and a lot of these other frameworks were just kind of coming up. LinkU was coming up back then. So as always, exciting times in the .NET world. That's how I began my career. And since then, it's been interesting to kind of watch the evolution of .NET, C#, F#, and a bunch of these Microsoft technologies kind of take that open source route. It's a route that now I've taken with my organization, Hasira. Anyway, I'll take very little time talking about myself and my company. I want to talk about GraphQL today. I have a few slides, unfortunately. Sorry, folks. And I also have a demo. I've tried to keep the proportion of slides to demo at approximately 40 to 60. So hopefully you'll forgive me for using slides. But I do have some slides, and if you don't mind, I would like to kind of present that. So Simon, the format is new to me, so please feel free to interrupt me if there are questions, anything I can do to make this as interactive as possible for attendees. Please let me know.
No, so it's okay. It's pretty easy, right? You're gonna go and share your screen, right, and then we can get started with the presentation and the demo that you have. While this audience watches it, they'll have some questions. They'll drop it in the comments, and towards the end of the session, we'll take some questions, and we're gonna do a lot of chit chat. But I would really love to know on how you get started with all these years of C#. You did tell it, but your organization, how you got into it, right? What exciting stuff you all are building, right? I would love to know more about, maybe towards the end of the session, or maybe you can talk during your presentation. That would be lovely.
I can do that as well. So I do want to give this disclaimer out that I work for a company that builds GraphQL tooling. We build tools for software developers. We help people build not really just GraphQL, but other interesting things because of a certain approach that we take. And I want to talk about some of these open approaches, like some of these, the tool is open source, the underlying concepts are open source as well. I'd love to kind of share some resources towards the end. We've been associated with GraphQL for about 5 to 6 years. We've kind of seen the journey. And before picking up GraphQL, we were doing something similar to GraphQL. It's in a space that is kind of MVC language framework adjacent, if you will, relax your understanding of what that adjacency means. But we built tooling which is like a compiler. It takes an incoming HTTP request, compiles it to a request that is understood by an underlying source. So, for example, if you're working with SQL Server, there's an HTTP request that comes in, let's say requesting some data from the users table. We convert it to SQL that is understood by SQL Server. We send it to SQL Server, get that data, pack it up as JSON. We actually apply on the database and all of that, but that's not important. We take that response and give it back to the client. Now, this request can be REST, it can be GraphQL, it can be gRPC, whatever you want to, right? So in today's session, I want to focus on GraphQL, and I want to talk about this approach, which, by the way, is not unique. We're not the pioneers. There are lots of other teams that are doing it. Microsoft is into it in a big way, and we will talk about that. And teams that are looking to succeed with GraphQL are looking at this approach and adopting this I think more teams are adopting this as they look to succeed, as they look to deliver good user experiences on their products in a chaotic data landscape that most enterprise organizations kind of go through. So that's what I'm going to talk about. So I'll take it slow. I'll take it step by step. And I also want to be cognizant of time. I can see Simon looking at his time.
Multiple screens, But Sandeep, you have really got us excited, I'll tell you what, you've really got us excited with how you started your product, and the GraphQL that you've got it. Now you're building your product entire on GraphQL, right? So I think all our .NET developers, C# developers, and around 550 people watching in. I think I'll let you take the stage now, right? I'm gonna add your stream to the screen, and I'm really excited on what's coming up.
All right. Am I?
Yeah, go ahead and get started. It's all you now. People can share your screen. It's all you.
All right. Hello, everyone. My name is Sandeep. I work at this company called Hasira. We make tools for GraphQL developers. So people like yourselves who might be interested in using GraphQL on any stack that you use, right? And today I'm going to talk a little bit about using GraphQL with a .NET stack. However, you can take the approach, you can take the concepts and apply it to any language framework of your choice. As you will see, we kind of circumvent this API middleware and go straight to the domain in the database. But I'll save that for the subsequent slides. So here's what we are going to do. I'm going to take just one more minute to introduce myself. We will take a look at GraphQL for those of you who are new to GraphQL, who have heard of GraphQL, but have never quite sunk your teeth into it. We'll take a brief look at GraphQL. Hopefully, it'll just be 5 minutes. And we will also take a look at some concerns that API platform architects or developers need to kind of grapple with as you kind of build out your API platform or data access layer inside an organization. These are concerns that everyone has to face, especially as your team, as your data landscape gets more complex and it evolves and grows. These are concerns that everyone inevitably faces as their organization scales. So we'll take a look at some of them, and then we'll quickly move to something slightly more productive, which is a demo of how these things will work. And towards the end, hopefully we'll have some time left over for a Q&A. So that's the plan. I'm not sure if you got my introduction in the beginning, but I'm the field CTO at this company, Hasira. We build tools for GraphQL. I started my career building .NET tools, building applications with .NET. 2.5-ish is where I started. Watched the transition to 3, and then went on to do other things. So C# and .NET hold a special place in my hand, and I used to use that old clunky Visual Studio code editor plus CICD tool plus everything in one, right? So that's how I began my journey, and very excited to be here and talking to you about .NET and GraphQL. So without further ado, let's talk about GraphQL. Quick. And I'll keep these sections quick and rolling. If you have any questions towards the end, I'll be more than happy to take them. So quick bit of trivia, GraphQL originated in Facebook, an organization that is very much like an enterprise, lots of data, lots of teams, and more importantly, a lot of scale. I think nobody in the world had seen, very few teams in the world had seen scale the way Facebook and I think the WhatsApp team saw. I believe around between 2010 to 2015. And this was also the time they introduced React into the developer ecosystem. React components started to become a thing. People started to understand the kind of reinvented. For most of you folks who've been around, this should sound familiar, but the idea of data hierarchies and architecture and individual components being able to represent their own needs asynchronously, all of these things started to take off in a new way, of course, in a new fashion between in that time frame, 10 to 12 to 15, I think, is the right window for this. So GraphQL emerged from developers being lazy and refusing to write new APIs. And they said that, hey, we will come up with a query language. We will write one endpoint. Let's say it's some domain / GraphQL. We will define a way in which people can express the query, that we'll define the semantics of this query language, so that front-end application can request whatever data they want. And without getting into the implementation details of how we will service that request, we will be able to return any such request with the data that has been requested. So you can see this GIF on the right, where depending on the request, you have a response that goes from your GraphQL API. The idea is that you bring your own data and write your code, but essentially you build out a GraphQL schema that has types in it. You write resolvers, you generate resolvers, you do whatever, that's completely up to you, but define a schema, expose the schema to your front-end developers, ask them to query whatever they want against the schema. You have types that will help you pull this information out from the underlying implementation and return this response data set to the consumer applications. Whatever else you focus on in this half an hour's worth of talk, if there's one thing you want to take away, it is the fact that GraphQL brings types that are consistent across the underlying implementation. You could be using GraphQL on top of a single table, a single database, 20,000 databases, but you will ultimately represent them using one type system, which you define. But the ability to do that is what differentiates it from, let's say, a JSON REST API with OpenAPI specification, where you have information about individual endpoints that are discrete, but GraphQL is kind of, I mean, if you kind of squint your eyes a little bit, ignore OData and some of these other frameworks from the past, the first time that you have such a schema-driven approach that does this. In the modern world, again, for people who've been around the block, you know that SOAP and other protocols have kind of done the same thing, but this is the new wave of the same frameworks, so to say. Using types helps GraphQL kind of self-document itself. That makes for an interesting experience. We will see that in the demo. And most implementations of GraphQL are in HTTP and JSON. If people want live queries and things called subscriptions in GraphQL, which let you access data in a real-time fashion, then you can use WebSockets as well. And there are libraries that can help with this entire implementation. So that's a not so quick trivia around GraphQL. The important thing is that it's a single endpoint. You specify what you need, you get exactly that data. This lets you declaratively define the needs of a single component in your application. And that's it. No one needs to write any code. No expensive interactions between front-end and back-end developers to figure out the API spec and to test it, to have test data, and all of these things. You get away with all of that. Once you build a GraphQL schema, any permutation of requests in that schema is kind of supported, because you kind of do the hard work with the way you write resolvers, which should sound ominous, and we are going to get into this. So GraphQL evolved, as I said, from front-end engineers not wishing to get into extended back and forths with back-end engineers, right? So it emerged as a layer on top of REST APIs or whatever your domain APIs were, written and requested by front-end engineers. So over time, what has happened is that the scope of building GraphQL has gone back to back-end engineers. This is because when you had a well-defined domain API set, it was easy to build GraphQL. It was okay to build GraphQL, a layer of GraphQL on top of it. But the moment you need to introduce new data into the mix, you need to troubleshoot performance, because if you notice in the left-hand side of this diagram, let me see if I can get my pointer turned on. You have APIs that talk to other APIs that talk to your database. Now, anyone who's ever written code that spans more than 5,000 lines of code and works with multiple databases will know that this is a very hard problem to solve. You don't know what is going on. Multiple pieces of code talking to each other had unnecessary latency, and it's very hard to troubleshoot, and it's very hard to standardize performance in a single place. So a lot of these patterns kind of started moving back to the backend engineering scope, so to say, for full stack developers. The balance kind of tilts more towards backend engineering systems, where you get closer to the underlying domain. Right. So this is one of the things that has happened in this 9 years of GraphQL, by the way. The tooling ecosystem that lets you build a subgraph, and we'll get to the definition of subgraph as well, but it should be fairly self-explanatory. You build a subgraph, one team owns a subgraph on one or more data sources. You write some code, which is called resolvers. This entire thing is called a subgraph, right? So tooling started in the GraphQL ecosystem being very schema first, where people would laboriously handwrite a GraphQL schema. Step 2 is kind of write resolvers to help implement this schema. And a few years of doing this, after the initial hype kind of wound down, people realized that, hey, maybe there is a way in which we can generate the schema instead of having to handwrite the whole thing. We have a complex domain. I don't want to sit and write thousands of lines of GraphQL schema. In some cases, I already have APIs and database domains which have defined what the schema should be. Why am I building another layer on top of it? That's the kind of thinking that led to people to do other things like code first, where if you have code, you can generate a GraphQL schema on top of it. So this is code first. And the third approach is domain first, where if you already have types in your domain, which usually come from your database, just generate the GraphQL schema, most of your GraphQL schema from it, and allow the definition of business logic to kind of customize this if any of that is needed. Over time, people have realized that this is academically very sound, schema first, but it takes a lot of time, and it doesn't solve all the problems. And the adoption has kind of started to shift towards code first and domain first in the first 2-3 years, and now there's a lot of stuff happening here. We'll kind of take a look at what is happening in the ecosystem in the recent past as well, right? But a quick caveat here. These are all steps that you will take to seed your GraphQL schema. Now, and like if you build applications, think about all the different tables, all the different models that you have in your domains, in your domain, and think about having to write a whole bunch of code and a new schema on top of that. Right? You might want to start with domain first. You will do that. And this will meet 80% of your requirements. But eventually you will come and tweak something. You'll drop a column, you'll define a schema to kind of take the place of this auto-generated schema. You will handwrite this one column schema and write a resolver to kind of support that. So for 80% of your needs, one of these approaches will work. For the other 20, you might want to lean on the other two. Right? So this is not a silver bullet. None of these approaches are. You will have to mix and match it, but only 2 of them let you kind of quickly deliver a GraphQL project and not kind of sit and write code endlessly. So that's one of the kind of patterns that has been emerging in the GraphQL ecosystem. The other thing that has happened is GraphQL is being used to solve increasingly complex problems it was being used for a single graph earlier. Now it is being used for a graph of graphs, right? So you have multiple teams kind of collaborating without expensive coordination to contribute to a single supergraph, if you will, right? So the complexity of use cases is increasing because GraphQL has become this lingua franca for API platforms. So it's the problem with different teams, heterogeneous systems, different kinds of APIs. How do you kind of standardize that? You go back to that one takeaway I asked you to keep in mind, which is types that remain consistent regardless of what is there in your underlying domain. So this middle layer, if it speaks GraphQL, you kind of standardize whatever is happening in your individual domains to GraphQL, and therefore allow a consumer application to speak one language to any of your underlying domain sources. I use the word language loosely, please excuse that. I don't mean to imply C# or whatever. I just mean a particular way of interacting with your underlying domain. But no one needs to know whether underneath your API layers you have SQL Server, Postgres, Snowflake, or anything else that a front-end application should just never bother with. So that's what's happening with GraphQL. It is being used to solve the problem of building API platforms because it provides that language for people to standardize on. And the rest of this talk is kind of taking that approach and applying it to your underlying domains as well. So if you take a look at the GraphQL landscape, right, this is a pretty stock landscape diagram for the GraphQL ecosystem. You have tooling that helps you build kind of subgraphs on top of individual or multiple data sets or APIs managed by one team. You have tools that allow collaboration. There are tools that let you kind of consolidate this into that graph of graphs. And there are tools that help you kind of consume GraphQL APIs as well. And what we have seen in the recent past is that the subgraph tooling has been moving to more code-first and domain-driven approaches, right? And there's a whole host of things that have come up here, not just from independent vendors, but also from cloud providers. And the whole reason for this is, if you go back to the origins of GraphQL, right? So this is a tweet from Nick Schrock, who's one of the co-developers of GraphQL back in Facebook. He's moved on to do other things. But he said that, hey, like a lot of people will fail to scale GraphQL or use it effectively because people forget that before GraphQL became a thing, Facebook had already kind of built out this data access layer, this common layer that interacted with the newsfeed team, the contacts team, or the friends team, the market. I don't think they had marketplace back then, but assume that the marketplace team had its own systems. Just standardizing all of them on a common scalable business object layer is something that Facebook had done before implementing a thin layer on top of that with GraphQL, right? Just to make the front end to multiple backends communication easier. Now, you can use it in completely different contexts if you want to. You're not required to use it only for those benefits. There's lots of benefits as you come down to the backend as well. But having this kind of data access layer is something that is important. And one of the crux of the domain first approach is that you can be metadata driven to leverage your underlying databases as much as possible to be this business object layer. And I don't want to belabor this point, but if you think about it, you spend a lot of time getting your database domain right. That's the true snapshot of what is going on in your system, especially folks who work a lot with OLTP or relational databases, right? Database design is important because it captures the state of your systems. Everything else has to connect to this stateful system to understand what is going on. Domain first approaches posit that, hey, you've modeled your domain already. Why can't I also model your GraphQL schema using the same domain and take care of 80 to 90% of your needs? Most application code is CRUD. Most application code is just doing simple IO with the underlying database domain. Why don't we just allow that to happen as efficiently as possible? And if you need to customize, write business logic, which no one can help you with, right? That's the key principle of domain-first approaches. And this is kind of where the GraphQL ecosystem is heading as well. In addition to all of those tools that I showed you in the ecosystem, which of course I'm biased with, you have all kinds of cloud provider services kind of taking the same approach. AWS has its own things. I won't get into that today. But Microsoft has, in the last 4 to 5 months, I guess, done 2 implementations of domain-first APIs. One with Fabric that allows you to connect to a diverse set of data sources, and the other is a collaboration. Sorry for this shameless peddling here, but the point I'm trying to make is that if you have a Cosmos DB, you want GraphQL APIs on top of it, you can just use some middleware that will give you instant APIs and let you customize whatever you need for business logic, right? This is the direction in which I like to say non-profit or rather for-profit teams are headed. If you're a non-profit, if you're looking at like academic stuff and you have a lot of money to throw on professional services, you can start with, let's say, a schema-first approach and so on. But the tea leaves have spoken, right? Like if you want to deliver successful GraphQL projects in this market, bootstrap your projects with more code first, more domain first stuff. Is my personal recommendation. So with that, we'll spend a couple of minutes on API platforms. I feel like I might be running late, so I'm going to rush through this. Again, not too many profound points that I want to make. 2 simple points. Think of API platforms like marketplaces. There are API or data producers. There are API or data consumers. You want to make sure that both their concerns are addressed, and this matchmaking of consumers and producers happens as efficiently as possible, right? That's the flywheel that you want to create of data consumption and supply, whether API format, gRPC versus REST versus GraphQL, none of that matters. Fundamentally, it's about data. People want to read it, people want to write to it, other people want to do the same as well. So just making this happen as seamlessly as possible is the role of API platforms. The second point I want to make is that API platforms, again, think of Amazon, if you will, right? As a user, you ideally don't want to write an email to a seller or a vendor on Amazon. You just want to see what kind of products you have available, check out the ratings, check out the metadata about it, and then be able to give your payment information and check it out yourself. Self-serve access to data is the goal of any API platform, which means that you need to do what is called, not exclusively, but in the GraphQL ecosystem as federation. You should be able to provide on-demand federation across any of your subgraphs for you to provide an effective marketplace. So if, let's say, I provide, there are 3 teams or 3 sellers in our marketplace, users, orders, and reviews. These are managed by different teams. As a platform provider, as a platform architect or a developer, I should be able to let consumers of this API platform run queries such as this, right? Give me users who have placed more than 10 orders, sorted by the count of the reviews. So you can kind of imagine the GraphQL query or the SQL query if you want to, right? Select users, select start from users, where users dot order greater than 10, order by users dot reviews. Oversimplification, but users, orders, and reviews are managed by 3 different teams. Their interfaces are APIs. It's not 3 simple tables, right? It's 3 different teams and 3 different systems, 3 different APIs, if you will. And you need to be able to provide this kind of on-demand joins for a truly effective and powerful API platform. because these are the use cases that you really need from an API platform, right? If your application is scoped just to the user's team, you probably have your own systems. You don't need like data from orders and reviews. It's a very simple process and something that you're used to. The moment you get into multi-team, multi-repo kind of situations is where things get tricky, because the choice of your boundary between teams, whether you choose to go straight to the data source, whether you choose to work with REST APIs, whether you choose to work with GraphQL APIs even, has a big bearing on how powerful your joins can be. There's some literature on this open framework called Supergraph. We kind of maintain we maintain that repo and encourage this discussion in the community. We've spoken at length about it, but the boundary at which you define the difference between team 1 and team 2 matters and has an impact on the quality of your API. But this is the goal of any powerful API platform. Path of least resistance and effort to be able to do any kind of join. That's the API platform stuff. And as you kind of journey across GraphQL, your maturity is going to increase based on how many such teams are involved in your GraphQL platform. So I'm going to skip over this and just give me 1 second. I think I should be able to move to a demo. So give me 1 second. Let me just open up. Let me open the application that I had in mind for this demo. All right. Simon, could you give me a quick confirmation if you can hear me?
Yes, Sandeep, I can hear you loud and clear, but I think you stopped the screen share, or perhaps you closed the browser.
I did. I'm going to switch to a different browser.
Perfect. Yeah.
All right. Going again. Let me just share. Wow, if you can still hear me. I'm going to share this entire window so that it's easier.
Yeah, I see.
Again, I'm going to use the tool. You can see my screen? All right, cool. Sorry. I'm going to use the tool that we built. I've created a special kind of project for the stream. And what I'm going to do is I have a couple of databases. I have 2 SQL Server databases. What I'm going to do in the next few minutes is build this API platform in front of you in the next few minutes using this domain-first approach. All right. So this is my project. This is what is called Graphical in the GraphQL ecosystem. It's a tool that lets you play with your GraphQL API. I don't have any types, any data in my GraphQL API which is being served at this endpoint. So you will not see anything here. So to remedy that, what I'm going to do is I'm using a middleware tool that will derive your GraphQL schema from the underlying database, right? So it's a tool that supports a lot of things. I'm not going to get into any of that. I'm going to add a SQL Server database, right? Let me connect this. All right. So I'll give it a name. I'm going to call it subgraph1. I'm going to use a database URL. This is credentials for this are open, so please do not hack my database because the password is available here. So I'm just going to connect this. This is basically this middleware knowing the existence of my database. I'm doing something wrong here. SQL Server database, where is the password is database URL. Let me just do this. Oh, okay. This is erroring out. Thankfully, I do have another project where I did add this. So let me just quickly go here. Just a second. How do I? Just a second. Okay. So what I'm going to do is I'm going to have to reverse engineer this. So let me just remove some of the things that I had in another project. Apologies for this. I don't want to go to Azure and add this thing. Let me remove customers, modify, untrack table, continue. All right. I'm going to drop customer address as well, modify. Please bear with me, folks, a couple of minutes and I should be able to do this demo for you. All right, cool. So I'm going to use this project instead. My apologies, I haven't whitelisted the IP of this new project in my Azure database. So I'm just going to use this new project called this thing, mutual ostrich 64. It's a randomly generated thing. So assuming I was able to get through this step, right? What you would have seen is an interface that says that, okay, this domain first tool has been able to talk to this SQL Server instance. It knows the existence of, let's say, 2 tables in this database, right? I did provide the database name in the connection string. So it knows that there is a table called customer. It also knows that there is a table called customer address. Now, customer and customer address are related to each other, right? So we will take a look at how to build, and this is in the same database for now. So we'll take a look at how to kind of define a relationship, expose these tables as part of our GraphQL schema and also build out a relationship. So let's do this step by step. So I'm going to track the customer table. I also have a bunch of other tables already tracked. Please ignore them for the time being. I'm going to track the customer table. By tracking the customer table, I'm telling this domain first tool that, hey, the customer table, which is this, right, which has customer ID, name, title, first name, the usual columns that you would expect in a customer table. I want to expose this data and this these columns and this data in my GraphQL API. So the moment I track it, the domain first tool introspects the schema of the table and is able to generate a GraphQL API that can support this. So for example, this is my table. We just looked at this one. I'm going to query first name, last name, and customer ID, and I'm going to simply run this query. It's going to take a few seconds. I can speed this up by adding caching as well. But I'm instantly able to go from pointing this tool to my database and getting a GraphQL API that is able to query this. Now, just to show you that I'm not doing any hand waving here, I'm just going to go and change. Can I edit this? Yeah, we don't support this for SQL Server, but I can maybe see if I can insert. Not really, but this is my data set. And this is the same data set that I'm able to query. A customer ID one is G Orlando. Let's go back to our data and run this again. And in a few seconds, we will have the same data. I really wanted to edit this and show you that this is not made up. Now I can sense the skeptics in the audience are like, hey, my model code will give me this. This is just API on top of a single table. What the hell are you trying to prove here? You're right. It doesn't make a lot of sense to do this on just one table, because that's what your ORM, any ORM or model layer will give you. I also want to track customer address, right? Let me track customer address now. Now, let's take a look at the schema of this thing. Very naturally, it has a customer ID and an address ID and address type and so on. It is not very hard to imagine that if I can query the customer table, I can also query the customer address table, which we just tracked, right? So let me get this, and let me run this query instead of the customer at this thing. So now I have this. I have data coming from this table as well, right? Again, the same thing. I have auto-generated this API, this GraphQL API on a single table. The interesting thing is that if I want to take, let's say, this customer ID and join it on the customer table and get customer data and address data in the same query, I would have had to write some code, some controller code, some model code to kind of join this, to define that relationship and filter them based on this join condition. Or I would have had to write a custom SQL and then expose that as code. I don't need to do anything of that sort because I am taking advantage of the domain. If I go back to my data tab, I know that there is a foreign key constraint from customer address, customer ID to customer ID. I'm going to track this. The moment I do this, and if I go to my customer address table, I can define a relationship, because we know foreign key constraints can let you have one-to-one or one-to-many relationships between two sets of tables. For example, customer can have multiple addresses. So if I go to the customer table, I'm going to go to the relationships tab, and it can already suggest this, right? Sorry, did this already exist? Like this definition already existed. Customer.customer ID is equal to customer address.customer ID. It's a relationship I can define because I track the foreign key constraint and I ask the GraphQL schema to also learn from that foreign key constraint. So it automatically adds this relationship. The inverse is also true. By the way, this is an array relationship because customer can have multiple addresses. You will see the others in the relationship definition here. I can add a customer relationship from customer address to this. Now, this is going to be an object relationship, a one-to-one relationship. So let me just quickly add this. I'm going to call this customer. Let me track this relationship. Okay, by virtue of doing that, what now happens is where I was simply querying a simple table, I can now say, get me data from a related table. So if you see this customer address field in my schema, it suddenly has this new thing called customer here. That's because we added that relationship. I can choose to start querying first name, last name here. So for every address, I can get the corresponding customer in the same request. I can run this query. This is a JSON.
Sandeep, I'm sorry to interrupt, but it's time to wrap. Yeah.
All right, cool. So I think I'm almost through with this. I was able to show you how to kind of compose or do this on-demand join on two tables. You can extrapolate this across two databases as well. And what I mean by domain first or being metadata driven is just this. Just give me 1 second. Let me just open. Right? Everything that we looked at, everything that we did in that pretty UI is actually adding to a JSON or YAML specification. And this is what it means to be domain first or metadata driven. You take the underlying domain, you translate it into something standardized, what we call metadata. And what you did for SQL Server, you can do it on Snowflake, you can do it on Postgres, standardize all of them on this JSON that you're looking at, and have a way for you to query any underlying source with this information. So that was my demo of the kind of productivity that you get with domain first approaches. Happy to take questions, and sorry for going over time.
Yeah, it's absolutely okay. I really loved on how you said how GraphQL was first for the front-end developers. They made it, then eventually went so good that it again went back to the back-end developers. That story was really nice, and I really liked the magic that you showed on how you can take your SQL databases, right? Click a button, and everything, it now becomes a GraphQL. You can actually also run queries there. So I think that was pretty magical. We have a few questions here. I think we may not have a lot of time to take it. Perhaps you can come back and maybe answer a few. There's usually around how you can use GraphQL API better in the .NET stack. They're more like generic questions from the audience. I know a lot of people use Cosmos DB and all that. And in fact, one of the blogs that you did mention about Microsoft, I cannot recall his name, but we're a very good friend to him, and I've hosted that gentleman many a times.
Sajid, I think I
Yeah.
have his. We're going to try and do like a webinar together very soon.
Oh, wow.
But the thing is, see, the business logic part, which I was not able to show you, is what you can write in .NET. And I wish we had a little bit more time for us to show this, but the moment you write, let's say, some .NET code, some TypeScript code that says, hey, CRUD is not enough, take data from customer and addresses and filter out addresses that are in, let's say, Bangalore, India. For some reason, I just don't want to show Bangalore, India addresses, safety, security, whatever you want, right? So you can write a simple TypeScript function to filter that out, and we'll generate the GraphQL type on that as well. So we take a code first approach too. So that is where that is how you kind of use this approach with .NET, right? The idea is not to write as much, like use a database that you're comfortable with. Don't do boilerplate code by generating that part of the API, and then write only the code that you are meant to, and then generate the GraphQL schema on top of it. So that's the way to kind of think about how to use. There are different tools, by the way. I encourage you to check all of them out. But that's the short answer to that question.
Yeah, I think this session is absolutely great. But we'll have to definitely have you back, to give you an entire 1 hour session. We do a lot of shows at C# TV, right? We could do 1 hour there, just talking about, because C# like we have a lot of .NET developers. They would love to know more about how you did it today, more from the business side and the .NET side. They would love to see that. So I will say thank you so much, Sandeep, for giving your time today. I know it's a work day, and let's stay in touch and let's do more content around this. I'll say, yeah.
Of course, I'd love to. Thank you so much for the opportunity, and can't wait to be back.
Yeah, thank you so much, Sandeep. Have a nice day ahead. Bye-bye.
Bye. Thank you, everyone.
All right, that was Sandeep for you with some really magical demos towards the end. And now we move to our next session. I know we're running 10 minutes late, so I'm going to quickly run to the next session. That is by Lucas. He's the CTO, Cloud Solution Architect, and a DevPrime advocate. We all love DevPrime, right? And what is he going to talk about today? He's talking about speedy microservices build and deploy in 30 minutes with Copilot at DevPrime. We've already taken 10 minutes from him. Let's see if we can do it in 20. Nah, kidding. We'll let him take all 35 minutes that he needs. So let's welcome the next speaker, Lucas. Hi, Lucas. Welcome to the Software Teacher Conference.
Hi, Simon. Thanks for the opportunity.
Yeah, I am really sorry for taking your 10 minutes time, Ra. You can take all the time that you need, no problem at all. We only have one session after this, but I'm really curious about your background. I know it's a green screen, you've had a virtual background, but is that your van?
Yes, this is my van. During the pandemics, I built my own RV, and I lived here for 2 years almost.
Wow. So where did you park it? Did you go around the states in this van?
Well, I'm Brazilian. Right now, I am in Brazil, and I used this van in Brazil during the pandemics. Everybody was in lockdown, so I decided to get locked down elsewhere, more isolated. So
how cool
I decided to do a van conversion, right?
You still own it?
Yeah, I still own it. I'm selling, so if anyone is interested, here, this one is available.
Yeah, use this conference to sell your truck. All right, Lucas, I'm really excited for your session, right? Build and deploy in 30 minutes. I think these are kind of sessions that really people are interested to watch it. Not just now, right? I know it's very late in different part of the world, people are working, but I know these kind of sessions, when we put it out on YouTube and all, people really come back to watch it. So I'm really excited and looking forward to your session. And I believe everyone else is. Please feel free to go ahead and share your screen, and then we can get started.
Awesome, thank you. Let me start sharing. I will share my entire screen. I think it will be better.
Yeah, that's the right thing to do. I see your screen now. I've added it to the stream. Everybody else can see it, and next 35 minutes is all yours.
Thank you, buddy. Welcome, folks. I will try to cover up a very huge product today that help us build and literally deploy a production application in 30 minutes. But first, let's start talking about who I am, right? Briefly, I have 20 years working in IT market. I'm a consultant, cloud solutions architect. I am a former Microsoft student partner and a speaker. I love kart racing. I built my own RV, as you can see here, and you will be able to keep in touch with me in LinkedIn and Instagram, right? Well, this is a very quick overview about myself. Let's go to the right thing, right? So DevPrime has a mission, right? To empower the developers and accelerate the productivity. The main objective of this framework, this tool, is to give the developer and the business control of the domain and accelerate how we build up software, microservices, event-driven applications. So let's start talking about the challenge that we have in software development, right? So everybody knows it's very hard to hire new people, to attract talent, and even worse, to retain these people inside your company. We have a high cost, right? Growing application is very complex, and we deal with technical debt all the time. Everybody deal with failures, applications that don't have reuse, and high coupling, and frequently we need to rework in tools and the business many times. I know that people is dealing with difficulty to scale applications, and that also brings to the table the high cost of this operation, because you will have much more cost deploying your applications and scale and etc. So as the CEO of DevPrime says, delay on innovation is a digital debit. So if you take so long to innovate, man, you're losing money on the table, right? So DevPrime brings to us a high quality software for backend, for event-driven APIs and microservices. We want to boost the developer productivity. I want to enable faster building of cloud native solutions. And I will show you in a live session called how we do this in 30 minutes, right? But where DevPrime fits? What is DevPrime? When we look to the stack of a development, we have front end, we have APIs, mediation layer, gateway layer, but we have backend. And in most cases, backend is where our problems scales. It's where we deal with most of our problems. And here is where the DevPrime fits, right? We're talking about a platform, right? DevPrime is a platform that brings inside a lot of features that you don't need to do anymore. So every day, people need to create a new API. They need to create logs, metrics. They need to create resiliability. They need to create a resilience strategy So you need to recreate the same thing all the time. And that comes ready inside the DevPrime platform. DevPrime supports HTTP, gRPC, GraphQL, logs, tracing, metrics. All the observability stack is resolved inside that platform. And you will have access to the code and control whatever you're doing, because our main objective is to apply the design patterns and best practices faster. So we bring to the table ready to be used an event-driven architecture with non-blocking APIs, hexagonal architecture. I will show you. The domain-driven design is applied the right way. In the previous presentation, I heard many times domain first. DevPrime is a domain first tool. You need to think on your domain, and you will be focused on the domain. You don't need to take care anymore about resilience. You don't need to take care more about logging. This is solved by the platform, right? Other things that people need to deal when we're talking about microservices. You need to consider the retry policies. What should I do when I try to call an API and for some reason the API is offline? Or what should I do when I try to call, for example, the RabbitMQ and RabbitMQ is not working? What is the resilience policy? These things needs to be considered when we're talking about microservices, when we're talking about event-driven applications, event-driven architecture. And this is already solved by the DevPrime platform. And also, the DevPrime platform is ready to run on container. So you will deploy this application in any cloud provider, in any server. It's your choice, right? We are not attached to any platform. In fact, we're not attached to any cloud provider. There's a way, a seamlessly way to integrate services and applications. So also the DevPrime platform resolves a lot of protocols to us and bring this ready to be used by the domain. We also can stream data to Kafka, RabbitMQ, Service Bus, and many others. DevPrime platform connects with Mongo, SQL, and other databases. And as I said, we are a cloud-native solution. So you will be able to deploy any application to Kubernetes, Azure, AWS, GCP, and any other. And of course, we have all the security layers with Auth0, Auth2, OpenID, and many other protocols so you can use to secure your applications, right? And DevPrime has born exactly from the pain of scalability. How do you scale? How do you handle thousands of requests per second? How do you monitor multiple microservices? How do you track the failure among thousands of microservices, right? So we design this platform for scalability. But let's stop talking. I think we should see these things working, right? So to start, anyone can go to your browser and open devprime.io, and you will be able to see our website there and how this tool works, and download it for free and try it for free. But let's start. I already have here the CLI installed in my machine, right? So I can simply start creating here a new solution. Let's start DevPrime, I will create a new solution. I will call software architecture live. I want to stream data to RabbitMQ, and I want to state to MongoDB. All right. Now I have one empty solution created by DevPrime on my machine. This is a traditional hexagonal architecture. Unfortunately, I don't have time to explore everything that we have around here. We have Docker files, we have scripts, pipelines, and etc. out of the box. But we have a structure to create a new application. And I will start showing something that is fun. So, for example, I want to add an aggregate. I will call customer. So now I have one domain, aggregates, and this is called customer. So what our customer have? Name. Customer have email, phone maybe, right? This is our customer. See, I will reinforce the statement. Domain first. I am only caring about the domain, right? Anything else I want to see for now, just the domain. So after creating the domain, I will run a new command here. Hey, DevPrime, start my application, init my application. So the DevPrime engine is testing, compiling, and building my project. And the tool will give to us an output saying, okay, I want to create files. Observe, the accelerator, the DevPrime accelerator, created 42 files and modified 10 files to us. What I have now, let's take a look. Our customer now have a new constructor, an empty constructor, one add method, one update method, delete method. So the DevPrime engine created for us all the business logic inside the domain. The domain is the piece responsible for connecting all the other layers of the application. I have events here. So create customer, customer created. I have the application. Now I have an application with an event handler here. I have a get by ID event handler because eventually I need to handle something like that, right? And what happens if I simply click run here? Again, the DevPrime engine is calculating everything, compiling the code, and in some few seconds, I will have an application running. All right. See, I have logs, structured logs here, right? The application started, read the configuration from this file. I don't have idempotency for now. I'm connected to MongoDB, right? Observability, security, etc., etc. If I click here, I can see my microservice running. Let's show you something. This is my MongoDB, right? This is my application. I don't have any database here, but I want to create a new customer. Let's try out. I will create here, Lucas. Lucas at messina.com.br, and my phone number is here, right? Let's execute. Whoa, it has been accepted. DevPrime created the database for me. And now I have the object there. And I don't type anything. I don't care about the database. I don't care about anything else. Let's go back to our logs. Let's take a look in the logs. So the application started, right? And here I have received a new post on this endpoint. Then it's triggered my service that triggered my domain, and domain said, hey, process the event create customer. this has been handled by an event handler that goes to the database, creates the database, and then triggers something out, sends the event out on my RabbitMQ, right? So here we have a complete microservices running in 5 minutes. Of course, we have to customize things. We can customize things. I can go into the code and change whatever is needed because the code is here. I can do whatever is needed to put my business rules inside my domain, right? That's the main objective of the solution. But let's take a look at something that is interesting, right? So my microservice is running here, and I have many containers. So let's imagine that my RabbitMQ is out of service for any reason. Whoa, my microservice detected that the RabbitMQ is out and is trying to reconnect. If I go to my API and I try to retrieve something, it's still working because the database is still there. Only the streaming adapter is not working, as you can see here. The system is trying to recover from a failure, right? Oh, it's not possible. So open a circuit breaker. Now we have a circuit breaker on the streaming adapter, right? So the application is not trying, but everything else is running. I can create a data. I can eventually create a new person. Let's try to create Simon here, right? Simon, you just received a new email, right? All right, let's try to create a new registry here. Simon, what's happening? Let's analyze the logs again. So again, we have a post, right? The application is running. The domain said, okay, process the create customer. It has been handled. Then go to the MongoDB, write, process the event customer created. And here is the trick. Hey, I was trying to send out an event to customer created, but it has not been delivered because we have the circuit breaker. RabbitMQ is not operational, it's offline. So DevPrime handled that message in the resilience level. And if we go into our database, now we have a DevPrime string level here. That is the resilience. Let's check what will happen if I turn on my RabbitMQ back again, right? RabbitMQ is back again, is going on. So after some few seconds, the application is trying to recover itself, and voila. After retrying, now the RabbitMQ is back online, and now we have out event delivered. Now the message that has been saved on the resilience level has been sent to the RabbitMQ topic. And I haven't created nothing. I just need to take care about my domain. The central part of DevPrime is the domain, right? We are a domain first, domain centric, domain driven design. But well, I showed you the power of the DevPrime platform, how it works, and how we can create code, manage our application, and etc. It's a very quick and high level, how can I say, example, right? But let's take a look how it works when we're talking about the Copilot, right? So I have here a tool, right? It's still beta. We're still developing this, and I will create a new project, right? I will call this Software Architecture Live. So I will create a new project here. And I will give instructions. So behind the scenes, the DevPrime, the DPX, is using Copilot. So I am building a CRM tool, and I want to track the customer interaction interactions. Customer have name, mail, phone, address. Please respond in English. See, the DPX can also give you your domain in your native language. I don't know if you want to receive your domain in Portuguese or Hindi or I don't know, Spanish, right? You can ask to respond in a different language. All right, now the DPX is running behind the scenes, calculating whatever is needed, and interacting with the Copilot to generate some classes. So now we have customer, interaction, address, and etc. Right? I will say, okay, generate the code for me. Okay. Let's go back to our CLI. I will create a new and I will try now. It's empty, right? All right, DPX list. Now I have the list of all my applications here. And I will start. I want to use the streaming wrapped MEQ, and the state will be MongoDB, right? What's happening? The DevPrime accelerator is using the code generated by the artificial intelligence for us and creating the project from scratch and giving us everything ready to run. Also, the tests. So let's take a look into this new code. Here we have the adapters, the application, we have the core, the domain, everything else. But now we have the aggregates here. The address is here. The customer is here, already calculated with all the validations, with all the tasks. We have the iteration. Everything is here, and I just interact with the artificial intelligence to build up for us. Let's run this application just to see what's happening behind the scene and the difference between the previous one to this next one. All right, let me refresh my screen. All right, now we have customer here. If we take a look on customer, we have other data here. Oh, sorry, I need to clean up my database because it's the same name. Just a second. If you look to customer, now the customer have much more information. I can create a new customer here again. I can use names and etc, etc, etc. Of course, I'm going super fast here because we don't have time, but we can generate more classes, more validations, and etc. here, right? So let's try to execute this one. Let's go back to my MongoDB. All right, now I have my customer here. Now the customer has interactions, address, and etc. Right? And again, I don't type it anything. I don't use any tool to build up that application, just the accelerator of the DevPrime and the Copilot behind the scenes, right? So this tool brings to us a very huge application that publishes and receive events from queues, for example, right? So I'm publishing here an out event that has been delivered on RabbitMQ. I can also write applications to receive those events, right? Let me show you something. I will open here because unfortunately we don't have time to go deeper on this. I will open here two applications. Okay, I will open an order service, and I will open here a payment service. Let me call here run. Both applications are being compiled right now, and they are connected to each other over the RabbitMQ, right? Let me refresh my API. Now I'm talking about an order API, okay? So let's put an order here. I will try to create a new order here for Lucas with some customer. I will buy, I don't know, a shirt. One, price 10, I don't know, 10. All right, let's create, observe here in the background, the order server will receive the intent of generation an order, creating an order, while here in the other side, we have the payment that will be responsible for receiving the order and processing it, right? All right, two microservices connected. In one hand, I have the order created and delivered. And in the other hand, I have one payment created. So here, we received, let's open here, the streaming, see payment, streaming, subscribe to order. And now we have an inbound, an in-event order created that has been processed by the platform. And both codes are similar because they have the same structure. They have the same pattern and following the same hexagonal architecture. And even better, if we go to our, let me open my other screen, sorry. Oh, here it is. To the Zipkin, for example. If we open Zipkin, I can see all the interactions from all the services in one place. I can see how they interacted with each other. So for example, let's take a look on this. I have posted an order into the order microservice that went to the web layer, order service, domain, handler, etc., etc. Then I have started processing the same order in a different microservice. So we have tracking of each step of that specific request into multiple microservices. If we look here on SEC, the same thing. We can see every step that has been executed in the application. And in many applications, payment, we can see what happened into the order layer. We can see everything. So we have a complete observability solution with DevPrime platform. And this is out of the box. And again, let's stop RabbitMQ for a second, just to see what will happen here in our observability logs, right? If we start again, and I'm creating my tail here, now I have an error that is pointed by the tracking system, the observability layer. And I can see exactly what happened in our application because we have a huge observability tool behind the scenes. And we can see exactly the line that the problem has started. We can see everything. And best, we can track every failure using the same ID, right? So if we look here, if we try to search something with the ID, I can see every single step about that specific object or request or intent, right? So unfortunately, we don't have much time to go deeper inside each and every details of the DevPrime, because DevPrime is a very huge stack. It's a very huge foundation. We have multiple layers. We have business-centered development that needs to be explained in a specific session. DevPrime is a domain-driven design solution in the minimal sense, right? Because everything that we care is about the business. We want to give to empower the developer in a way that he can focus his effort in the domain-driven design and not taking care about technical stuff and doing retry policies and etc. Right? That is already solved by the platform. Simon, I don't know how we are up or how we are in terms of questions. Let's take a look at the questions briefly. And I don't know how many times I still have.
There's no problem at all. You have all the time you need.
All right. So let's take one question from the audience, right?
Okay. You wanna pick one? I can put up one on the slide screen. There's one from Vitaly says, does DevPrime support open policy agent for cloud agnostic approach where dependency on Azure AD or any cloud provider access management is not desired?
Awesome question. Awesome question. DevPrime is agnostic of a cloud service. You don't depend on any cloud to run. You can deploy, you can save your code on GitHub, on Azure DevOps, on GitLab or Bitbucket. It's it's transparent to us, right? You can host everything everywhere. If you want to deploy your application using a different security provider, it's not a problem. See, we have multiple adapters here, and one of these adapters is the security. So if we look into the code about the security adapter, right, it's pretty empty. So from here, we can customize and apply wherever security pattern or integration you need. The code is here, is ready to be used, right? The same thing when we're talking about observability. If you want to extend the observability and use, for example, primitives, you can simply use this class and extend the integration from here, right? So you don't have to support, but you can support everything that you need from your cloud provider. I don't know if that answers your question, right? Let's go to Deepak, right? He is asking, can you explain how DevPrime integrates with existing CI/CD pipelines to streamline the deployment process of microservice? Awesome, great question too. Thanks. DevPrime behind the scenes is a .NET application. This is a traditional .NET application, right? So you will deploy this application the same way you deploy your .NET application. Build and deploy. We have some accelerators here, right? So we have tools for build and release. We have some scripts to help you run the application in Linux, for example, if you need. And we have also a Docker file here that helps you build and deploy a container image. So it's pretty straightforward deploying a .NET application, and you can integrate with any kind of CI/CD platform. right? All right, let's go to Rothy Tomar. How do Copilot and DevPrime handle database integrations for microservices, and what are the recommended patterns for ensuring data consistency and performance? Awesome. Well, DevPrime is a platform, right? We don't suggest how you manage your data, in fact, because that's a business decision. But you can change wherever is needed. Let's go back to the code and analyze something. We have adapters, and we have the state adapter. We have a repository, right? And I have a customer repository in this case. We're using MongoDB. So the accelerator created to us a by default way of receiving and converting the domain into an object to be saved on MongoDB. But you can customize wherever is needed into this layer. I can come here and change wherever is needed. This is a .NET application. So the database integration for this microservice will be a decision of the architecture team. Of course, in the perspective of a software architecture, we always recommend to don't share the same database with multiple microservices. Each microservice should have your own database, but we know that eventually that's not possible, or you are in a transitioning phase of the project, right? But that's the way. So the consistency and the performance will be handled by each microservice independently. Okay. Any other question? I don't know.
I don't see at the moment.
There's one important point to mention. What's the biggest difference between generating code with DevPrime and generating code with the traditional copilots or GPTs, right? If you go right now into any GPT and ask to give you a code with resilience, high dependency database, repository pattern, hexagonal pattern, etc., 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 none of them will be capable of delivering to you an entire solution. And even if you create a prompt that give you something similar, it's not tested, and you are not sure if this works. So DevPrime brings to the table the adapters running untested and ready to be deployed in production. So this application is ready to be deployed. We can simply run the Docker here and deploy the application direct into my Docker and eventually to a Kubernetes and etc. So in less than 30 minutes, we can build up an API and deploy to production, right? And thanks to this DPX tool, because we can talk, we can interact with the copilot behind the scenes, but receive the code very well structured and ready to be used, right? Because you don't need to take care about the other adapters. You don't need to take care about the other layers, right? And this is how DevPrime works. Well, I don't know if I'm on time, but if you want to go deeper and you want to test it by your own, I invite you to open the YouTube. We have a video there explaining how you can accelerate the software development using DevPrime, and it's pretty straightforward. Into the website also, there is a very good quick start there. So you can start right now. Just create an account, download the CLI, and start coding. It's pretty easy. Unfortunately, the the Copilot tool, right? The DPX tool is still in beta testing. We're still developing this. But if you aren't interested in testing the tool, just contact the DevPrime team and they will figure out a way and an access to you. Okay. Well, since we don't have any other questions, I would like to thank you for the opportunity and the time. It was an awesome talk.
All right, Lucas, that was absolutely great. I'm glad that you covered a few questions that we had from the chat itself. I think there were a few questions by Lucas and other guys too, and I think someone from the comments already replied. Like Raymond, maybe he's from your team, right?
Yeah, Raymond
Yeah.
is the CEO of DevPrime. He is the mind
Ooh.
behind this structure.
We
He
should
is the
have him
guy.
sometime.
Yeah, I think we should.
Yeah, I
This
mean,
guy,
we do. Yeah.
sorry, this guy is 10 years ahead of the technology, man, because he has created this technology 10 years ago, or something like that. So it's a
Wow.
very mature product.
Yeah, Mahesh, who's the founder of C Sharp Corner, right? He would love to host him, right? Because he started this C Sharp Corner like 22, 23 years back, and it's biggest community if you talk about C Sharp and .NET, right? We have like 30 million people visiting every single year on our
Yeah.
platform. So I think you both should connect sometime and let's have him on the show. With that said, anything else final thing you want to add, Lucas? I did see your call to action about this YouTube, so that was perfectly great. Do you have any kind of like a DevPrime Academy or like something like that that you would like to point to the audience? Anything like that,
Right.
learning resource?
Yeah, we have the DevPrime Academy inside the
Mm-hmm.
devprime.io website, right?
Okay.
So feel free to join us. It will be a pleasure to guide on this journey and figure out whatever is needed. Raymond also have a consulting service as a CTO as
Mm-hmm.
a service. So eventually, if
Mm-hmm.
people needs guidance on their business and the technology itself, will be a pleasure to help you guys.
Wonderful.
Right.
All right, Lucas, in that case, thank you so much for your time today. I loved your session, right? Nice way to wrap up the day. Thanks for all that you do for the community. And yeah, well, let's stay in touch and let's see how we can have more content for the C Sharp and .NET community.
Awesome. It's my pleasure
Yeah.
to be around. Thank you. And I'm waiting for the next one.
All right. See you, Lucas. Bye-bye.
See you. Bye-bye.
All right, ladies and gentlemen, that was, I think, the best session to wrap the day one of Software Architecture Conference C Sharp Corner, and why not some C Sharp and .NET session to wrap it up. So thank you so much for joining today. I see a lot of comments. I think we have had more than like 500 comments if I added from all the destinations, and still 568 people are still watching. I know there's a lot of drop on YouTube. It's about like 17, 18 now. It's already what 12:30 p.m. in India and way too late in the other Asia and China and Indonesia. It's like very late. And it's evening in Europe, so people are dropping out. But I see Twitter gets a lot of viewers. So yeah, about to all those 600 people who are watching now, thank you so much. I said them that I'm going to do a giveaway, but I think I'm not going to do a random giveaway. I'm going to give it to Ganesh, right? Ganesh has been active on this stream from last more than 8 hours. Thank you so much, Ganesh. You win something. I don't know what you win. Just DM me on Twitter, LinkedIn. You know me how to reach me out. We'll make sure that we send you some swag. So thank you so much, everyone. That was day one of Software Architecture Conference. I quickly wanted to actually share my screen and talk about day two. Day two is actually very exciting, right? Just like day one. So if you go to the conference website, if you scroll down, this is day two. You'll see a little change in the day two agenda. Actually, we will be starting a little early because we have had few more sessions added. Uh, they're already there. They're like recordings that we need to add it. Few speakers submitted their recordings because they couldn't show up today. So there will be slight change, not here, but perhaps in the beginning. So the conference will start maybe an hour or an hour and a half early. We're talking about social technical engineering. We're talking about AI architecture. We're talking about data. Microsoft Fabric is very popular these days. You'll find everyone in the Azure data talking about Microsoft Fabric, RAG, no surprise about all this AI thing we have coming up in LLMs. Then we have multi-cloud, then .NET Aspire, .NET community, they love Aspire when it comes to the architecture session. Then we have keynote by Rodrigo. Rodrigo is, I think, maybe 7-8 times Microsoft RD, and he's been to India to our conferences. So he's a very good friend to us. He's also joining from Brazil. I think Lucas is also from Brazil. So Rodrigo will be the keynote for for tomorrow. Then we have about big data case, keep it simple. I love the session title, and a lot of sessions. Then we also have day 3. So we have speakers from Viber, TikTok, Netflix, eBay. I should have written it somewhere on the website, but that is for the day 2, ladies and gentlemen, and that is for the day 1 of Software Architecture Conference, 3rd edition 2024. I'm your host, Simon. Thank you so much, everyone, for joining today. All the speakers, volunteers, and the people who are commenting, and everyone who's interacting on social media. Thank you so much. My name is Stephen Simon. I'll see you in just about 12-13 hours. Take good care of yourself, and see you soon. I'm looking for a video to play. See you soon. Bye-bye.